an introduction of what the software is. So once again, the name of the software is Palladio. We mainly focus on two things in Palladio: the management of inspection data and the study of risk-based inspection. How do we start? Once you open the software and you access to the main interface, the main interface is divided into three main sections. The top section is where you have your menus and your toolbars. We will navigate through this later on in the training. We have the dominant side of the screen, which is the graphical and information panel. That, if you notice, it is giving a graphical representation of the asset or the section of the site that we are selecting on the left side, which is the navigation panel. So for example, right now I'm selecting demo plant. I'm able to see the plot plan of my demo plant. If I open any of these folders, which are areas, and select a plant unit, this visualization will change to show me the plot plan of the plant unit that I have selected. Other than that, I will see that in the top right section, I have different drawings that are associated to this particular unit, which in this case are my different P&IDs. Okay, we will talk about how to manage P&IDs and what are the different functionalities in the software to associate P&IDs with the asset list. In the plant unit, we have different folders that correspond to asset types. So you have equipment, piping, instruments, machines, any different asset types that you will be managing inside the plant unit that you will define. For example, if we open the folder for equipment, you will see that there will be a list of equipment that are inside this plant unit. You also notice that there are different icons, and the icons, let's say, are different from each other. We are going to learn why. In fact, I can tell you right now, if the gear icon represents an equipment, if the icon is white, it means that we don't have a 3D model for the asset. If we select an equipment that has a gray icon, we will see that we have a 3D model representation of that asset. I will also show you how can we get this if necessary, and even how can we create a basic management model for our equipment inside Palladio using Palladio. So at the moment I have explained, if I click on an equipment that has a white gear icon, there will be no 3D model. No problem, because we can have other type of representations like P&IDs or even a drawing. If we have one with a gray icon, it will show us the 3D model that we have available for it. If we have one with a gray icon and a red ring, it means that we have inspection data to be able to be visualized over the model, and we can go to the detail of visualizing different measurements of thickness along this 3D model. We'll be looking into that later on in the demonstration. There are a special kind of equipment like tanks that have their own icon, and these tanks will normally, this is probably a wrong example, but normally this icon is assigned when in the data sheet you define that this equipment is a tank, and normally a storage tank. So you can manage, let's say, the tank bottom, the different shells of the tank, the rooftops, and so on. So it has a special data sheet. For piping, we have also the possibility of looking at the line list. And if you notice, something that is very important is that if you remember the slide on our philosophy, where we have a visual representation and then we access the information, the software connects the different PNIDs of the plant unit with the asset list. What do I mean by that? If I select an asset and I go to the PNID tab, I can ask the software to find the position of this asset within my PNID. So if I click the PNI browsing tool, it will zoom in to the location of the tag of my equipment. Okay. Then also, this PNID can be used to navigate on information about other assets in the drawing. So for example, if I click on this tag of this line, it will find it for me here in the navigation panel. And now all the information in these tabs corresponds to this line. So it's a bidirectional link that if you select from either the equipment list or the drawing, you will find the information for the asset. What kind of information can we find? We can find the visualization of the equipment, the PNID for the asset, the data sheet of the asset, where we can have the general design, operating, and construction data of the equipment. And for each asset type, so for each one of these main folders that you see under the P unit, the data sheet is going to be different because, of course, you manage different data for equipment and for piping, and whichever is common, it will be there as well. So on the data sheet, you can manage all that information. We can even, we will see later also that in the data sheet, we can define the RBI components to divide an asset in different parts. That is helpful for the analysis in the future for RBI, especially when the fluid and the operating conditions of certain sections of the same equipment are under different conditions. We also, it's important to notice that we have an attachment repository. So all the files that we want to attach for this particular asset, we can attach here. We can have if I double click on any of the files, I'm able to open it and visualize the document. And we can also have files of any format. It can be PDF, DWGs, images, Excel files, Word files, any format that you want. In terms of the inspections, we have the possibility of collecting in a chronological order all the different inspections that have been performed in the asset that is going to be managed. So it could be, for example, a visual inspection where we have a collection of pictures of a visual inspection with a description in the title. We can attach, let's say, the compliance checklist of the asset and, let's say, the results of the inspection. We can have inspections such as thickness inspection, where we can declare the different CMLs or conditioning monitoring locations and register at a particular date by a particular surveying company using a particular instrument what were the measurements captured during the inspection on each one of these dates, on each one of these CMLs, sorry. One of the benefits of having these measurements collected over time is that I will show you in a different example that we can access a corrosion trend. And this corrosion trend is showing us how the thickness is changing over time. And this allows the software to calculate through a flash report the corrosion rate, short-term and long-term, and the expiry date, short-term and long-term. We will look into this later in the training. Right now, just for you to, I know I'm explaining a lot of things now. I just want to give you a quick overview of what you can expect, and then we go into detail in the process. We have a section also for reports. The reports allow us to insert different inspection or maintenance reports indicating what types of inspections were defined. We can even have the number of companies that are working in our facility with all their particular details. We can indicate who was the inspector. We can load their certificates here as a document and have also all their details. And we can, from the report, extract notes, extract short-term actions and long-term actions. And we can define a date for those short-term and long-term actions that will be connected directly to the due dates or the scheduler, where we register the last time we perform an operation of a certain type, and we can define a frequency if permitted, or if not, we just define the next date in which this one needs to happen. We can have a technical drawing of the asset. We can even have, let's say, a picture. If we don't have the mechanical drawing, it's very easy to insert the image. I'll show you this when we navigate on this tab. And finally, we will be able to see, for example, if we have the 3D model of this particular plant unit, this plot plan will become the ground of the model. And on top of the plot plan, we have the management 3D model that is also like the P&IDs linked with our asset hierarchy. So if I select a particular asset in the model, I understand what is the name of the asset, and I can navigate through the isolated 3D model, the position of the asset in the P&ID, the datasheet, the attachment, the inspection history, and so on. I will show you later, because I don't have in this installation the point cloud data, but we can load laser scanning around the 3D model so that we have a as-is representation of the asset if needed. This point cloud data allows me to take measurements from point to point and to overlap my existing management model over, let's say, a recently acquired scan. That is quite useful to keep an updated representation of the facility if you are interested on 3D models. This is, let's say, a quick overview of the IDMS side. Then we have the RBI results also for the asset. We can have this here, but we will look into this tomorrow in terms of how these results get connected to a particular asset in Palladio. So with this quick introduction, also I would like to indicate that here on applications, we have the RBI management side, where is where you can find the tool to create your RBI studies, and you can see that there is a place where all the data that is used for the RBI analysis is stored. It is divided in different sections of the result, the basic data used, the data used for each damage mechanism, and the calculation of the consequence, either financial or by area. And also we have the inspection plan and the inventory mass. We'll look into this on the training tomorrow, I expect. So this is the interface just to see the data that has been used. We have 3 calculators one for qualitative RBI inspections, one for quantitative with a consequence area, and one for quantitative with a financial consequence. So when we select an asset, we can select a calculator, and it will open the Palladio RBI section that, let's say, is essentially an environment for you to calculate the main components of an RBI inspection that include the probability of failure calculation and the consequence of failure calculation. So in order to do that, you have these tabs, the probability of failure section, with all the different questions to be answered, the consequence area section. In the general section, you will define which are the applicable damage mechanisms for the asset. And also in the inspection plan, you will evaluate what was the actual risk result, what does the future without an inspection look like, what is the future with a suggested inspection will look like in terms of risk. And you can define the inspection, the required effectiveness of inspection based on your calculated risk, and what will be the percentage of coverage and type of inspection that you need to perform based on the RBI analysis. So this is essentially what we are going to be looking at. So to begin with, I'm going to explain you how to start using the software. To start using the software, it is very important on any asset integrity management activity. It is very important to define the asset list. It is very important to understand what is that we are going to manage. So the first step in Palladio is to be able to populate the navigation panel that contains the plant, that in this case is associated, the plant or the site is associated with the license that you purchased. So most likely your license will say PTKPI instead of demo. And under your site, you can define different plant units and group those plant units into folders if you need to. You don't have to. You can create plant units directly under your site, and inside those plant units, like we saw before, like this one, this is an icon for a plant unit. When we access one of the plant units, you will have different folders for the asset types that you manage inside the unit. Okay, so let's have a look into how do we create a plant unit. In order to create a plant unit, we need to go to the section tables. In the menu tables, there is a section called data sheets, and in data sheets we have P units. So I repeat, we go on tables, data sheets, and then P units. Once we arrive here and we click there, we have this table that, or this window that shows us all the different plant units that we are managing under our site. Yeah. Please, in your case, it might be that this has no plant units yet, and it's okay. If this table is empty, it doesn't matter. We can define new plant units using the same procedure I'm going to teach you now. From this window, we can click on the add icon, that is this new icon here, the paper looking icon. And when we click add, we will have one row in our table on which the first column is asking me for the name of the plant unit. So I'm going to call my plant unit PT KPI training. I can give a description of this unit. This is optional. You can give a description. And these are the two basic fields that you need to worry about in this table. The rest is not used because it's to be able to have access to this unit to other modules that you don't have, that includes sewerage and cathodic protection for offshore facilities. So don't worry about it. Just in order for you to create a plant unit, define the name and give it a description. After you define the name and give it a description, what it is important is to define what types of assets will you be managing inside the plant unit. So here on the right side, you have the different asset types that you can manage. So equipment, piping, instruments, pressure safety valves, for example. Let's say you will have to check in the boxes of the asset types that you will like to manage. In this case, I'm going to select these four. And the other fields, what they mean is on the type, you can, if you like, you can define what type of area, what type of plant unit this is. If it's, let's say, a cracking unit or a distillation unit. And if you don't have a type on this list, first of all, it's not mandatory to define a type. And second, if you right-click on the white field, you can create a new type if necessary and then define it. I'm not going to give it a type. Notes are also not a mandatory field, but I can insert something for an example. And on area, what it means is that if we have different folders under our site, we can assign that the plant unit that we are creating goes inside of any of the available folders. How do I see the available folders? Here on area, I can see, as you can see, we have training, gas upstream, oil refining and petrochemical, oil upstream, which are all the different names that we have here under our site. I'm going to leave it outside of any folder. I'm not just going to put it directly under my site. And the other fields are also optional, like who is the owner of the plant, maybe name and of the facility and the sub-facility, and that's it. So the basic requirements are give it a name, assign the asset types that you would like to manage, and that's it. After you define those two, which are the bare minimum requirements, you can click Save and exit this window. And you can see that our PT KPI training unit is directly under our site. Again, I could have put it inside of a folder, but I don't think it's necessary. If you would like to create a folder, that's what I will show you next. So if you have a lot of plant units and you would like to group them in different folders, you can right-click over the demo, and there will be an option on the last section that says organize plant units into folders. If we select this, we will be able to click on the edit button and create a new folder here. I can name this I can give a name to my folder and I can save it. So now you can see that under my site, I have a folder called PT KPI Area 1. Another thing I can do from here is that I can assign the plant unit to go into my folder. So if I save, I have my folder here, sorry, here. I can edit and then drag and drop inside the folder, then save. Now you see that the unit is no longer here, it's inside my folder. So I have a folder called PTKPI Area 1, and inside that folder I have a plant unit that is my training unit. Okay. So just as a quick recap, what we have learned now is under my site, I can create a folder by right-clicking on the site and clicking on Organize Plant Units into Folder. Click Edit, and then New. Give it a name and save. If I would like to drag an existing plant unit into the folder, I just drag and drop. In order to create a plant unit, I go to Tables, Data Sheets, P Units, and by using the New button here, I can give the name of my plant unit, assign what type of assets I will manage, and then save. If I have an existing folder and I am creating a plant unit, you will see that, for example, on the PTKPI training unit, here on the area, you can assign to which folder you would like it to be part of if you're creating it and you already have the folder. In our case, in our demonstration, we created the unit before we created the folder, so we moved it from the folder section. But both options are valid. Okay. What is the next step? So we are going more into detail. We have our site, we have a folder. Inside the folder, we have a plant unit. And if I double click on this plant unit, I can see different folders that the same way I set up on the tables, it has the asset types that I will manage inside that unit. So as you can see, our equipment list at this moment is 0. Our piping is 0, instrument 0, pressure safety valve 0. So how do we start creating an asset? So for example, for pressure safety valves, for any asset actually, you can right click on the folder and click on New Sheet. In this case, I'm right clicking on pressure safety valve. As you can see, the software will open a window with a template for the data sheet or the specifications of the valve that we are declaring. It also shows that the only mandatory field to declare the asset or to create the asset is the code or the name of the valve. So for example, if I call it PSV 001, this is all the information that I need. If you want, you can fill up the different information about the valve in the other fields, but it's not mandatory. So just to declare the valve, you can give the name and then press save. Now you can see that inside our pressure safety valves folder, we have our asset. The same for piping. In piping, if you right click, you will go to new line sheet. There is sometimes some confusion about create line number sheet and new line sheet. Please use new line sheet. This one is for groups of line codes, but it's not often used. I recommend you to go for the new line sheet option. So if you click on new line sheet, same, you will have the space for different fields of information of the line that you are creating. And here, the only mandatory field is in yellow, which is the line code. So here we can say the name of the line that we are declaring. And then when we save, we will have our asset right here. Same for equipment, but equipment has 2 steps. So every other asset, you right click, new, give the name, and that's it. For equipment, it's a bit different because you right click, you go on new sheet, you give the name, that is the yellow field. So for example, exchanger 2693. But since you are interested on RBI, this is an important step. You need to go to the section construction data, RBI components, and you will define the parts of this exchanger that you will need to analyze in RBI. I recommend you do that at the moment of creating the asset so that you can do this. You don't have to go back at the moment of doing your RBI analysis. So, for example, the exchanger, we can define that it has 2 components. You can click edit, go to the component description and say, I want to define the shell side and also the tubes side. I can also say that if I want, I can populate this information, but it's not mandatory. I can save, and we can see that our asset has here the name of our equipment. And if I expand, I can see that it has 2 chambers or 2 RBI components, which are the shell side and the tube side. Sometimes this expansion is not shown, and it's because on the display menu, you need to have activated the RBI option. If not, it will just show like this. You will not be able to expand and see the RBI parts. But if you want to see them, you just select on RBI, and then you will be able to expand to the declared components. Okay. Okay, so that is how you will define an asset inside Palladio. So we have learned how to do an area folder, a plant unit.
Sir, Alberto.
Yes.
If we already create the exchanger, but we haven't put in the element list, how do we add the element list in already created of exchanger?
Okay, so that's a good question. Let me demonstrate. So for example, let's say you have an equipment like this one, let's say E, and that's all you have. It doesn't have any parts, right? You will like to define them. No problem. What you do is you can, on the existing equipment, you right click and go to properties. And then it will open the datasheet. So it's the same as if at the moment of the creation is the same datasheet. And you can click edit and go to construction data, RBI components, click new, and then you can define the different parts. To create one part, you click on new. To create the second one, you click on this new icon again, define the name, and then you can save. You can see that once we save and exit, let me refresh. Now both of them have the definition of the parts for shell side and tube side. For piping, it's not necessary to do this. Also, it's not necessary to do it for PSV. Only for equipment. Yeah. Okay. At the moment, do you have any other questions?
Mr. Alberto, I already add the component in the output RBI component that you explained earlier, but in the P unit list it doesn't show. How do we show the added component list?
Okay. So if it doesn't show in the here, it's because you need to go to display and activate the option RBI. Try that.
Sorry, where do the menu is to activate the RBI?
Yeah, I have it on my screen right now. You go to display menu and then select the option RBI. I'll show you. Display RBI. It has to have this check mark, and then you can see the parts under the hierarchy.
Display menu. Okay.
Okay. All right. You're welcome. Okay. So this is the way, let's say, you will manually add an asset. But sometimes it is important to be able to add many assets at the same time. Especially, let's say, for piping, we know there are a lot of line lists. It's a long line list, and to do one by one could take some time. So we have also the possibility of loading the asset list using Excel. Okay, so this is what I would like to show you next. So how does that work? We have a section of the software that is called the items list. The items list is a very important section because it is the section in which we can create tables extracting all different data of the assets that we have declared. And we can also export this to Excel, fill it up in Excel, and import to the platform so that we can populate the datasheet, for example, faster, or that we can create more assets, many assets at the same time inside the software. So if I click on the item list button, it will open this particular window. And this window is in order to explore the different information that I have on the different plant units that I am managing under my site. So for example, we are looking at the name of the unit that I created is PTKPI Training Unit. So I'm gonna look for that here on the left side, TKPI Training Unit. And as you can see, here on the top right, we have all the different asset types that we have inside that we could have inside the units. So for each asset type, there will be a data template. For example, right now I am selecting equipment, so I can see the two equipments that we have declared that are these two exchangers that you can also see here. Yeah. For example, if I change to line to piping, sorry, in piping I will be able to see the one line that I defined, that is this one. And if I go to PSV, I will be able to see the PSV that we defined here. So why is this important? Because let's start with piping. When we are looking at piping, what I can do is, let's say I have many more lines to load and I don't want to do one by one. What I can do is I can select the plant unit under the items list menu, click on asset type piping, and then here I have an option that says export data. So I'm going to click there, and the software is going to ask me if I would like to save this as an Excel file, and I'm going to say yes. And then I'm going to call it piping PTKPI. Any name will do. Save it somewhere I can find it in my desktop, for example, and I'm gonna open the file. So once the file opens, it looks like this. Okay, and what it is a table that in which we can declare the names of all our missing lines. So, for example, let's say I would like to create. I have already a line list in Excel. I can copy and paste it on column C. In column C is where you have the name of the asset. So I will. Let me see what happens. No, it will be the same. So gonna copy and paste this and just change a bit of the line number. And I'm gonna do a few of these, but I hope you get the idea that here you can paste a column already of all the line names that you have. And I don't have a line list with me, so I'm just making an example where what I'm doing is that I'm creating 3 more lines, 4 more lines. And I would like to change the number a bit so that they are different from each other. Okay, so we had one existing line, and I've created 5 more. Yeah. What do we need as a bare minimum? The name. That's it. Just the name. This code, you don't have to worry about it because this code is assigned automatically by the software. The only thing that is a bit of a manual step that you need to do if you're going to use this functionality is that this column A, this cell here, this description that says Valori, you need to drag it until the extension of your line list. So here, let's say at the end of my last line, I drag and drop this, and now I can save. So I can fill up other information if I want, but let's just for now, let's work with the name. I'm gonna save this, exit. And now if I come back here and click on import, I can select my Excel file, click open, and the software will tell me, do you want to start loading the data? I will say yes. And here we have an issue on the way I named it because it is not detecting the let's say the quotation mark symbol. So let me modify that here. Okay. Okay, so what I've done is I have added a few assets here. In fact, I'm gonna refresh, come back in. I have now 2 equipment, 24 lines, and 10 pressure safety valves. So what would be next is on some of these assets, you will need to populate probably on the IDMS some information. Before we get into that, I would like to show you one more thing that could be useful for you in the RBI side of things. That is how to create circuits or corrosion loops, for example. So you can group some of these assets to make them a corrosion loop, and you do that under the system or circuits section. If we go here, we will be able to see that I can create systems of different types. It's a different visualization from the plant unit. And what we can do is go to circuits management, click on new, and name our corrosion loop, for example. And give it a description. We can even assign a color to it. I will explain why later, because we can mark these over PNIDs. For now, let's say get this color and we save.
Sorry, sir. How do we get to the system? I kind of missed out earlier.
Sorry, say that again.
Yeah, I kind of missed out on how to get to the corrosion loop system. Can you show it
Yes,
again?
Of course, no problem. So basically, sorry, let me save this and exit. We were here, right? We were inside our plant unit. We were looking at our equipment and piping that we created. And this is under the plant units section. So I moved to this section here. In your installation, it should be called system or circuits, one of the two. And when you click on this, you can, on where it says systems on the top, you can right click and go to circuits management. Here, what I did was I pressed new and I created a name of a system that is called corrosion loop PTKPI, and I gave it a description and assigned a color. What am I going to do with this? From here, now that I have created that, I can select it here on the navigation panel and go to datasheet. In datasheet, I can click edit and I can declare that this is a corrosion loop. There are different types of systems, but let's say this one is a corrosion loop. I can indicate from which plant units I'm going to retrieve the assets on this corrosion loop. Like, for example, in our case, would be this one, the PTKPI training unit. And after that, I can go here on item type to say, okay, these are the asset types that I want to explore. For example, I would like from my PTKPI training unit, I would like to select a few piping that is part of this corrosion loop. I select piping and then go to item selection, and you can see that we can find all the list of piping that we have created on our unit, and we can select the ones that are part of this corrosion loop. For example, I can say that the one with insulation is part of it, and I can also change my asset type to PSV and say, okay, PSV1 is also part of this corrosion loop. And I can go also to equipment and say exchanger 2693 is also part of this corrosion loop. So essentially, you will be adding the items that that are part of this specific corrosion loop. After you declare the list of items that are part of the corrosion loop, you can save, and the corrosion loop has been created. That is all. You can go back to your plant units, and I will show you later how you can use those corrosion loops for assessments of RBI when we get into the RBI topic. So far, we have created our folder, created our unit. Inside of our unit, we have different asset types. Inside those asset types, we have the different list of assets that we're going to manage. And we went even further in terms of populating the RBI parts for some of the equipment. Another important thing that you might need is to fill up the data sheet a bit more on some of the assets. I want to be very clear on something here, and is that at the moment of performing the RBI assessment, the RBI calculator has fields to input everything from scratch. But also, you have the option to import some of the fields that have been filled in the datasheet to be imported into the RBI analysis. This is optional. This is not mandatory. So it's not that you need to populate the datasheet in order to do your RBI analysis, because the RBI tool has its own fields to populate the information directly. That's why our solution can be communicated between RBI and IDMS, or it can be an RBI as a standalone, or an IDMS as a standalone. But let me show you what different things we can populate on the datasheet, and how much of that can be imported into RBI later. So just to give you an example, I'm going to select this equipment, and to populate the datasheet, we have two options. We can go directly to the tab datasheet here, where we can see the datasheet, or we can right click and go to properties, which it opens it in a window, in a separate window that you can move to your second monitor, or place it anywhere else in case you need that flexibility. For example, I am going to show you here in RBI management. We have an option that is this one here, that is import data from the datasheet. And when that happens, it indicates us which are the fields that it will bring in consideration during the RBI calculation. So I'm going to show you that for this exchanger, for example, at the moment of performing an RBI analysis, it is important to define the RBI parts. We have already defined that. For each one of those RBI parts, for RBI analysis, we need to understand what type of equipment is the one that we are managing. So here on equipment type, I'm going to click edit, then on equipment type, I'm going to define that this is a heat exchanger. As you can see, when I define that this is a heat exchanger, the equipment type on the different RBI parts gets defined as a heat exchanger. And that allows me to populate the component type for each one of these parts. So for example, I can click here and I can define that the component type is on the first one is the shell side of the exchanger, and the geometry type is a cylindrical shell. And on the tube side, I can say that is the tube side of the exchanger, and that is also a cylindrical shell. So we have defined the general equipment type of the exchanger that is corresponding to this field, the component type that is mostly related to the RBI representation of the part, and then the type of geometry that is also a question in the RBI analysis. The next thing is, for each one of these, there will be a material. So it is important to understand where is this coming from. So each facility will have different materials, of course. In RBI, according to API 581, there is a list of material families that you need to declare. So it doesn't matter what you name the material, it needs to be related to an RBI, an API 581 material family at the moment of performing the analysis. So which are those families declared on API 581? We can see that either on the calculation screen of the RBI, or we can go to tables, materials, and then go to base materials. In base materials is where the facility will list the names of the materials that they manage in their assets. It can be related to a family. There is a different table to declare a family of materials. Also, notice that there is a section here that it says materials for RBI 581. So when I select a material, I can declare, these are the different options that we need to classify under API 581. Is the material that I'm managing carbon steel, low alloy steel, ferritic stainless steel, austenitic stainless steel, or nickel alloy? These are the options. And some of them, like for example, austenitic stainless steel, will require a type and I think it's a type and a class. So they will tell you on the dropdown which are the possible ones, and then you will select the appropriate option. So, for example, in this case, I am doing ASI 1065 UNS G10650, and I am saying that this name that I have created, which is a text field that I can name whatever I want, is related for RBI purposes to this material category. So from this table of materials that I define first at the beginning of my project, I make a relation with the material type for RBI. And if I do that, here on materials, I can select the name, and it will understand what material type I am using for the analysis. So it will define the material for each one of the components. The next, let's say the next field that we can be useful for the RBI, I'm gonna save our progress here, is the installation date of the asset. So in the data sheet, the installation date would be here in the operating starting year. So I'm gonna say, for example, that this asset was in 2005. And then it will also ask me information about, in RBI, we are going to consider also things like the volume. So the volume is something that we can define here here under the design data in this field called capacity. So in capacity, we can define the volume. So we can say that the capacity is in meters cubed. So okay. And then this will can associate it to shell side and the tube side. We can also populate values in the data sheet, such as the maximum temperature. Like, for example, here. We can say it's 150. The design temperature would be under design data. The operating temperature will be under operating data. So let's say and then the operating pressure will be also here. Maximum pressure will be under design. And we also have information about the yields. We need information about the yield strength and the tensile strength. This is related to the material selection we have selected here. So if I go back to the tables, you can see that on the materials table, in the base materials, we can predefine the tensile strength and the yield strength for a particular material. And then the software will use these values at the moment of the RBI analysis if that is what we would like to insert or import from the IDMS. We also have the section for in general data. We can define if the let me. Okay. That is here. Yeah. So there are questions from the API 581, including questions about sometimes the type of insulation, whether or not the asset is insulated. We can mark it here. If it has a lining or cladding, we can indicate here. And also coating, for example. And if for the questions about a post-weld heat treatment, we have a section to indicate that. That is here in the standard. We can say if the heat treatment was performed, we can say yes, and this kind of information can also be assigned to the RBI later automatically. For the general data, we can say that on the design data, we can specify also the fluid. So we have a fluid table from which you can define which fluid is going through the asset. And same as the materials, whichever fluid we name here, we can define according to RBI API 581, which one is the representative fluid for RBI, and if it has some type of toxicity. And this information will be automatically uploaded at the moment of doing the RBI analysis. So we can select a representative fluid based on API 581. Here you have all the types that can be related to the fluid that we have selected now. And then we can define if it has a toxicity type. Okay. So when we select the fluid, it will be there in the datasheet. We can bring in this type of information. These are, let's say, the ones that in the datasheet you can import automatically into RBI consideration, but it's not mandatory. Again, it's just for you to have in mind. These are the fields that RBI will consider coming from the datasheet. Additional to that, we have many other fields for additional information. Most of them are free text fields, so you can use under your own interpretation, giving the description here of the general description of the asset, or if you want to indicate what is the service of this equipment, you want to give a description on text of what plant section this is located. None of this is mandatory. I wouldn't worry too much about the content of this, but yes, the fields are there in case that you want to include this information. It is not used anywhere else. It's just a text field. Only the fields that I mentioned before this are the ones that can be retrieved automatically into RBI. So the rest are additional components. In terms of adding information to the datasheet, we can do it directly through the fields here. Or if you remember, we can, under the items list, we can also go to our plant unit.
Sorry, Alberto.
Yes.
I have one question. Maybe can you back to the component, your tab construction data, your construction data.
Yes.
But what the difference? Construction data or operational data maybe. Sorry. Or design data. Sorry. Design.
Okay.
Sorry. What the difference of painted painted and outer coat? Maybe on the construction data I see before.
This here?
No. Yes. Yeah. What is the difference of painted and outer coat?
You mean what is the difference between paint and coating?
Yes.
I'm not the best person to tell you the difference, but normally it depends on what is the practice of. Let me check here what information I have of those fields.
Okay.
Yeah, they are
same treatment.
Yeah, I don't know the difference between coating and painting, but let's say I can share with you that for RBI, the one that is considered is the term coating. So if for you it has no let's say it can be terms that are used interchangeably. I recommend you to define it as coating if the asset is painted, because this is the one that can be imported into RBI. But I will check with my colleagues. I am not too sure of what is the difference between these two fields. I will make sure to let you know tomorrow.
Okay, Alberto. Thanks.
Okay. Yeah. Now in the data sheet we have a few options. So some of the options are, if you click edit, you can fill up any of the empty fields. If you click save, you will save those changes. If you click delete, you will delete the asset. This one is to cancel a modification. This one is to print the data sheet. Let's say like a PDF, some of the basic information of the data sheet. This one is not used. Attachments is to, on the datasheet field, attach some files that are useful for us. For example, the U1 form, like the manufacturer report, the actual datasheet in PDF, if you have it, any field that is related to the design, operation, or construction data of the asset, you can attach here. And I will teach you how to attach files. This is to understand what are the pressure safety valves that are protecting this equipment. To assign these, you need to do it through the pressure safety valve list. The same for bursting discs and other safety devices. Here you will also see which instruments are connected to this particular equipment. And here you can add an additional component that is connected to the asset, but is a generic item. I don't think this is very used very frequently, but let me do an example. Here on safety devices, I can say that, for example, PSV002, if I select it, I will see the data sheet, and I can go to the section. See here, we can say that the installation is on a equipment, and or we can go here on the equipment and select directly on which equipment and which section of the equipment this PSV is being used for protection. So if I click select and then save, and I go back to my equipment, I should be able to access the PSV list. And as you can see, it shows me that PSV002 is protecting my equipment. Using the same process, you can assign a bursting disk or an instrument that you have declared and make some sort of connection with the equipment. This is important on the due dates, because when you program activities for the asset, it will require to check in parallel the activities that need to be planned for the safety devices. So you can see that in the due dates tab for a particular asset, you will have the list of activities that need to be performed for the main equipment, but in parallel, you can see the activities that need to be performed for the safety device that is connected to the equipment. We'll look into this when we review the scheduler section. Okay. So filling up the data sheet, once again, is you right-click on the asset, go to Properties, press the Edit button, and then fill up the different fields as much as you consider necessary. Again, not a mandatory activity. Some of our customers only define the name of the asset and then attach the data sheet directly. I recommend you to extract in the datasheet the information that is useful for importing in other options of the software, like the ones I described for RBI. Later, at the end of the training, I will share a document with you that reminds where are these, which are the fields of the datasheet that are connected to the RBI application, and where to find them, so that you can focus on those, and then the rest, just consider them as optional. Okay. Now I would like to show you how to attach things. I think it's important that, let's say, even in the datasheet section, we can attach a PDF with the PDF form of the datasheet if we have it. So how to do that? We open the datasheet, for example, we click Edit, and when we click Edit, this icon called Attachments will become active. So once this icon is active, I can click there and click on New or Add. What is going to happen here is that I'm going to have this window with different options. The first option is, first I need to find the document that I want to attach. And we have two options. I can attach a document by clicking on the three dots, or I can select a folder to attach an entire folder on this datasheet section. Let's say I will find a document. So when I click the three dots, it opens to navigate my computer. And let me see. Okay. Sorry, 1 second. Let me find a good example. Okay, for example, I found a U1 form template, so I'm going to use that as an example. So in the description, I can say this is the datasheet for exchanger E2693. This is a free text. You can use any description you want. The reference date can be either the date in which you attach, so today, or the date in which the document was issued. Depends on what you prefer. And you can have different types of attachment. You can indicate this is a technical document or this is part of a survey. So in this case, it's technical. You can have groups also. This is to group attachments by different categories. In this case, this is not a mechanical drawing. I'm not going to associate it to it. And the other fields are not mandatory. They are, location is for some of our customers require this field because they wanted to, sometimes they have a printed version of this document or this book, and they want to indicate what is the code to find it on their library, for example, in let's say the physical environment. And also if they have a data management system number, or if this is coming from a specific contractor or a vendor, they can insert their codes, but this is something not mandatory. So only the mandatory fields are find your document, give it a description, and a date. That's all. After that, you click OK, and the document is attached. Once it is attached, you can open, and you can see the data sheet here. Okay. So that's how you will attach any file. There are many places in Palladio in which you can attach things. So not only in the data sheet, but in the inspections, in the reports, sometimes in the RBI. Many places have this attachment icon. You will see later. And it is important that we look at this tab here. So far for an asset, we have seen the data sheet. Now we're moving to attachments. As you can see, when I go to the attachments, here we can see the file that we just attached. And in the case of other assets, example, there will be many attachments that are coming from different places. So for example, you can see that if the attachment is coming from the datasheet section, it will have here on the column type, it will have the same icon as the datasheet tab. If it is coming from a flange of the 3D model, it will have the flange icon. If it's coming from the shell of the 3D model, it will have the shell icon. If it's coming from an inspection, it will have the this survey icon. And if it's coming from a report, it will have the reports icon. This one is attached to even a welding, so it has its own icon as well. So in other words, we can have the list of all the files that belong to the asset that, or the equipment in this case, that we are exploring or visualizing. With these attachments, we can consider files of many different formats. So it could be a picture, it could be a DWG file, a PDF, a Word, an Excel, anything. It will open with the software that is in the PC that you are running Palladio in. So if you have a software that can open the file that is attached, it will open on that software, no problem. Like for example, if I open this DWG, it will open in AutoCAD for me. Or if I open the PDF, it will open in Acrobat in my case. It is important for you to know that once we get multiple files, we need tools to search. So sometimes here, this is useful, the search bar. You can, for example, if I type inspection, then go for search, it will find the file that has an inspection as part of the description or the file name. If you click again, if there is another one also with inspection, it will be highlighting the two that have this description. You can also look into the different ways of searching things. So far, we have seen how to declare the names of the assets. We have seen how to attach information to those assets and fill up some of the fields in the datasheet. So it's a good opportunity to say, okay, if I have many assets, how do I look for a specific one among all the assets that I have? So there are a few options in the software. One of them is the search tool here on the top left. If I click search, I can, here on the name field, I can specify a particular piece of the name of the asset or the exact name of the asset that I'm looking for. So if I have only, for example, if we remember, if I'm gonna go back to the asset that we created as an example, here on piping, I have these 24 lines that I created earlier with the Excel file. From these assets, let's say I didn't remember what is my line number or even how to find this asset. I remember that it was 10-inch and that the fluid was DCPD. I can insert part of that name here. For example, 10-inch DCPD. And then click search. And it will find for me all the lines that have that are matching that description. It will tell me on which plant unit are those lines, what type of asset are we talking about, and it will give me the register number and the serial number. Let's say that I remember pieces that are not as a consequent, like a continuous string. I can say, okay, I remember it's a 10-inch line, and I remember that the piping class is 150 CS. So since I don't remember what's in between that information, I can use this. That is important for you to learn is a placeholder, and it's replaced by a percentage sign. So if I say I remember it's 10 inches something 150 CS, this percentage sign can take, in this case, replace the missing characters on the string that are dash, DCPD, dash. So if I find, in this case, it will have the same finding because it is finding all the 150 CS lines that I have in my demo plant. So I can restrict this also to a specific plant unit. For example, I can say, oh, actually, I'm only interested in looking into PT KPI training. I don't want it to look for PT KPI 12 or PT KPI IMV or all these other ones that I have. I just want to look for it in one specific plant unit. So I can restrict my search to a specific plant unit. If I search again, you will see that it will only show lines under this description with PT KPI training unit. I can also say, okay, I'm only interested in piping. And we will have only piping. So this is the tool that you will like to use in case that you want to search for an asset where you remember the name or part of the name. Okay. After this, there are much easier ways to look for things inside Palladio. And if you remember, as part of the basic philosophy, one of the main ways to reduce time of search is using visual representations. So if I have a PNID and I am navigating to the PNID, and I know the position of my asset in the PNID, I can click on the tag and find all the information about this asset using my PNID. If I have a 3D model and I know the position of my asset in the model, I can click on it and find all the information of that asset from my 3D model. So visual representations allow us to find things easier, in an easier way, and reduce the time of finding. How do we do this? First, we need to go to a unit that has some PNIDs loaded. In case that you will like PNIDs to be loaded into your system and connected to the navigation panel or the asset list, it is something that Antea can offer as a service. And same with the loading of 3D models. If you have an existing 3D model, we can convert it into our proprietary format and load it to your system so that it can be linked to your navigation panel if needed. How does this look like? When we select a unit, remember at the beginning of the training, I was showing you that on the right side you have PNIDs. These PNIDs can be displayed by going here on the PNI tab and clicking on the different drawings in the list. There is information about these drawings, like for example, what is the description and the name of the drawing, on which revision is this PNIDs, how many red lines does the PNID have, and so we can visualize this information from the table and select the different drawings. If I start zooming in and browsing around my drawing, I can click on an asset, and as you can see in the navigation panel, it immediately understands where it is. I can do the opposite. If I'm looking at my asset list and I click on it, it will find the position of the line that I have selected here. And this is important because when we look at a line, then all the information about this line will be immediately available through me to the different tabs, whether it is in 2D, like having this particular sketch coming from the actual management 3D model, or we can have the position of the line in the PNID, we can have the data sheet of the line, we can have the attachments for it, the inspection history, and all the other information for the asset. If we are looking at the 3D model of the site, I don't need to know the name of the asset. I just need to know where it is. Could be another way to search for things. I'm looking at my model and I want to know, to which line does this elbow belong to? I just click on the elbow and it will tell me that this elbow is part of this line. If I click on this vessel here, it will tell me that the name of this vessel is this tag right here. So so far we have learned how to define our assets, how to make them part of a plant unit, how to search for the assets through different types of search, like text search, drawing search, or model search. We know how to load the attachment, and the next step would be to make you familiar with something that could be useful for you, which is the functionalities of the PNID tab. So if we look into the most basic graphical representation that we can have of the process flow of our facility, we have the PFDs and we have the PNIDs.
Sorry, Mr. Alberto.
Yes.
Before we move to the next topic, can I ask a question?
Of course, please go ahead.
We kind of miss how to regroup the newly created plant unit datasheet into folders. Can you show it again? Just like this PT KPI training unit, how do we move it into PT KPI area 1?
Okay, no problem. So let me create a plant unit outside of the folders to show you really quickly. Okay, so I have this plant unit outside of every folder, correct? Test move P unit. If I want to move this to, for example, PT KPI area 1, I have two ways to do it. One is I can go here and organize P units into folders. So right click on the site, then organize plant units into folders. And then I click edit, and I can drag and drop this the P unit that I want to move into the folder that I want to move it to. So I can drag and drop here. Then I save. And as you can see, the plant unit has been moved inside the folder.
Okay, that's clear.
Okay. The other way to do it is from the tables, datasheet, and P units side. We look for the name of the plant unit. In this case, the test move P unit. Press edit, and here on the area section, I see the names of all the folders. So I just make sure to select the one in which I would like to move it to. In this case, PT KPI area 1, and save. That will also result into moving the plant unit inside the folder. This is the two ways to move it.
Okay, sir.
Okay.
Sorry, sir.
Yes.
Then how do we delete the item, sir?
How do we erase an item?
How do we delete the unit item?
Sorry, say it one more time. I couldn't hear you.
Okay. How do we delete the unit item?
Okay. To delete a plant unit, for example, this one that we just created, what you can do is go to tables, datasheets, and plant units. And here you select the plant unit you want to delete. For example, this one. Edit. And then there is a delete button here. You save. And it's gone.
Okay, thank you, sir.
Okay, welcome. Okay, any other questions so far?
Also, how do we create new site if we want to edit new site?
Well, you can create folders under the site, but the site is one site. So basically, the license is assigned to one site only.
Oh, okay.
Okay. Let's say that after this, what I would like to show you is about the different drawings that come with the site, or that come with the plant units, and eventually how are those connected to the equipment or the assets that you're managing. When you have, let's say, a plant unit, we can load for you the different drawings or PNIDs that you have as a service. What we achieve with this is that we can load the drawing and automatically have a connection with the list of assets. In in case that you have the drawings loaded and you want to create a connection between a newly creating asset and the drawing by yourself manually, you can do it too. So I will show you how to do that. So for example, this in Palladio, we have a proprietary format to display a vectorized image of the DWG for the PNID. So from the client, we receive the DWG drawing with the PNID or the PFD, and then we convert it into a format that is called SB2, as you can see here at the end of the file name. After these drawings are loaded, they will be associated or loaded to a particular plant unit. And when you access that plant unit, you will be able to see all the drawings that were loaded for that unit. In your case, this will be empty until, let's say, you decide to load some drawings. We can convert and load for you if you require. So how do we make a connection between an asset in the drawing and an asset in the asset list? Whenever I create an asset, this asset, if I go to the PNID tab, it shows empty because there is no association with any drawing. So if I go to the plant unit level and I select any of the drawings, for example, this one, and let's say I'm gonna assume that this asset here is B688. I know the tag is different, but actually I can make something that makes more sense. So let me find that again. Okay. Okay. Let's say I have an asset that is this here. I don't have a tag for it. So I'm going to create that item. Okay, so now this asset is here, but I don't have a connection to its PNID. Let me go back to that drawing by going to the plant unit and finding the drawing. Then I will zoom into the location. And then I can say, I have this menu here that has different options. And one of those options is new area. In order to see these icons, you need to make sure that the PNI browsing tool is active, because look what happens if I deactivate it. Those options are no longer there. So we need to make sure that this is active. And then I can zoom in to the location of the tag in the drawing and click on the option new area. When I click on the option new area, I have different shapes that can help me box this particular section. In this case, I can use a rectangle. So I'm gonna click, move my mouse, and click again to box the tag. Then the idea is that the software will say, okay, for this particular drawing, you will need to find the asset that you want to tag at that location. So it's in P unit cluster, that is the one that I'm accessing now, and I want to tag this equipment. And so when I click select, you can see that there is like a dash box around the tag, and it means that the link has been created. So I can access the link by selecting this area pick tool and then double click. So now every time that, let me refresh this. Okay, I made a mistake with the drawing. Sorry, let me check this one more time. Okay, I see. So, for example, I don't have this one available. I try on another drawing. This one is sorry, I need to set something up really quickly and I will explain from that. Sorry, yeah, I'm having an issue with the tag process. I need to check if it's my installation. Normally, the procedure is when you select the plant unit, you will be able to select a PNID. On that PNID, you can box an area, and that area can be connected to a specific asset in the asset hierarchy. When you double click to it, it will bring you to it and show you the PNID. But I'm having an issue with the visualization. I will check on that. Maybe I'm missing a file on the PNID. But the procedure should be the same.
Okay. Mr. Alberto, how do we attach PNID to the plan unit?
Yeah, to do this, we can receive, if you have the PNIDs, you can send it to us. Normally, our clients send us the PNIDs. We convert it and load them for them, and make the connections between their asset list and the drawings. This is a service to load the drawings, or also we can provide a tool that allows you to convert DWG to SB2 and load it manually by right-clicking here and going to add drawing. And then here you will have, let's say, all the different SB2 files that you convert from DWG to SB2. And when you click open, it will load the file directly here.
Okay, so the format must be in SB2.
SB2, yes. But we can help you convert from DWG to SB2. The only requirement that we have is that the DWG file has the tags of the equipment in text format and not a block entity. Okay.
Also, can we use the earlier method for piping to tag the pipeline in the PNID to the piping plan unit?
Yeah, the method is the same. If you do it manually, it would be selecting the. In fact, let me see if I have a sample PNID that we can load our training unit. Let me see. Normally, we will load. Trying to convert a PNID to show you the loading process. Give me 1 second. Okay, so we use a tool to convert a DWG to SB2. Then there will be no tags between the existing equipment and this drawing, but this drawing will still be in the P unit. So from here, what we can do is we can select some of these tags and connect them to an existing asset. So if for example, I create an instrument that is called 100 PI 241. What I can do is create from this visualization of the PNID. I can create a new area. Go to instruments, select my instrument. And now you can see that if we exit somewhere else, every time we access this instrument, it knows the location of that instrument within the PNID. So if I'm looking, let's say at the something else, and I go inside my unit, first it will show the general PNID, but then when I go to instruments and I select this one, it will zoom in to the location of that specific instrument in the drawing. So the process to do it manually is we can install for you a tool where you need to convert your DWG as a DXF. So let me. So from DWG, you go to DXF. And then once it's in DXF format, we have this tool that is called convert from DXF to SB2, and it generates an SB2 file that you can upload by right-clicking on the PNID section of the plant unit and just say add drawing. So when you add drawing, you can just paste the SB2 file here, like I did with this one, and click open, and it will be part of the plant unit. Once you can visualize it in the plant unit, you can click here on new area, and let me do another one. For example, here I'm gonna create this instrument called 100 TI 241. So 100 TI 241 would be my other instrument. And what I can do is I can create a new area here. In this case, it's a circular shape, so I can use the circle tool. Click and expand to define the limits. And then from my instruments, I can select the TI instrument. Click select, and now the link has been made between the instrument and the position of it in the PNID. If I switch this one, it will find for me the location of the PI. If I click on TI, it will find me the one for TI. You can do this for essentially for any tag and connect them to a drawing in the PNID. Okay, that's how the connection between the asset list and the drawing happens. For us, we have other tools that we can automate this process, and we offer this as a service to our customers, so that you don't have to do this manually. So normally, what we recommend is, if you want to load the PNIDs and make the connection between the tags, we suggest you the first round of drawings loading is done as a service, and then the minor modifications you can do manually. If you want to, you will have the tool. The tool that we are using, by the way, is inside the bin folder of your installation, and it's called DXF to SB2. Is this one here? Convert DXF to SB2. So to use this, you just browse the location of the DXF file. So in this case, I had it on Antea data right here. And then when you select here, just click convert. And once the conversion is completed, if you look at this path, you will have the location of the DXF, sorry, the SB2 file. So if I go to Antea data, and yeah, I can see here the location of the SB2 file. That's the file we will load here, and then you can visualize it inside Palladio. That is normally the followed procedure.
Sorry, sir. I missed. Sir Alberto.
Yes.
Yeah, sorry if I missed. How do we open? How do we convert DXF drawing PNG to DXF file?
Okay. So to convert a DWG drawing to DXF, you need to open the DWG in AutoCAD, and when you go to the option Save As, you select in the file format, you select DXF.
Oh, okay.
Yeah, something we recommend to avoid any issues with let's say the restrictions of the conversion is to save the DXF in version 2000. So that one will prevent having any issues on the conversion.
Thank you, sir.
Okay, now that we have a drawing and that we have made a connection to assets in the asset list, let's explore what other tools we have with the PNIDs. So with the PNIDs, something that is very important and that we have discussed with many of our clients is that PNIDs are very used in the normal practices in the facility, but it's a document that when it's needed A lot of versions are everywhere. It's hard to find the latest version of the drawing. And the idea with Palladio is that the drawings that we load here should be the most updated ones. And of course, we understand that there are challenges in terms of the timing that it takes to revise a drawing and issue the latest version. So from the latest one that we uploaded into the system, what we can provide is some assistance in terms of defining what we call red lines, that are some sort of comments of let's say, the condition of the assets that are inside the PNID. For example, let's say that this instrument, 100 TI-241, during a plant walkdown, I realized that this instrument was not working. I can immediately use the tool new redline, that is right here. And with this tool, I can create a comment box next to my the position of the instrument that I want to comment. So in the field note, it will be the title of the comment. So in this case, I can say faulty temperature instrument. And I can describe here that during plant walkdown, it's just a free text field to explain what the observation was. What the system will capture is which user, in this case me, is reporting the comment and when was the comment reported. As soon as I click OK, every user that has access to Palladio will have access to this comment if they are going to use this specific PNID. So this is how you create a red line or a comment in the drawing. And there are a few more things here. So this button is to create a new comment. This one is to pick a comment. As you can see, we can only see the title, but if I was a user and I want to see what is this comment about, I need to select this option, and then I can double click on the comment and see what is the note, what is the content. Also, I can modify the red line, which means I can modify the size of it, the extents of the red line by dragging the let's say the corners or the sections of the comment. And I can also use this button here to eliminate the red line in case that I want to delete the comment. This is these are the four basic functionalities of the red line comment, and is something that is useful in order to keep the drawings up to date. So okay, as I was saying, there are four options with the red lines. One is to view the content, that is the first one here. The second one is to modify the red line. The third one is to create a new one. And the fourth one is to eliminate the red line. So if I click here, I will be able to click on the red line, click delete, and then click yes. And so once we enter again to this drawing, the comment will not be there anymore. Not every user has the permissions to delete red lines, so you can set that up so that only certain users can delete them in case that you need to protect the comments that different users will make. You can have someone that validates and have the right to delete or to confirm that the change needs to be made. This is normally how PNIDs are used. It is important to see that when you have multiple drawings, the PNID button here on the top allows you to see the entire list of P&IDs that you have in your system. So it's an entire table with all the different P&ID names and positions connected to which plant area and plant unit they are located. What is the name of the file? What is the name of the drawing? What is the description, the current revision they're on, and the date that they have been uploaded. You can filter this table by, for example, selecting a specific, searching for a specific text of a name of a P&ID, or selecting a specific unit in which you would like to see the drawings. So, for example, in our case, if I select this unit and I click search, we will only be able to see one drawing. That is the one that we uploaded as an example. But in other units, like for example, this one, you can see that there are plenty of P&IDs connected to one particular unit, and you can search them here. The reason to search here is that if you double click on any of these drawings, it opens in an independent window that you can, let's say if you're using two monitors and you want to consult a P&ID outside of Palladio while you check something else, you can move this to a separate monitor and consult the drawing. Other than that, this is the way to look at it, and we have the possibility of offering you as a service loading these drawings massively, very fast. So in case that you need that service, please let Puro Veritas know, and we will be happy to help with that. In terms of this, so basically we have one basic graphic representation. Let's create one here just as an example. Let's assume that this is our exchanger, and I am going to connect it here. So just as a reminder, what I'm gonna do is I'm gonna box a section of the drawing. It doesn't have to be the tag, it can be the asset. Normally it's the tag, but and then I'm gonna connect it to this particular asset. And if I double click, now we have a P&ID. So every time that I am, let's say, on my demo plant and I access my unit, I can see that when I go to my equipment here, I have the location of that equipment that I have tagged within the drawing. Also, I have an equipment tab, and this equipment tab at the moment is empty. This equipment tab is for a graphical representation in terms of 3D modeling. Sometimes our clients have either designed 3D models or as-built 3D models or as-is 3D models. In Palladio, we have the possibility of creating a model in case that those models that our clients have are not available, or maybe they are outdated and they want to create a management model that allows them to manage, for example, inspection data or the different list of parts of their asset. So what I would like to teach you next is how can you create a very basic 3D model of the asset so that you can have a 3D representation of it inside Palladio using our graphic editor tool. So if you notice, for example, an item out in another plant unit like this one, when we go into the equipment tab, we do have a 3D model representation. So how do we build this for the ones in our training unit? At the moment, our training unit has, when I selected, we have a PNID. That's the basic graphical representation that we have assigned. But how do we create a 3D model? So if I right click on the, so because you can see this is empty, if I right click on the equipment and go to graphic editor, I enter to a window that is an environment to create a management 3D model for our heat exchanger. So normally, yes?
Sorry for interrupting.
Yes, go ahead.
Could be back to Kennedy section.
Yes.
I want to ask you about does it has undo and redo function?
Undo and redo in what sense?
Like if I create a box, then I accidentally delete it, so I can redo or undo it.
No. Well, if you create, let's say you're creating a box. Let's go here. Let's say you're creating a box for this foam chamber. So you go here, you're creating the box, and then once you define it, you click select. There are only options of let's say you can delete this box by selecting this remove area, or you can click this on link area with to change to which asset you have linked this box. But it's not very easy to delete this on accident because you need to go through different steps. Like, for example, you will go to click here, double click, then it will ask you for a confirmation. Do you really want to delete? And you need to say yes. And then it's gone. So if you delete it like that, there is not an undo button to get it back. You will have to redefine it, but redefining it is also very, very fast. You can do like this, select your asset, and that's done. It's created. So we don't have a undo and redo functionality for this.
Thank you, sir.
Okay. Now, as we can see, for our equipment, we have already a position in the PNID, but we don't have a 3D representation. How do we make one? We can right-click on the name of the asset, and we go to Graphic Editor. Graphic Editor is a window that has a basic library of elements that can help us create essentially any pressure equipment. And it will look like the one that I showed you earlier, and it can go into higher complexity. Like, for example, if I show you this as an example, if we look at this asset, this is an asset that was modeled inside Palladio, and you can see that the components are very basic. We have a combination of cylindrical shells. We have mainways. We have nozzles. We have elbows. We have heads, hemispherical heads or blinds. And all this library of elements we will find it inside the graphic editor. So when we open our equipment, right click and go to graphic editor. The first thing that we need to define is the main axis in which the equipment will be modeled. So first of all, in a 3D model, there is something that is called the coordinate space. So in this space, you need to define the position of the asset in a X, Y, and Z coordinate. If we don't know where is the position of this on our planned coordinate space, we can just define it as 0, 0, 0 to start with. It's okay. And we are going to define if the orientation of our asset is built on the x-axis, the y-axis, or the z-axis in case that it is vertical. Let's say I'm going to select the z-axis. The other functionalities they are not used. I'm going to click OK, and you will notice that under equipment 2693, there is now an axis. In this axis, we can zoom in here, and we will be able to see where is this axis pointing to. So now notice that we have a library of elements or parts that we can use to start building our vessel, or our exchanger in this case. I would like to work with you in an example, modeling a simple vessel that we can, let's say, learn how this is normally done. I'm going to show you. Normally, we will have a mechanical drawing like this. So in a mechanical drawing, we have the name of the asset and the list of nozzles, for example, the sizes, the specification, and the description. And then we have different views, for example, a side view and a front view, to understand the angular position of the nozzles and the length of the different parts. So maybe it would be a good exercise to learn how to model this vessel, and let's try to do it together so that we can learn how to use this modeling tool. Shouldn't take too long. I noticed that the measurements on this particular drawing are in feet and inches. So I have converted this to millimeters in the different comments so that we can insert it. And I'm gonna make it half of my screen here. The other half, I will have this window here. So basically, we will start. We will see that this is a horizontal vessel. So I'm going to modify my axis by going to properties, and instead of it being vertical, I'm going to put it on the yellow axis here. So I'm going to put it on the x-axis so that it's a horizontal, and I'm going to click OK. Now the orientation of my axis has changed, and I am going to start with a basic element. And in this case, one of the most basic elements that we can consider is the shell of this particular vessel. So what do we know about this shell? We know the length of the shell. We know the length, and we know that the length is 2.4 meters. So what I'm gonna do is when I select the axis, I can click on Add Shell. And in Add Shell, it opens a small data sheet that asks me what is the name of this shell. I'm gonna call it shell 1. and it's going to ask me for the dimensions of the shell. So from our mechanical drawing, we know that the length is 2,438.4. 2,438.4. And we need to know also an outside diameter. So let's see from our drawing where we can find that information. So we can see that we have information about the internal diameter. The drawing has no information about the thickness in this case. But what we can do is we can assume. We can say, okay, let's say this is 914.4. 914.4. And I'm going to give it a thickness of 15 millimeters. Yeah. When we assign a value of thickness, we can also assign a corrosion allowance value, for example, 2 millimeters, and a tolerance either on millimeters or on percentage. So, for example, I'm going to give it one more here, 1 millimeter of tolerance. It's a 6% tolerance. And I can click OK. We can also define the material of this shell here from the tables, but I'm just going to confirm to show you how it works. So as you can see, we now have created the shell for this, and we can proceed to define the other components. At any point when you are modeling an element, it's good to save when you have some substantial progress. You click yes, and what I'm gonna do is I'm gonna resize this, re-enter to my graphic editor so that we can work. Okay, now we have created our first element, which is the shell. The next easy one to create is the heads. What information do we have about the heads? Not much in this drawing. So what we're going to do is that, as you can see, we have created one shell under the main axis of the equipment. And now in my library, I have 3 different types of heads. I can have a flat head, a hemispherical head, or an elliptical head. I don't have specific information of what type of head this is, but we will select the one that is appropriate. I'm going to assume it's an elliptical head. And notice how the software highlights the places where you can attach heads. So let's say I'm going to attach this head here. I'm going to click there, and you can see that automatically the software is copying the diameter that will match the shell that the head is going to be attached to, and is also copying the thickness from the shell. The rest is modeled automatically to create a head that will be attached to that particular shell. You can always modify this in case that you have more specifications. I don't have enough information, so I'm going to go with the standard. And also you can add some neck. So it's some let's say, a straight length here. Let me show you. I'm going to exaggerate the size so that you can see maybe more than that. But it's let's say a flat piece of head that you add after the hemispherical part. I'm going to leave this one as 0 and just continue over here. Okay, by the way, I'm gonna call this one elliptical head, right? We give the corrosion allowance. And click OK. As you can see now, we have a head on our vessel. The other one is missing, but you know what to do. We click on the shell, we click on the head, we click on the space where we can insert the head, and we call this one left. And it is already assuming the dimensions of the other head. So we click yes, and now our vessel has shell and heads. The next step would be to add the nozzles. So to add the nozzles, I think that it's a good practice to follow the order that is described here on the table. And so we start with the mainway number 1, that is a 16-inch nozzle. Let's have a look at where is this located. So the mainway 1 is this one that is on the head. And we can see that the axis is 8 inches or 203 millimeters away from the center of the right head. So in terms of the length of this particular mainway, we know that from the beginning of the head up to the end of the mainway, we need to have 381 millimeters. So essentially, what we are going to do is, first we need to know that we have our head. Wow, what a terrible drawing, sorry. We have our head. And the distance from here to here, we can know that from Palladio. So if I select the head and go to properties, I will be able to see that the length of this head is 228 millimeters. And then we need, from our drawing here, we need 381. So 381 minus 228 is 153. So the length of the mainway, this length here, should be 153. So let's have a look on that. We have how do we attach a nozzle on this head? We can right click and then go to add axis, element axis. So instead of working on the main axis of the equipment, because this is going to be in a different axis, we need to add an axis on the element where the nozzle will be installed, in this case, the head. So what I will do is I will right click there and go to add axis, element axis. We also have the same option up here as a, let's say, quick icon to add this functionality. So what is the software doing? It is asking me, okay, you have this head and the axis that you want to add is this red one. Is at distance 0 from a total distance of 457. Where do you want it? So I'm gonna put it, let's say, halfway of the radius distance. So let's try 100, 114. Hundred and 70. Okay. And then notice that this axis is facing is normal to the let's say to the curvature of the head. So what we really want is to be perpendicular, sorry, parallel to the element axis, so that our nozzle comes out straight. I'm gonna put it there. Maybe I can increase this a bit more. And then we define that the axis should be parallel to the element axis, and we click OK. So now we have an axis here where this nozzle can be installed. If I click on that axis, I can insert a nozzle here on Add Nozzle. What do I know about this nozzle? I know that the name is M1 based on my table here. And I can go to a standard table where I can find a 16-inch flanged nozzle. So on type, we can look for the nozzle here in terms of size. So I'm gonna go for 16. We don't have information about the class, but normally you have the dimensions for different classes. Also, you can define if it's a socket weld, welding neck, long joint, long welding neck, and so on, or slip-on. And then you can define if it's raised-faced or what type of nozzle is it. I'm gonna go for a class 300, 16-inch here, and I'm gonna select this type of nozzle. So the software automatically creates the dimensions of this nozzle according to the class that we have selected. And then we know that we need to have a total length of 100 and forgot my drawing here, 153. So we need at least 6 millimeters more of tube length. So we add up to 7. And we can insert the nozzle. So I'm just gonna click OK. And you can see that the nozzle has been inserted. It seems like the axis needs to be moved a bit higher. I'm gonna move it, say 190. And then we have our manway. I might be getting these distances wrong. I just want to show you how to do it in terms of the distances. Is something you can calculate with a bit more time. I am going to extend this a little bit in terms of the length here of the tube. I'm gonna give it, say 100. Then now we have, let's say, our manway here. Now, after that, we have that's manway 1. After that, we have nozzle 1. Nozzle 1 is over here. So for nozzle 1, what we need to know is that is 7.6 inches from the beginning of the shell. So it's considering that this is 0, 7.6 inches towards the left is the position of nozzle 1. The information that we know about nozzle 1 is that it's a 4-inch nozzle and is just it's an inlet. So and it's a flanged nozzle. So what we can do is on the shell, we are going to create an element axis that is going, we need to see the angle of nozzle 1. Okay, so nozzle 1 is right on top of together with nozzle 2 and 3A. So we can use the nozzle 1 by adding an axis, an element axis. At the moment, the axis that we are creating is in the bottom, so we need to change the angle to be 180 degrees from where we are right now, so that it points up. You can see here. And then this one is counting the distance in the opposite way. So if we look at here, the total distance for our shell was 2,438.4. 2,438.4. And if we subtract from this value here, so minus 2,286, we can see that we need to be 152.4 millimeters away from the beginning of our shell, and that's the position of nozzle 1. So okay, so now that we have created the axis, we can insert the nozzle. And to insert the nozzle, you know that you select the axis, click on nozzle, call it the same way as the mechanical drawing, so nozzle 1. Go to the standard table and select the 4-inch nozzle. Then select I'm gonna keep using the 300 class. And we don't have a value for tube length, but say 100. And now we have our nozzle 1. If we continue with nozzle 2, we need to do a similar operation, which is from 2,438.4, that was the length of the shell, we subtract 1,981.2. And we get that the distance that we need to move from here to here is 457 millimeters. So again, we right click, we go to add axis, element axis, and we go to 457.2 away from the beginning, and we fix the angle to be 180. And we make sure our axis is pointing up, which it is. Then we can click OK, and we can insert our nozzle 2. Select the axis. Now, notice that this is nozzle 2 is a 3/4 flanged nozzle. So we will select a nozzle. We call it nozzle 2. Go to the standard, look for a 3/4 class 300, and we click select, and we do a tube length of the same of the other one to be consistent. Click OK. So that would be our 3/4 nozzle. We proceed to do a nozzle 3A. So nozzle 3A is a similar operation. We select the shell, right click, add element axis. For this one, we need to, let's see, 577. Okay, so for this one, we need to subtract from 2,438 this amount. $577.85. And so we need to use this distance. And the angle should be 80. You can see that the position is correct. And then we insert our nozzle 3A. Our nozzle 3A, it seems that is a coupling. So for a coupling, we don't use the flange nozzle menu, but we used simply like a representative shell that is for the coupling. And we call it, based on our mechanical drawing, as N3A. And then we just give it a length of, we can find here on the standard at 3/4. So 3/4 threaded, because it's a coupling. And we click select. In terms of length, I'm gonna give the same 100. Then we click OK. So that would be our nozzle 3A. Nozzle 3B. Nozzle 3B, we can see that nozzle 3B is actually in the bottom of the equipment. So based on this part of the drawing, so nozzle 3B is right here. It's actually in the exact same place as nozzle 3A, but in the opposite side. So what we can do is we can, again, right click, add axis, element axis. We have the calculation of the last distance, which is 1,860. And then we know that it's in the right position, it's in angle 0. And we click OK. So from here, another useful tip that I can give you is, if it's an exact same element that you want to include, which nozzle 3B is also a 1.5 coupling, you can select one of your previously installed elements, right click and copy. Then select the axis, right click and paste. That will paste an exact same item as this one, and you just change the name to be N3B. N3B. We click OK, and we have our N3B coupling. Now, N4. N4 is actually right here. So what it looks like is that there is a blind after the mainway, and then there is a nozzle coming from that blind. So on the mainway, we can select it, and then we can put in a blind just by clicking on top of the mainway. We can insert the blind. The blind will size accordingly to the size of the nozzle. And then over that main way, we can create our nozzle 4. Nozzle 4 is a 3/4 coupling, so same as nozzle 2. We can create an element axis coming out of the blind. Notice where it is pointing right now, it's pointing inwards. So we need to define that the element surface is the external flat surface so that it points outwards. And then we click OK. We select the axis and insert our N4 that is a coupling, 3/4 coupling, which we can insert as we saw before with a representative shell. We give the name of N4 and we proceed to do the 3/4 threaded selection. In terms of length, we keep the 100 and we click OK. So now we have our nozzle 4. On nozzle 5, we have nozzle 5 right here. It's in the bottom. They have it at a distance that is the combination from the distance to the support of the asset, which we are not modeling right now. But if we add this one with this one, we should have the distance up to this point. So pretty much what we will have to do is 209.55 plus 412.75, and then the entire distance of the shell minus this combination. So 2,438.4 minus this combination that was 622.3. So the distance of N5 should be at 1,816 from the shell. So we select the shell, right click, add axis, element axis, and then we go to a distance of 1,816.1. After that, we click OK. I did something wrong because the distance here is a bit different. 12. Mm-hmm. $412.75, 295, and then yeah, I got one of the two wrong, either this coupling or this one. But let me switch it up a bit just to finish the exercise. Sorry for the. Okay. Okay, I'll place this here, nozzle 5. Nozzle 5 is 1-inch coupling. So again, we go to the shell menu, we call it N5. And then we go to standard, go to 1-inch and pick the threaded component, select, length of 100, and we click OK. So now we have our two couplings here. Now we proceed with N6. N6 is right here. So it's right. Okay. I wonder if this 4 feet is from the support or from the beginning. But it looks like it's right in the middle, so it should be in the middle of the shell. So we are going to create again one more axis, add axis, element axis, and we go to 1219. Yeah, it's right in the middle of the shell, 219.2. And it is in the right location, it's pointing down. So I'm gonna select this axis to insert nozzle 6. Nozzle 6 is 4-inch flanged, so we can use the nozzle. This is N6. We go to standard, 6 inches, 300. And then we give it a tube length of 100 like the rest. And, oh, this is too big. This is, sorry, I did 6 inches instead of 4. No worries, let's change it. We go back to the properties, go to 4 inches, place that, and just click OK. Okay. N7 is also at the bottom. N7 is right here. So N7 is the entire length of the shell, 2438.4 minus 1955.8. So we create an axis at that distance. Again, right click, add axis, element axis, distance 482.6. We click OK. We select the axis, check what type of nozzle is N7. N7 is a coupling, so we do this one. Call it N7. And it's a 3/4 threaded. Okay, we give it a distance and firm. And then finally we have N8. N8, as you can see, is in the middle and it's on this head. So we create an element axis right on the middle. We just make sure it's pointing out, which it is. It is external, so it's correct. And from that element axis, we create our last nozzle, which is N8, and is 1 inch. So it's a 1-inch coupling, so we use this. Call it N8. And then we can go to standard 1-inch threaded. Length 100. We click OK. Okay. As you can see, we have modeled this particular asset. When I click save, I can click yes. And if I after saving, if I exit, I can go back here and notice that if I go to my equipment and then go to the equipment tab, now I have a graphical representation of my asset. So we have achieved the 3D model, and we have achieved the positioning of the asset in the PNID. So in other words, the basic philosophy of having a graphical representation, as we discussed earlier, has been accomplished by assigning the asset a visual representation in 2 and 3D. Regarding the modeling on the software, I know that we are modeling an exchanger. So sometimes we also need to insert the internal components, which are the two bundles. These are the way that we are inserting this is very representative. It's just to indicate the existence of such part, but you can see that here in the library, you have the possibility of adding a tubes plate. And this tubes plate is the one that that will allow you to create, let's say, the internal components of this kind of asset. So, for example, if I select the tubes plate, I can indicate what is the diameter of the piping, what is the diameter of the pipe bundle, the pipe thickness, the plate thickness, and so on, and add this as one of the elements of the internal elements of the model if I need to. On this one, I don't think we have enough time to do the internals, but it's very simple. In fact, the only thing that it will do is it will allow you to find to visualize the internal components in the following way. I can show you with one that has an internal model. So, for example, on this one, you can see that the exchanger, if we enter in transparency mode, you can see the internal tubes of the exchanger. So that's what you will be able to achieve. And when you select this particular tube bundle, you can see the properties in terms of which of the tubes are plugged, or what type of let's say pipes are going to be, what is the order of the fluid, which one is inlet, which one is outlet, and many other properties of the tube bundle. So yeah, depending of what is the criticality for you to manage this kind of data, then we can consider discussing this later. For the moment, this is what I wanted to show you on modeling the asset. We have achieved creating the graphical representation for our exchanger. So I would like to ask you if you have any questions about this modeling process.
Does the model can be connected to the component RBI that we created in the plan unit, sir?
Yes, it is actually already connected. So in other words, if I exit and I open my plant unit, and then I open my equipment list, and I select one of my equipment, you can see that if I go to here, I immediately see the representation of my equipment as a 3D model. So I can see the 3D model for my equipment, and it's already connected with the asset that I have selected. If I select a different one, I will see a different model. In this case.
What about the component that we added in the construction data and the equipment? Is it connected to the 3D model?
No, because those are let's say the RBI parts are can be defined based on different functions. So basically, there is not a 3D model for the shell side only. It's the model for the entire asset, and then you can view either tubes as an internal or shell as an external, but both are represented. The thing is, the representation of the 3D model is physical for the entire asset and is theoretical for the RBI parts. So it just shows a boundary, but it's not represented in the 3D model.
In Palladio, you can load different types of inspections. We will focus in two very common ones. One of them is the visual inspection, and the other one is the UT inspection for a ultrasonic thickness test or thickness measurement. When we go to the inspection tab for an asset, we can see the history of inspections that have been loaded into it, and then we can visualize the results of such inspections. Here in the let me access an example. When we access one of the assets and we go to inspections, we can see that if I select one of these UT or thickness gauge inspection, it is using our 3D model to indicate the positioning of the CML, and it is also showing us the element in which this CML is placed. Both of these are placed on this shell. That's why that's the region that is highlighted. And then we have the different readings that were captured on that particular section. Let me see here if I can show you something else. Here on the graphical representation of the asset, we just learned how to create. We can activate this icon called thickness measurement location, TML. And the software will show you the position of the different declared CMLs. Yeah. If I want to see the measurements that were captured on these particular measurement locations, I can select the icon values grid, and on top of my 3D model, it will show me with color-coded points the different measurements that were taken on these areas. If you can see, the colors are representing the proximity to limit thickness. So, for example, if I see points that are in color blue, it means that they are very close to nominal thickness or higher. If I see green is an intermediate between normal and intermediate, then intermediate is yellow, white is between intermediate and limit thickness or below is red. This helps us to graphically understand when there is a point that has a thickness under the limit thickness. Notice that we can declare inspection areas such as that there are circular sections, points, or rectangular sections for like grids, for example, when we do further assessment of a specific inspection point that is giving us a bad result. When we click any of these measurements, for example, this one, there will be a window that shows up showing us the reading of thickness at that particular point based on the latest inspection report loaded for that measurement location. It will also give us information about the nominal thickness, corrosion allowance, tolerance, and limit thickness defined for the element in which the measurement was taken, and will guide us on what is the current reading. Also, we can see that if we go to the inspections tab, the details for the inspections on different dates can be accessed and visualized. Here are the measurements, all the measurements captured on this particular date by this particular survey company and this instrument. And the benefit of capturing this data over time is that when you access any of these surveys, you can check this graph. This graph is the change of thickness over time. And so we have a graph that with red, it is indicating the limit thickness of the asset. Green is indicating the nominal thickness. And then we have the change of thickness over time based on the different registered inspections. So we can see that there are two lines. One line is, the blue line is representing the mean or the average value. So for example, if in TML IP3, I have 4 measurements, it's going to add and divide by 4 the measurements and give us a display value of just one value, which is the mean value out of the measurements, as the reference on how the thickness was represented on that particular analysis. If we don't want to work with the mean, but we want to look at the minimum, we can switch the value here to display the minimum, and it is graphed by the pink line. Okay. We can also select this checkbox here that is called the calculation trend. What it means is that, let's say this data that we have was from 2015, where the minimum value was already at limit thickness. What the software does with this calculation trend is it plots what should be the position of thickness today, considering the latest available corrosion rate that was calculated by the system. How do we visualize the latest corrosion rate calculated by the system? By right-clicking on the asset, going to inspection and survey, and then flash report. In flash report, we can see the value of the corrosion rate in short term and long term for the asset. 0.93 millimeters per year, 0.37 millimeters per year, and the expiry date, short term and long term, which is now defined as expired already. How do we calculate the short term and the long term? It's a very conservative formula. The idea for the short term is a previous thickness measurement minus actual thickness measurement divided by delta T, or the difference of time between the previous measurement and the actual. For the long term, we do either the nominal thickness or the first recorded thickness value minus the actual divided by the difference in time between the two in years. This is the way the value is calculated, and it can be calculated per element. So for example, shell, nozzle, head, or it can be done by TML. So each conditioning monitoring location can have its own corrosion rate. In terms of which one to assume for an RBI calculation, for example, we recommend to go with the worst case scenario. But again, the information will be available for all the different items so that the RBI inspector can make the judgment of which one is the most appropriate corrosion rate to use based on the available inspection data. Okay, before we took the break, we were looking at our unit in which we created a 3D model for our exchanger. Yeah, finish our 3D model, And now the idea is, let's load some inspection data on this 3D model. So how do we do that? If we right click on the 3D model, we will be able again to, if you remember, in graphic editor was the place where we created this 3D model. If we access that again, we will be able to see this window in which we can create the different, as an element of the asset, the different conditioning monitoring location. So let's create the CMLs. How do we do this? If I click on the element that I want to insert an inspection location, like for example, the shell, then I can right click and say, add inspection zone. So if I add an inspection zone, I can click on circular section, give a name to my CML, like for example, CML 001, and define the location of this CML along my element. So for example, I can say that my first CML is a circular section that is going around the shell of the vessel, and I want to have it at a position that is 1,300 millimeters from the beginning. Okay, that would be the position of CML1, and you can immediately see the ring going around our vessel. Okay, let me define a few more. For example, I can define one in the nozzles as well. So if I select the nozzle, again, the steps are, you select the element, you right click, add inspection zone. You have options. It could be only one point with one measurement. It could be rectangular as a grid, or it could be a circular section. Let's use circular section. Let's do CML. It's 002. And let's move it to half of the neck of the nozzle. So place it like right there, and this is our CML2. Notice that the element is registered under the parts list here on the left as a CML. So we have 2 CMLs on our vessel, and let's add one more on the shell. So again, right click on the shell, add inspection zone, circular section, CML 003, and then we define the distance. Okay. Okay. We have 3 CMLs on this vessel. Then we can save and say yes, and we can exit. Now, on my visual representation, for me to see the CMLs that I have declared, I need to activate this icon called TML. Here, I can see the CMLs that I declared, and I can also see their position within the list of parts that create this particular asset. So we have CML1, CML1 and CML3 under the shell, and CML2 under nozzle 1. Okay. Now, how do we create a survey? There are multiple ways to do this. One of the easiest one is using Excel. So for example, let's say we are going to create a survey where we're gonna load the measurements for this particular CML. So what I can do is I can right click on my equipment, go to utility, and say import thickness gauge from Excel. Okay, one more time. Right click my equipment, go to utility, import thickness gauge from Excel. Okay. What do we have here? We have a window that is telling me that on Exchanger 2693, that is the one that we're working on, I have 3 CMLs, and I have to assign the different values of readings of thickness along the positioning of the CMLs. So the first thing that the software will ask is for a session. We can click on search, and we can say that these inspections are under the session of 2022. This session is normally used for either define the, let's say, inspections of Q1 of 2022 or shutdown 1 of 2022, or let's say on what event was this inspection performed. I created one that is very general, but if you want to create another one that is more specific, you can click on new survey session, give the date in which it starts and the description. Okay, I'm gonna use this one. So it will populate the date, it has a session number and a description. The session number is the year in which the session was created, and you can have up to, let's say, 10,000 sessions per year, which that would be too much, but as you can see, we only have one, so it's 0001. Okay. Then on inspection, I'm going to select thickness gauge, US. The survey date, I can say, for example, that it was on the 1st of January of this year, or even today if I want. And then I can select my inspection company. I'm gonna say Antea as an example. And then I can define who was the inspector and who was the supervisor. To populate these different inspection companies or the people that are involved here, we can do it from the tables menu. I'll show you how to do that, on how to fill up the list of companies and list of personnel. Certificate number is not mandatory. It was a requirement from E&I for us. But it's normally when the inspection was delivered, there was a code for the certificate, and we have a field for it but you don't need to worry about that. And notes are just general notes, a free text field, so you can insert any type of comment. Now, what is the idea? We have 3 CMLs. So what we have to do is we have to open Excel, and we have to insert these names of CMLs, just like this: CML1, CML2, CML3, exactly the same as they are defined over here. So after that, we are going to define what is value 1, 2, 3, and 4 of the measurements for each one of the CMLs. So if you have a table, an Excel table like this, what you can do is you can copy, and you can paste the selection right here. Okay, now I have a problem because it only captured for me these values, if you see. And the reason is I forgot to do something. That is, here it is saying that from my selection not to import columns 2, 3, and 4. I actually want to import all columns. What does this mean? Sometimes the inspections have other data that include, let's say, nominal thickness, limit thickness, corrosion allowance. So you can define from a big table which columns not to import. If I want to copy this table, for example, I will need to declare in the software that I would like all columns to be imported. So I'm gonna say 0 on all of them. And then I can paste the selection, and now I have my values. Now that I have the values, I just need to click Save. It will start the procedure. We click Yes. So it will ask me information about the instrument. What instrument was used for the measurements? We can select the type of probe. Again, if you right-click on the field and click New, you can register a new name or new type of probe if it's not in the dropdown. Same for the coupling, the temperature, and then the instrument name, the description, and the calibration date. Okay. After we complete these fields, we click OK, and it says that the loading is complete. After that, you can exit, and I will exit Palladio for a second. Okay. And then let me re-enter. If I go back to my unit, I should be able to see two things. Number one is that notice how the icon changed and now has a red ring. That means that we have inspection data. How do I know that? I can go to the inspection tab, and I can see that the survey that we registered on the 1st of January of this year is right here. If I open it, I can see the measurements that I registered. They are color-coded because they are following the pattern of which ones are above, close, or below limit thickness. And we have the information about the surveying company and also the instrument used for this measurement. So what is next is, okay, I would like to see these measurements on my 3D model. So I can activate the TMLs. It will show me the position of the TMLs. And then I can use this icon that is the values grid. And as you can see, in the CMLs, there are different points, and those are the measurements. If I click on any of the points, I have the information. For example, this one is telling me that on this particular point, the measurement was 14, but the limit thickness was 15. So we are under limit thickness. On this one, it is green. So you can see that the value was 14, but the limit thickness is 12, so we are in a good condition. Some others could be yellow, and it indicates here what the measurement was, and this is based on what we have inserted. There are other ways to upload these thickness measurements, and that is, for example, templates. So if we don't want to do it by copy pasting the tables in Excel, what we can do is we can create a template that is called the thickness preparing module. How does that work? The way that works is, if I right click on my asset and I go to utility, to inspection and survey, there is something that is called the thickness preparing module. In the thickness preparing module, I have this window, and this window is showing me the current status of my equipment in terms of which points are under limit thickness, close, or up or above by the color coding. And also, it is helping me to prepare a template for thickness inspection that I can deliver as an Excel file, and then I can upload to the system once it's filled up. How do we prepare this template? Well, first of all, we need to select the CMLs that will be involved in the inspection that we are preparing for. Let's assume that we are using all CMLs. So we can select this option that is called selected all, and it will select CML1, CML2, and CML3. If you don't want to select them all, you can unselect all and then just click the ones that you want to add. For example, 2 and 3. Let's say you cannot inspect in this case CML1, but let's use all of them for this example. So you are selecting all the CMLs that will be applied. Then you can proceed for, let's say, an automatic preparation, which means you can define what is the number of points that you would like to have on all of the selected CMLs. So we say we're going to take 4 measurements per CML. And then you can prepare by saying, okay, it is declared as 4. Everything is correct. So I click OK. Right click on the CML, prepare. It's going to take 4 measurements. Everything's OK. Right click, prepare. OK. When the status here is P, it means prepared. And then if it's A, it means it's going to be using the same setup as it was from the previous inspection, which is retrieved from the database data. If it's a new CML, it will have an N that it will indicate that you need to prepare and you need to define how many survey points you would like to include. After you have prepared this, you can go here where it says layout. And in layout, you have a menu where you can orient your vessel in a way that you can create a snapshot or a picture that will be transferred to this side, like for example, like this. You can zoom in the picture, and you can also increase the label size. The labels is the names of the CML locations. Also, you can move the CML locations so that they are in a better place, so easier to read. And it will tell you the position of the CMLs. Okay. Also, let's say you want to have a different view. You can still like rotate and your 3D model or do it from another angle, and still send that view and accommodate it somewhere else in the layout of your inspection. So I can, they have a side view here. It depends on what you would like to achieve, but yeah, it would be, let's say, up to you. Now, the idea with this picture is that, sorry, let me see. I forgot how to delete this one. Okay. 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 To delete, you use the scissors and select which one you want to delete. Okay. Now let's move this one to the right position. And what we're gonna check now is we're gonna click on preview, either preview or save layout. So preview is just to see how is this being set up. So maybe the image is a bit too big. I have to reduce the size. So let me reduce the size a little bit. Okay. Preview. Okay. Now this is the kind of report that we will print a template in Excel. So if that we fill up the measurements, it can be automatically imported to the software. So when we are done, we are going to click Save Layout, and we will be ready to export this template. So we have different options of export. For example, we can export to an Excel model. And this Excel model will have a particular logo that you can have the logo of your company or the survey company that is doing the inspection. And then it will ask you to save it somewhere in your PC. So let me save it. Then what I'm gonna do is I'm gonna download it so that I can open it in Excel. It's downloading from the server to my local. And now that I have it, you can see that it will open. And I have the possibility of filling up the measurements of the CMLs for the new survey. Notice that some information that you retrieve from previous inspection is what was the minimum thickness captured on the previous inspection. It will be here, and you can compare that because I have the other Excel file that we loaded. So on the first inspection that we loaded, the minimum for CML1 was 13. The minimum for here was 14, CML2, and the minimum for CML3 was 12. So that's what is showing here. Just as a reference, it's also showing the limit thickness of the element in which the CML is placed, the material, if we have defined it, but it wasn't defined. Then we have the nominal thickness, corrosion allowance, and the tolerance. So here we can fill up values for the new measurements, save the file, and then we can upload this file for automatic thickness loading. So let me say 12, 12, 12, 12. This one, say one. Okay, so I'm gonna save this. Now I'm gonna import this file into the server. Okay. Now, how do we load that file? We right click here, we go to utility, and we do the thickness automatic load. So here it will ask us for the path of the file. So we need to look for the file, and Sorry, I cannot find the file in the server, but normally the idea is you look for the file here, and it will retrieve. If it's filled up in the file, it will retrieve the inspection, survey date, inspection company, and so on. And if it's blank, you can define it still from here. When you check the files and click OK, the measurements will be loaded. You can have, let's say, 12 or 20 of these equipment files and load, instead of one file, like a folder full of these documents, and it will upload to all the different assets that you have downloaded. This is possible because the software understands to which equipment does each one of these measurements belong to. Each one of these reports belongs to, the measurements belongs to. So the last way to be able to add thickness measurements includes directly through the 3D model. So you can select one CML, for example. It will be highlighted in red. And once it's highlighted in red, you can right-click, go to Inspection and Survey, load new survey, define the different survey requirements, go for the thickness gauge, select the people who worked on it, the notes, the date of the inspection I will be putting as today, the result, and the reason. When I click OK, it is asking me again for information about the instrument and for a calibration date. It is asking for the number of inputs that we are going to define. We click OK. We are able to add the values that we would like to add on this one particular CML. So I can say for CML1 that everything went to 12, for example, directly from here. Once I do that, I will be able to see that survey as part of the inspections here. So one of them was in January, the other one was today. Then also from the thickness preparing module that we saw earlier, we can add a survey directly on this model, and we can do it through here, through the survey insertion, and then we can say, okay, for CML2 we have these values. Sorry, let me see here. For CML2 we have that the values are 13 on all, and we can save on this TML. For CML1, we can say that everything went to 12. We save it, and then for CML3 also everything went to 12. We can do it also manually directly from here. Once we're done, we save the selected TML and we save to the database. If there is any error, there will be an error file that you can observe. And it will register the newest survey right here. So after registering these surveys, we can always visualize the input and we can see the change of thickness over time. This is trended automatically, and this calculation trend it's not happening now because the latest survey loaded was today, so there is no projection to be done. Let's see if there is any calculation on corrosion rate for this one, which I doubt since we only have data of 1 year. Oh, okay, no, there is. So as you can see, after loading 3 different thickness inspections, the software calculates a short-term and a long-term corrosion rate, and it is indicating that we are losing 3.31 millimeters per year based on the different survey data. I will ask my colleague Fikri to show you a little bit more about something additional on the inspection side, on how to insert a visual inspection, for example. So Fikri, please.
Yeah, I will share my screen first. Can you see my screen? Okay, so for visual inspection, it's a bit simple than what Alberto just showed to you. So basically, for the inspection, you need to go on the item level to select any of this one example that we have here. In this inspection tab, and then so you need to go for the add a new survey. So basically, this is where you add a new survey. Click this one. So this session is the one that I have been creating before. So in case you want to create a new session, same as what Alberto just showed, you can go to the create session, and then you can define the date and also the description of this session. If you need to define some sort of a description for this session, you can put it here. So maybe you can put it like a section 2022. And you can click save. Then you can select the session first, and then this is where you can define the inspection. So because this is already a visual inspection, the software will detect the visual inspection. And then in case you put this as a general inspection, then you can define what kind of inspection is being done during this session through this drop-down option. So you can select this inspection, then you can name the inspection company who's performing this inspection, and then the executor or the one who's performing the inspection, and then the supervisor. So you also can put the note here if you need to, if regarding on this inspection too. And then the result of the inspection. So this is a drop-down option, so you can define it. This option can be defined through the base table. I believe Alberto has shown to you today. So to you, and also the reason. Maybe time-based. So this reason also is the same. You can define it in the table, and then even though they have only 4, that you can have more than 4 them in the table. And after that, you can click OK. So if you notice, this is the difference started for the inspection. For UT inspection, once you click OK, you need to define what kind of instrument you are using. So you need to define the gel, you need to define the probe, and the temperature of the UT. For visual inspection, it is a bit simpler, where once you click OK, you can define. It directly will bring you to define your visual inspections. So here you can define what's the normally in this this is basically a free text field where sometimes our client use it as you can put a summary of the inspection. So put here the summary, and then this is a free text field, so you can put any notes or finding or action to be taken for this inspection. And then after that, you can go to pictures. So basically, here you can add or attach any pictures that is related with your equipment on the inspection. So how to do that is basically you can click add here, and then you can select which one you want to include inside this one. So this one is the old one that I have, but maybe we can use it the same. Click here, you will have your picture here, and then you can put the description in case this one is like, you can put it like photo one or any other description that suits the picture, but I don't know what to put, so I can just put photo one and save, and then you can add another one if you have more. Maybe I can put 2 first, and then after that you can save. You can click save. So it will the VI inspection window will be closed, and then how you can access the the newly created inspection is by double click on this one. So the one that is created is today, which is 21st of April. You can double click here, and then you will have access to your inspection report here. Then you can have your pictures here too. And other than that, in case you want to include any attachment related to this inspection, such as ITP inspection test point or certificate related to this inspection also, or the certificate or of the one who are performing the inspection, you can go to this attachment, click, and then you can attach to this prompt here. And then also you can, on this window also, you can try to print the report itself. Okay. So as what Alberto explained to you, I think in the UT, whenever you want to print the thickness preparing module, you can have the ability to define what kind of logo you want to have inside the inspection report. So for this one, this inspection report for visible inspection, you need to define it through the file option within the setting of the software itself. So you can put it like maybe KPI or Bureau Veritas logo here in order to show who's performing the inspection. And then this is the first page of the report. So you can see. So it will show to you the plant name of your plant, the P unit that involved, the equipment name, register number if you declare in the P unit, in the data sheet, and then the session date of this inspection and the session description. You also can see the hello. Okay. And on top of that, also you will have the name of the company that's performing, the executor and the supervisor. This is for the first page, and then the second page is this one. Same item, same information, but the pictures and also the description of the pictures if you have any. And okay, this for preview, and then in case you want to save it in your locker, you can just print, and that's it. I think that's all for the visual inspection report. In case you have any questions. Okay, maybe no, so I think I can hand it back to you, Roberto.
Okay, thank you, Fikri. Okay, let me see. Let me share my screen again. Okay, so basically, you can see that we can manage different types of inspections. There will be a table here where you can have the different inspection types. For example, you can define this table with all the different inspection types that you are planning to manage in your facility. You can define also inspection codes in terms of what kind of inspection type will cover a particular activity. This is strongly connected to the scheduler, and is the way to program different activities based on the inspection results. I would like to show you a little bit about the reports. The reports is the next tab, in which every time there is a survey that, or a report that you receive from any survey company, you can add a report in this tab, in this section. So in order to do that, you are going to click here on New Report, and you're going to select what is the report type, if it's for a survey, a maintenance activity, an engineering report, or is a report by an authority. And then if there is any specific check type, like for example, an external visual inspection, a leakage test, or any other. So when you click OK, what we can do is we can define the due date of this of any activity that was declared on this report. So it will record the emission date as today, but we need to define a due date and a completion date for this particular activity that is defined in the report. So let me just do an example, like for example, a month from now. The completion date is not yet programmed. The survey company, you can define here from the dropdown. If the survey company that you want is not here, you can define it by right-clicking on the field and adding it. For example, we can add in code number 11 or number 5, that is free. We can add Bureau Veritas. We can also add a logo of Bureau Veritas so that any report that is coming from them will automatically have their logo. To add the logo, you just double click here and look for an image in any of these formats with the Bureau Veritas logo or with the survey company of your preference. Here we can have the details about the survey company, the service company, and we can add an address, a zip code, a city, and let's say the contact information for the company in general. After that, we can save and we can select it and use it as part of our report. Also, normally in this report, there will be an inspector involved. Same thing, you can right click and see all the list of inspectors that have worked in your plant. You have the possibility of attaching a certificate of any of these inspectors, together with all their contact information. And we can select any of these as an example. Same for the supervisor and the person who redacted the report. We can define a result for the activities. So a general result, like for example, acceptable. And if you can specify if a shutdown needs to be planned based on this result. The checkboxes here are to indicate what was the reason for the inspection or the survey that was carried out, if it was programmed, if it was because of routine, or because there was damage, if it was a predictive inspection or a shutdown. And you can select any of these categories and then select the type of inspections that were covered in this report. Like, for example, you can add a visual inspection or any entity inspection. Here, we can add a few comments about the report. Let's say, any text field is a free text field. You can go to recommended actions. So and you can define any executed actions during this report. So let's say, for example, UT measurement and external visual. You can define if there are short-term actions that need to be declared. Who is the person responsible? What department of your company is responsible? So maybe you select any of those, and then you can select a date of when it should be completed by. So let's say by May 6th. Same for long-term actions, and you can have any attachments that are connected to this report. Normally, our clients only consider this. The attachment part is important for them. They can attach the report, declare what type of inspections were covered, and that's it. After that, you can save. And we can see that the report status is here. Other than that, I would like to show you that we have the due dates. So basically, we will indicate when was the last time that an inspection of thickness measurement was performed, and when the next one should be. So we can define that right here. And from the report, it is picking up that as a short-term action, we need to do an action of changing coding on May of 2022. Of course, if you open this, you will see where is this coming from and what is the specific date in which this needs to be performed. A more general view of this can be acquired through the scheduler. The scheduler is the place where we can select a specific plant unit, an asset type, and search for which are the activities that need to be completed. So the last time we made a UT test was on April of 2022 for the shell side of 2693. We also did it for the for E6985, and we can schedule if there is a defined frequency for this. So let's say we can give it every 5 years, or insert a particular due date in the calendar. Let me navigate on how this works. The first two options are to either open a model or save a model. What is a model? The model is the format or the template that we are going to be using in terms of what are the fields that are displayed in the scheduler. In other words, I can say, okay, on my first column, I want the names of the assets. I am not interested on the factory number, so I can go to column list and remove that column. To go to column list, you right click on the header and then click on column list. Okay. And then in column list, you can check and uncheck any of the columns that you want to display in the scheduler. So even, let's say, for RBI, if there is information you need to display to schedule a particular activity, you can do that from here. We will cover that on tomorrow's session when we discuss in detail the RBI side. So we have, when we arrange the columns in the way that we want, and we can save a model. And that means that every time we open the scheduler, we don't have to reselect which columns do we want to display. We can just open a model that we can select from the dropdown, and it will display the columns in the arrangement that we decided. If one of your colleagues sends you a file of a model, you can open it through this icon right here, and to save the one that you're creating through the software, you can save it through here. The next icon is the options in terms of formatting of the colors, let's say, and font of the table. So if you want it in a different font, or if you wanted a different color, you can format this here. You can change the date format. This is just to reassess the way the default of the table is. And the color side is important because it is explaining us how would it look like if, for example, one of the activities is expired. So, for example, it will show us that it will have a red frame around the cell, and if also if it was executed with an offset, it will have a blue frame. Then you can change all these colors by clicking here and selecting a new color. This option is for the model properties. So you can define, this is in order to understand how this should be printed. You can fix some of the columns. You can save a specific P unit, and just give this information to the model that you are going to define. But normally we will help you defining this so that you have the template that you like. For the column properties, we have also it's just the way that they are aligned, so it's not very important. For the column list, is the same that you can access by right-clicking the header and going to column list, which allows you to add or remove any of these information columns. So there are a lot of properties that you can display here that are related to dates and activities definition. So you can decide which columns by the column list. Here, you will be able to see how where the page margin ends based on your defined model, so that you understand how much of it you can fit in printing. You are familiar with this button now, that is the edit button. This one is the multi-select. So if you want to assign a value, for example, to multiple rows or cells at the same time, you can activate this, go to edit, and by pressing the control key, you can select multiple fields, and then right click and just set a date. So for example, you can input the value that this one should be done in April of 2023. And you can apply this to all the selected rows. And now this date is massively assigned to all these particular equipment. Notice that as soon as we apply a due date of the UT, for example, and the due date is not yet reached, the color changed to green, indicating that there is an activity program but not expired yet. If this date was before today's month, so let's say if we assign March of 2022, this will become red, indicating that the next UT is already expired. Okay, this is how you use multi-select and the edit button. Then if you want to save, you can save the data. If you want to see the data sheet of any of these assets, you can click here in properties, and it will open for you the data sheet of the asset that you have selected. This one is to consult the attachments for this particular asset as well. This one is for editing a date. So you can see for this particular asset, there are these activities that were, let's say, expected to be scheduled. So you can change the dates from this window, indicating which one was the last, if they come with a defined frequency, and when should be the next. Is this one right here, the calendar icon. This one is the inspection sheet, where you need to define, is in order to define the preliminary activities that you need to perform in order to do a certain activity. In terms of, let's say, I need to do general cleaning, or I need to do any NDT activity before I can do the inspection that I'm going to do. And finally, you have the expiry planning, that when I select, okay, okay. This is for a specific plant unit. You can see the different activities that have been performed, and you can check if for this year or any year that you select here, how many of these inspections type you need to execute in the month of January, February, March, April, May. On each month of the year, how many inspections or activities of the type that you select here need to be performed on a specific year. Then you have this one, that is to find from the scheduler directly, you find the position of the item in the database. Then you have this, that is to add a due date or add a date. So for example, if I want to add a date on this one, I can say, okay, I would like to add a UT inspection. And then I can assign the date. I can also add more columns. This is also, they will be part of the column list after you define them. And the rest are filters. Filters to understand, look over when the list become very complex, very long, you can activate general filters that help you find a specific range of activities by date or by type. You can also use a search field to find a specific asset name. You can print this scheduler. You can save it as a CSV file or an Excel file, and even create a Word document with these different tables. In the scheduler, let me show you one that is more populated. For example, this one. You can understand when was the last time you performed an activity type, the defined frequency, and when should be the next one. You can see that the ones that are in red, it means that it's already expired. There is one that is not expired on this end, but is expired on this type of activity. And so the general status of the asset would be as expired in terms of activity and programming. We have we have to understand that the planning of activities can be done based on a time-based scheduling, or a risk-based scheduling, or a condition-based scheduling. But that's why you can have different models, and you can have access to different data in the scheduler, depending on how are you going to plan your future activities. To bring in, for example, the RBI data, let me bring an example. Okay, I will make an RBI example tomorrow. I don't have enough data for this in this database, but we will see tomorrow. Let's say whenever we have an RBI inspection, for example, and we declare an inspection plan, the dates in which the inspection need to be performed will be registered here in the scheduler, and we will learn how to do that tomorrow. The software will suggest you a specific year in which you need to inspect, what is the inspection type, what is the percentage of coverage. So based on that, you can either use your scheduler on the IDMS or directly your RBI scheduler. We can also talk about a little bit on this drawing tab. This one is a very basic functionality that allows you to, for example, if you have a mechanical drawing of this particular equipment, you can just paste it here by pasting an image. Let me show you an example. In fact, we were using the the mechanical drawing just now to model the vessel. So let me try to get a snapshot of that, and you will see how you can add an image. That image, normally clients will add a picture of their asset on site to see how it looks on site, or the mechanical drawing of the asset. But okay, let me create a snapshot of this. And okay. I will send it to myself here. Okay. Okay, so let's say I have here on my local, I have an image. I have an image that is the mechanical drawing that we used for this to model this particular vessel. It's as simple as this. You will right click, copy, and then make sure that since we are pasting in the server, I need to make sure that the image is transferred. So yeah, I think I can do it with this better. I will just transfer it to the server. So from here, I can go here, upload. Okay. Normally the process would be you select your asset. You go to the drawing tab. You get your image. Copy the image. And then paste it here. It will be inserted directly on the drawing tab, and it will remain there always. Yeah. This image can be anything, any type, and so I'm just having an issue transferring to the demo server, but quickly that's the demonstration on how to do that. So so far what we have covered is the creation of the asset, followed by creating a 3D representation. That 3D representation, we have assigned conditioning monitoring locations for which we have loaded thickness measurement data that we can visualize directly from the model. We have assigned a P&ID for the equipment. We have filled up a few values of the data sheet for the asset. And we have loaded a few attachments. There is the inspection data loading in terms of visual inspection and UT. We can declare the reports. We can define due dates. We will explore a bit more on this tomorrow, and we have added an image in terms of the graphical, let's say a picture of this particular asset. So in order to before we have a 30 more minutes for the training today, I would like to give you, let's say, an introduction of what we will be doing with all this data. So you may ask, why are we loading all this here? The software has the ability to integrate all this data and facilitate the finding of all these values that we are declaring on the data sheet and on the different fields of the inspections to make conclusions faster. For example, if you have, let's say, a 3D model of a particular plant unit, by right-clicking on the unit, you can go to Overview, and the software will load the 3D model of the plant unit that you have selected. We already know that if we click any element on that model, it will guide us to the position of the asset in the asset hierarchy, and we can retrieve all its information. But besides that, we can visualize some of the data that we have loaded directly into the model. So for example, in this 3D model of this gas dehydration unit, we can see that if I load the piping, I can do very interesting things. Like I can see, I can color code by model by using this palette, color palette right here, by properties that we have already loaded. Like for example, if you remember in the data sheet, there was a field for the fluid. I can paint my 3D model by fluid. So I can understand on each one of these vessels, what is the fluid that is running through these assets. How do I know what color represents what's fluid? I can go to tables, fluids, fluid codes, and I can see the list of fluids with their representative color. Yeah. For any fluid, I can load information such as the NFPA code, the handling instructions, like for example, what personal protection equipment I need, or what are the routes of exposure for this particular fluid. And I can load documents that explain about any properties that I need to consider about the fluid. Other type of color coding that could be useful is, let's say you're looking at this P&ID and you're getting ready to do an inspection. You hand over this P&ID, and if you notice in this setup, there are 3, 6, 9, 12, 13 columns. So this P&ID belongs only to one of them. And if your task is to walk down this P&ID, it is important to understand that a P&ID is a non-dimensional drawing. So we don't know what is the extent of these lines, for example. But if you have Palladio and you have a P&ID and a 3D model, you can color code by P&ID. And if you select a color, the model will acquire in red, or the color that you selected, the extent of the non-dimensional drawing for you to understand how far does this P&ID go in terms of the assets that are registered in the drawing. So it's a really, really powerful tool. In terms of inspection data, how to visualize it, you can color code by inspection. So it will tell you, on this particular plant unit, you have performed these 5 types of inspection: guided waves, thickness gauge, weight loss corrosion coupons, thermography, and visual inspection. So each one of these can be assigned a specific color, and you can say, from this date to this date, show me which assets have been inspected with what kind of inspection. So when you click OK, they acquire the colors based on the inspection that has been executed on these particular assets in all their history or in a defined time range, which could be very useful to track the status of the inspection data that needs to be loaded into the system. Other than this, you can color code with many other parameters. You have a long list here. You can color code by, for example, if you want to color code a specific element, you can say, I want to see that any color code in red all the elbows. And so every elbow will be color code red so that you can identify them quicker. Or any element here can be assigned a color. We can color code the TMLs by thickness. We can color code by many other components. So you can graphically assess the status of your data by using the graphical representations in the software. If you don't have this, if you don't have a 3D model, it's okay also. We have this module here that is the statistics module, and it helps you analyze the data that is in the plant to identify main characteristics that you may be interested on. For example, if I go to statistics, I can see the thickness statistics. This is a useful model that allows you to, for example, go on the TML analysis to understand, okay, in my entire plant or in this P unit at least, please let me know which measurements of thickness were under the limit thickness in the entire unit. So if you search, immediately you know that you have 12 CMLs that are under limit thickness. You know that they are in this plant unit. You know that they belong to this equipment. You know that are on this element of the equipment, and you know the name of the conditioning monitoring location where you have the issue. So with a report like this, you can do further assessment by saying, okay, why do you say that this one is under limit thickness? Let's have a look. If you click here and then click find, you can see how immediately, if I minimize this, it has highlighted the asset in which you have a problem of thickness or a measurement being under the limit thickness. You can go to equipment and it will highlight in red the CML that has the issue. And then you can, as we learned before, activate the values grid to analyze the measurement on that particular element that has the problem. So the connection in the data, it's very powerful. The connection between the way to find and the place to how it guides you to be able to analyze the status. This thickness module also allows you to, for example, visualize the corrosion rate of different assets, of different elements. For example, you can search all the different assets here of this plant unit and calculate the corrosion rate if there is data available, of course. So it will color code for you the status in a way that you can understand, based on the calculated corrosion rate, which ones have an expiry date that is already expired or which ones are in green, which means they are not expired yet, but they have a defined expiry date based on the available corrosion rate. So, for example, I can sort this by color, and I can see that, for example, all these elements here, all this equipment, have a corrosion rate that put them on a status of expired remaining life. Yeah. You can also say, okay, show me only the ones that are expired. So immediately the software will filter and give you this list, and you can analyze as a report. Then you can, if you want to analyze in detail, you can click detail, and the software will show you here the place in which you're having the issue, or the asset in which you're having the issue. So really powerful tools for finding the missing information. And you can do this not only with the corrosion rate, but also to understand the status of measurements of thickness. And you can create a table where you can display more of the information based on your inspection data. So we can look for this data graphically or by tables using the statistic module. These icons that we haven't explored here, the search one is, we already learned that here on the name field, you can ask for a tag or a partial naming of a tag, and it will help you find it on your entire database. The data sheet, it's in order to, when you are anywhere in the software and you click on any asset and you want to see its data sheet, you can click this big button here and it will open it for you. The attachments is also a place where you can select a particular, let's say, level of the asset hierarchy, like for example, a plant unit, indicate which plant unit do you need, indicate what type of documents are you looking for, let's say only survey documents, and you can define also a component type, but let's leave it open for all of them. And then you can search all the different documentation that they have under this category in this particular plant unit. You can download all these documents by clicking download document. You can multi-select and download them all as a compressed file. Or you can, if there is a connection between your data management system, you can open the data management system and visualize the documents through Palladio. The printouts allow you to print the datasheet of a specific asset that you are visualizing. So it's like printing the datasheet but in PDF. The item list allow you to check all the different properties that you want about a particular unit. You can customize the columns to show different properties that are registered normally in the datasheet and in inspection data. Create a template that you can export and you can print, or export this to Excel to fill up more of the missing information. To visualize the percentage of completion of your data, you can also do it through the item list and use this percentage of data filling icon that will let you know, like for example, for how many of my assets in plant unit cluster do I have the serial number? Only for 35% of them. For how many do I have the fluid? 70%. So this will help you understand the completion of details and information that has been loaded for your assets in your plant. For the PNIDs, we learned that we have the record of all the PNIDs and that we can open as a separate window any of the drawings that we have loaded in the system. For the scheduler, we can track all the different activities for a particular plant unit by selecting a specific item type. And then for the inspections, we can find the different inspections that have been performed in the plant in general. You can organize them by chronological order. It will tell you on which plant unit, what item, and what was the type of survey that was performed. For reports, it's the same. It will give you a general visualization of all the available reports. And this will, let's say, conclude the different functionalities of the IDMS. I will like to use these last 15 minutes to see if you have any questions that we can go over, and before we conclude today's session.
Okay, Mr. Alberto, I would like to ask a question about the previous session about how we establish the TML or inspection point at the 3D model. Supposedly, if we don't have the 3D model, can we add this TML on the how do we add this TML if we don't have the 3D model of the equipment?
Okay. Yes, if you don't have the 3D model of the equipment, the way to do it is through the section point analysis. I will make sure, by the way, I want to ask you, in PTKPI, the idea is to manage the CMLs through 3D model or just a table?
In the short-term period, I think it's by the table. We don't have the 3D model yet.
Okay. Okay. So if that's the case, we need to cover this point analysis. Point analysis is a way that, as you can see, the point refers to the measurement point or the CML. So you can declare a CML. You can declare the position or the element in which it is placed, and then you can define the different properties of that element. When you create the CML here in the point analysis, you can do it through Excel, and you can declare all the list of CMLs, and then when you are going to create a survey, you will load the measurements in a table form, no longer connected to the 3D model. Since this takes a bit of time, I will like to maybe start tomorrow's session with this topic, and we should cover it in about 20 minutes, and then we can proceed with the RBI. Is that okay with you?
Okay, okay.
Okay.
And also for the previous session, we have covered the how to add the thickness measurement on the 3D model for vessel type. Could you show us how to add the inspection method on the heat exchanger on the tube side, especially the thickness of the tube?
Yes, the operation is, let's say the inspection is loaded for the entire asset, let's say. Hold on, let me get a, go back to, so when the thickness measurements are defined into the into the asset, you can declare if it's you cannot declare if the measurement was done for a specific part, but we normally do it on a general level. But what we can do is to break down the equipment like this, based on the different chambers, and then let me see. It will still show only that it belongs to the exchanger, but not if it belongs to the shell side or the tube side. Let me consult with my colleagues how can we define this. So your concern is you would like to define if the thickness measurement is for the shell side or for the tube side of the exchanger, correct?
Yes, sir.
I
Also,
believe
we want to know whether we could establish some sort of tube mapping based on the latest inspection survey to the Palladio.
yes, I think we can actually insert the CML on the tubes of the tube bundle instead of the outside of the vessel, and then those measurements will be identified based on where the CML is placed. It will only be related to the asset itself, but based on the position of the CML, you will know if the thickness measurement is coming from let's say an outside component or an internal component. But let me get back to you on how to do that tomorrow.
Okay, and also for the report inspection, or we call it inspection test plan, as you have explained earlier. Can we do it if we don't have the 3D models?
Yes, you can do everything without the 3D model. The 3D model is not mandatory. You can manage everything, every type of operation and data loading without a 3D model as well.
Oh, last one, Mr. Alberto. Can we somehow attach the TML in the, I don't know, the drawing in the 2D section, or is it limited only to 3D models? The feature of the TML.
You mean like have a mechanical drawing where you define where is the position of the TML?
Yes, yes.
Okay. Yeah, we can load let's say an inspection attachment that has that drawing, but it will not be, let's say, linked to the. It's not going to be a clickable item. In other words, it will just display the drawing, and you will be able to read from it the different position of the measurement.
Okay, but will it show in the previous step in the thickness survey report, the drawing, the mechanical drawing?
I think we can add it on the report. Yes, yes. I will show you an example of that as well.
Okay.
Okay. Okay. In that case, I will work into solving those few questions, and we will solve them tomorrow morning before we get into the session on RBI, and I guess we will continue for there. If you don't have any additional questions, we can start the session.
Sorry, Mr. Alberto.
Yeah.
I'm sorry, I have one last question. For the piping, how do we establish the TML if we don't have the 3D models?
Okay, yes, it will be the same process as with the equipment. So I will explain for equipment and piping tomorrow morning with the point analysis instead of the 3D model.
Okay.
Okay. Well, I like to thank everybody for your time today. I know it's been a long session, and I hope it was useful for you, and you learned a few things. If you have time to revisit some of the lessons learned today, and you have any other questions that you would like us to provide some help, feel free to email me or my colleague, or we discuss tomorrow, and we'll be happy to help. Thank you for the first day, and we will continue tomorrow. So yes, just to emphasize what we will be discussing now is some questions that happened yesterday, mostly related to the loading of thickness measurement data when we don't have a 3D model. So I would like to show you that in the software, every time that we have an asset, an equipment, for example, we can go to when we select the equipment and we go to the inspections tab, we will have the list of inspections that have been performed on this asset. If the ID of the inspection is classified as US, it's a regular thickness measurement inspection that is defined on the 3D model. But we also have a section that is called point analysis. And when we don't have a 3D model to define the locations of the CMLs, we can use the point analysis section. That is a table in which we can define the names of the CMLs and the measurement that were captured on each measurement location as a table instead of, let's say, a graphical representation as we do with the 3D model. So how do we do that? First of all, I would like to show you that the place to register inspections and CML when you don't have a 3D model is still under the inspection tab, but then we go to point analysis.
Sorry, Mr. Albertus, but in the demo plan, how do we bring up the tab of the point analysis, because we don't have the tab in the demo plan?
Yes. So in the demo plant, you go to your plant unit, select an asset, and then go to inspections. Here it says point analysis. In the point analysis tab, we can do a few things that include the registration of CMLs in a table. So let me open a guide here. So basically what we do is we create a new survey by clicking the button New Survey. And we are going to define that the type of inspection that we would like to declare is a UTP, a UT through point analysis. So here, the UTP type is called thickness gauge points. And when we select this, we are able to register a thickness measurement using the point analysis. we are going to be asked to declare a few more things, like the inspection company, the person who executed the inspection, the supervisor, any notes, the result, and the reason for performing the inspection. When I click OK, I will go to this window. So in this window, what I can see is that I will have different fields. One for the points that I'm going to register, or the measurements. I can have a definition of the position of those points, on which element, the properties of the element in which they are located, and the date of the survey, the value of the measurement, and some other information about the instrument and the surveying company. So how do I populate this table? I have to here in the, I have an Excel file option in which I can download an Excel template. I'll put it here on my downloads. And then what I can do is open this in Excel. Okay. So what the file looks like is a table like this. This file will be, sorry, 1 second. Yeah, sorry. This Excel file is to download the table once populated in Excel so that you can create a report. But the option you need to use is this one to prepare the thickness measurement points. So sorry about that. I will download this one. Okay, now we have a table like this. What do we see here? This is the table that we need to fill up to load our thickness measurements. So as an example, we can say that, for example, the columns A, B, and C, they are fixed because they are indicating from which plant unit we are analyzing an object, what is the name of the equipment, and the internal number assigning the database for this particular equipment. So what we need to do next is to say, okay, I am going to add, for example, let's say 12 measurements. And these 12 measurements are going to be defined as, they are going to be part of this same plant unit, this same equipment, and this same object ID. So we can replicate that. The point name is the name that we're going to give to our TML or our CML. So for example, I can say, this is CML 001, number 1. Measurement 1 on CML 1. Then we continue to do CML 2, measurement 2. Let's say we have 4 measurements on CML 1. Then I will create CML2 and CML3. I'm just gonna replace this one here. And CML3. Okay, so basically we're giving the name of the CML plus the let's say the number of the measurement within that CML. Then in the position, we can indicate on which element it is located. For example, we can say it's on the shell. Here is if we need to access this point using scaffolding or not. So let's say no. And here is a bit of properties of the element. So the nominal diameter of the element, let's say, is the shell of our equipment. The nominal thickness. So we can have a look here. What was the nominal thickness of our equipment? And the shell has a nominal thickness check here on the properties. I believe we said 15, okay. So we can use value 15. The corrosion allowance is 2. And the limit thickness 13. So then we will also populate the values of the reading. So what was the reading on each one of these measurements? We will be populating that on column M. So I can say, for example, that the readings were 14 for all of them, just to make an example. And this is what we need to fill up from this template. The survey date, the temperature, operator, and nodes, we can do it directly from the software or from the template as well. But when I save this, and I upload on my server, then I can go here and just, let's say, load the new survey by going here, defining the UTP, and we didn't define a date on this one, so it's okay. And then just adding a few more of this field. Here, I have an option that is called load Excel values. So I can click this, look for my Excel file, and click open. So let me see. I think I have a mistake here. The point name. Oh, cool.
Mr. Alberto,
Yes.
in the position column, do we need to fill the name of the position the same as the component that we add the tick scope to, or we
Yeah.
can use another name?
You can use another name because it's a free text field, so you can add anything you want.
So it only linked to the equipment or the component of the equipment that we assign it to. Yes.
Yes, only to the equipment.
Okay.
Okay, I see what is the error here. This is not the same equipment. I made a mistake. I was changing the name of the equipment all throughout the 12 rows, so let me just make it the same. And the same for the object ID. Okay, that should work now. Let me verify that this, yeah. Sorry about that. Let me try one more time. Okay. Now. To the server. And load this one. My name and code. This is unusual. I don't know. Let me see if I can show you over here. Okay, I tried this last night. I think this is how it will look. I will check what that error means, but normally the procedure is like this, just to summarize. When you select the asset, you go to point analysis. In point analysis, you can download using this green arrow an Excel file that will look like this. The way to fill up the information would be in the following way. You will have the name of the plant unit in which the equipment is. So in this case, PTKPI training. Then the object name, that is the name of the equipment, E6985. Then the object ID belongs to the equipment, so it's the same all throughout the rows. TML ID is just the numbering, and it's not reflected here in the final table. The name of the CML is declared here on the field point name, and is what you will be looking at here. So we create one per measurement. The position, I have interpreted this as the element in which the CML is located. But after your question, it's good to clarify that you can have any description on this text field. It doesn't affect anything, because this is not really connected to the shell. It's just an indication of the position. It's a free text field. If you fill up the necessity of a scaffolding, yes or no, it will display here as well. And then for the nominal diameter, the values are in millimeters. It will display here. We have also the nominal thickness, the corrosion allowance, and the limit thickness over here. Now, every time that, for example, these values of 14 are indicated on a date that I created on February 1st of this year. The way that this is shown is every time you upload an Excel with the measurements on column M, it will ask you of the date when you click on New Survey. So on the New Survey field, you can define the date of the survey, also the inspection type. Please remember to declare as UTP, and then define the result and the reason. After that, you will be able to load the Excel values from your Excel file. So you can use this Excel file, and maybe let's try to change here the measurements and make them all 13. So if I change this, in fact, if you have already a file like this, a table already set up like this, you can download the table first by clicking here. And then you will be able to visualize that in Excel. Just like this. So after that, when you click Enable Editing, you will be able to assign the new values for readings. So let's say that in this case, all of them went to 13. Then save the file. And then upload it by creating the survey. Okay. And loading the Excel file. So you can see that the also here it is important, this column INC means included, and it is if some of our clients don't like some of the measurements to be included in the calculation of corrosion rate. So if you don't want a particular measurement to be included in the calculation of corrosion rate, you can remove the check mark on such measurement through this table. And then once you upload the Excel file like this, you will click OK. And as you can see, now you have a new column of measurements for today's date. So the software is immediately based on the measurements loaded. This is the history of thickness inspection that have been loaded. So it becomes one in February, another one yesterday, another one today. And using these measurements, the software is calculating the values for short-term and long-term corrosion rate. This is how we work with the point analysis. We had a question also yesterday about the possibility of having, let's say, a visual of the position of these CMLs if we only have the tables. So the different visuals that you can get here include, first, this is the trend of corrosion rate. So it shows how the thickness is changing over time here, going from 14 on the first date to 13. And you can see this for every CML.
The red line is the limit of the safe thickness.
The limit thickness, yes.
Okay.
Yes, green line is the measurement, red line is the limit thickness. You will also be able to see here, in case that you want to recalculate the corrosion rate, it remakes the calculation. And also, when you go to upgrade surveys, you have the possibility to visualize any of the surveys that you have loaded here. And I remember that there was a question yesterday about if we can have, for example, an isometric or a mechanical drawing indicating the positions of the CMLs. So the place to do that is here on attachments. So each survey will have an attachments box where I can, for example, add an image. Let me find something. That by pressing edit and then new, I can attach an image, like for example, this isometric, and say inspection drawing. Just click OK. So I will be able to see that attachment every time I access my survey through here. My attachment is there, and I can open it. I don't have a way to visualize image in the server, but you can see, you can have the image there. It will look like something like this. So you can have an image of your piping or an image of your equipment indicating the positions of the CML just as an attachment, but directly connected to the survey repository on each different date.
Okay.
Okay. This is I'll have a look into the error I got earlier, but this is normally the procedure to be able to load measurements. This is how they will be displayed. The options are very basic. This one is to, whenever you have a lot of measurements, you can lock the columns so that if you scroll around, the names of the CMLs don't move. And the rest we have already seen. This one is to print and create an Excel file so that you can have like a report exported to Excel. And it just pretty much extracts all these fields, but without the possibility of upload. It's just for, let's say, printing or editing purposes. And the way that looks is like this. So it would be just the same table that we see in Palladio, but it will be extracted to Excel with all the different dates of inspection and the respective measurements and calculation of corrosion rate. The other option, this one was for the template to upload the measurements. This one is to visualize the trend of change of thickness over time. This one to calculate the corrosion rate if these fields are blank. and this one to access any of the declared surveys. Notice that in the survey list, we still have the possibility to visualize both. So for example, for clients that, let's say at the beginning, they say we're going to manage this through tables, they can follow up and upgrade to 3D models. They can register both types of measurements. So you can still visualize 3D, or if you don't have 3D, you can visualize your tables. So in the survey list, they will still have the possibility to visualize all the different inspections, independent of how they are registered. So, yes, any questions about this?
I'm sorry, Mr. Alberto. I still don't understand what the calculated corrosion rate. What is the difference between short term and the long term, and how does those value calculated?
Yes. Let me explain. I think how to this. Okay. So the short term corrosion rate works like this. We have the measurement. So the thickness of the previous inspection, the thickness measurement of the previous inspection minus the thickness of the actual inspection divided by, divided by the difference in time, let's say delta T, between the previous, the actual minus the previous. So let's say if you have an inspection in 2005, or no, in 2010, and the value of the reading, the thickness of the reading was 15 millimeters, and then you perform an inspection in 2015, the thickness captured was 13 millimeters. And then we did one in 2022. The thickness was 12 millimeters. Then how does the short term work? The short term would be like this. The actual thickness is 12. The previous to the actual was 13. So the short term calculation will be 13 minus 12 divided by, in this case, the difference in years of these two, which is 2022 minus 2015. So this would be the short-term corrosion rate that has units of millimeters per year. The long-term corrosion rate would be like this. Instead of the previous thickness, it will be either the nominal thickness or the first thickness measurement register. So let's say that my vessel had the baseline, or the first measurement was in 2010. So in this case, it would be the initial thickness minus the latest one divided by the difference in time between those two. So in this case, the long-term corrosion rate would be 15 minus 12 divided by 2022 minus 2010, and that would be long-term corrosion rate. And now we can continue. So let's say moving on to the let's say in the training, we can see that when we register all the inspection history and all the technical data for the assets, we end up having something like we discussed earlier. We have the graphical representation, a P&ID, a data sheet, the attachments, the inspection history, and the schedule activities based on that inspection history. And we are going to see now the side of the RBI. So I would like to start doing an introduction about Palladio RBI. And Palladio RBI is the tool that we are going to be learning now. It's going to be fundamental in the calculation of risk. And so before we get into that, I want to make sure that we are in the same page and we understand what does this mean. So starting by what is RBI? RBI, or risk-based inspection, is the process to assess the industrial risk that is found in assets of an industrial plant. The idea of the main purpose of the RBI is to understand how to define a proper inspection plan, indicating when should I inspect, what type of inspection should I provide, or how should I inspect it, and where should I inspect, which assets should I be worried about. So an important outcome of the RBI is to be able to prioritize the effort of inspection in your plant. You will understand, based on risk, which is that 20% of the assets that are the driver of the risk in your facility. And normally that is the distribution we have of the 100% of assets that we have. Normally 20% are the ones that have the higher risk. And so it makes sense that we don't treat them equally with the other 80%. We emphasize our efforts and our resources of inspection to take care of this 20% that is either very likely to fail or has a very high consequence if it fails. The concept of risk is an assessment that is as I mentioned earlier, defined by the combination of how likely is an asset to fail, or what is the probability of an asset to fail, and how severe or how big is its consequence if it fails. In API 581, the definition of failure is loss of containment. So if there is a leak, or if the fluid that we are managing it's escaping from the process line or the equipment, then we have a failure. And this has different types of consequences that are assessed through the risk-based inspection. Whenever to define risk, we calculate probability, how likely is this to happen, and how bad is it if it happens, And then we define this normally on a risk matrix. The risk matrix has different risk areas that, if we follow API 581, are normally defined into low, medium, medium-high, and high risk. An asset that is on, for example, on area 1E means that is very unlikely to fail, but it has a very big consequence if it does. So still the risk is medium-high. And we need to pay close attention because of how big is the consequence of failure. There are different approaches in terms of how to perform an RBI analysis. You can do a qualitative assessment, a semi-quantitative assessment, or a quantitative assessment. The qualitative assessment is a relatively fast procedure. We require a low level of data, and the result is just a positioning of the asset within the risk matrix, indicating if the risk is low, medium, or high, but it cannot go to the level of defining numerically what is the value of what is the, let's say, the required inspection effectiveness based on a calculation, because it's all qualitative. It all depends on the experience of the inspector based on the grading system in which the questions are answered on a qualitative assessment. So even though it is fast, it's not as precise as a quantitative analysis. In Palladio, you have the possibility of doing a qualitative assessment. We normally, we will see later how to do this. And if you want to do this, is normally for groups of assets, for example, corrosion loops, or you can do it for an entire area, but it's not very precise. So we recommend that if you have the tool to do the precise risk analysis, do it with quantitative. Other approach is to do a screening of a grouping of assets with a qualitative assessment, and the ones that indicate medium, high, or high risk, you go more in detail, analyzing their components individually through a quantitative assessment. A semi-quantitative assessment is a combination of partial experience input plus numerical input. So it's in the middle. We have the possibility of making some semi-quantitative assessment, but it's mostly for defining susceptibility of damage mechanisms in the quantitative assessment without actually performing a calculation. I will show about this later in the software. Instead, the quantitative is following the model of API 581. Here we have all the different formulas that are considered to calculate a value that is called a damage factor for each damage mechanism that could possibly affect our asset. So we will calculate a damage factor that is combined with other parameters like the generic failure frequency and the management system factor, for example, to calculate a probability of failure in a numerical way. And in the consequence side, we will be able to calculate different scenarios of consequence that include toxic, non-toxic, flammable, personal injury, and so on, for different sizes of holes that could possibly occur in our asset. So it's considered as a small, medium, large, and rupture. More on this quantitative, but let's say of the risk assessment approaches is the most specific one. And And the good thing is that in the software, you have the tool to do any of these assessments. Normally, the standards that follow these different approaches are listed here. For us, by default, we have API 581 covering both the qualitative and quantitative. And we have also the possibility of doing some semi-quantitative by defining susceptibility of damage, which is a fourth input by the user. A typical RBI process will involve not only one assessment. Sometimes you need a combination of both. Maybe you can start by creating your item list, defining your corrosion loops, and then create a qualitative assessment. Whatever is low risk, you can go directly and based on your experience, define an inspection plan. And whatever is high risk, you need to do extra data collection of the process, the inspection history, documents, all the different analyses that you have, which is what we discussed in the IDMS side, and perform a quantitative RBI assessment, followed by an either automatic or manual inspection plan based on the calculated results. This is not a mandatory workflow. You can, in fact, straight up do a quantitative without doing a qualitative. So it's just to show that an RBI project can have more than one methodology or just one, depending on what is your objective. In terms of the RBI process, normally it's the data and information collection, followed by the calculation of the probability on failure and the consequence area. This is then the combination of these two parameters will be what is used to perform a risk ranking and then define an inspection plan. In the inspection plan, we will understand when is the time to perform our inspection, what kind of inspection, and what is the percentage of coverage. And we will also understand if maybe even the highest level of inspection cannot bring down our risk under the target or limit risk that we don't want to exceed. And in that case, we can consider a mitigation. A mitigation is maybe a repair, a replacement, a redesign, something that requires changes and that will result into a reassessment of risk, which restarts our data and information collection process and goes through the whole workflow once again. In Palladio, we have the possibility of visualizing the results of RBI, mainly by default in two different matrix formats. One of them, both based on API 581, one of them is the unbalanced risk matrix and the balanced risk matrix, which are these two over here. You can see that the difference is the way the areas of risk have been distributed in terms of which ones are considered low, medium, high, or high risk. This is normally depends on what type of process you run in your facility and how do you want to manage your risk. There are some customers that leave more room to they are more strict in terms of the consequence. So they consider medium risk when it's on area C, and others that prefer the balanced, where area C is still it's still a low risk area. And so it really depends on what kind of practice you can do. But remember that the result of risk will always be the same. The value of the calculated risk will always be the same, and the way in which it is represented or positioned in the matrix, it can be defined by the user on either an unbalanced or a balanced risk matrix. On some other risk assessments, there is the necessity to create a customizable risk matrices that we can do as a service. In fact, we have done it for many clients where they have their own methodology. For example, we can add it to Palladio, not only API 581, but any other international standard or even proprietary methodology. And we can create the respective risk matrix for their assessment and the representation of the results of their assessment. What do we see in Palladio? We will be able to see a combination of three risk matrix. One of them is the one that is going to represent the present risk. So after we finalize a calculation, it will show us where is the risk of the asset today, or let's say the date in which the assessment was made. What would be the future, the predicted future without inspection? So if you don't perform the suggested inspections of the RBI assessment, what would be the position of the asset in the risk matrix, if it's gonna increase or if it's gonna stay the same, to help us judge the importance of following up with the inspection plan. And then we have the future with inspection that shows you if you follow the recommended inspections, this will be your position of risk within the matrix. This is how we can also, let's say, visualize at a plant level. This is normally when you have just one point is like showing only one asset. But if we look at it at the plant level, we will be able to see numbers that indicate the numbers of assets within the plant unit that are on each risk area. So this is what we will see here. And the way that I was telling you of comparing the present, future without inspection, and future with inspection is the opportunity that we have to understand what will be the redistribution of the assets in these three different scenarios: present, future without inspection, and future with inspection. You can see that in this particular example, two of the assets are in high risk in a future without inspection, also in the present. But if we perform the appropriate inspection, we no longer have these high risk assets. So it's the idea of being able to see the benefit of the RBI analysis here, and how the suggestions can help us reduce the risk or bring it under the target. Okay. Here, every time that we will see this during the demonstration, but every time we do a new project of RBI, we have the possibility of visualizing the window that we see here on the left. And that window shows all the different projects of RBI that we have performed in our facility. And it also shows me the setup scenario in order to customize my study. So first of all, I can give a name and a date. I can select what types of methodologies I will be using. If it's a screening, which is the qualitative, or if it's a detailed analysis, that could be either semi-quantitative or quantitative. Okay, so by selecting the type of methodology and the type of matrix format, if balanced or unbalanced, we proceed to define the list of families of damage mechanisms that we will be using in the analysis by checking the boxes and adding them to the study. We can also indicate how in the quantitative analysis, the probability of failure will be calculated if following rules of API 581, same for consequence and same for the inspection plan, or if we have an alternative way of calculating probability, like for example, consider the maximum damage factor or the sum of all the damage factors, some specific rule like that. But normally we leave it as API 581 and we follow the standard. In Palladio RBI, we have the possibility of, at the welcome screen of the RBI management module, we have the possibility of visualizing all the different data that was used or loaded for the calculation as a table that, as we see here. This table will be divided into different sections that involve the result after the risk assessment is complete, the basic data, that was the basic data input that we had to make in order to perform an RBI analysis, the information for each damage mechanism that was considered for the analysis of probability of failure, calculation of consequence area or financial consequence, the inspection plan, and others. In terms of the calculation of probability of failure, we have to consider for example, the sum of different probabilities is one option, the maximum between probabilities, or following the API 581 probability calculation. That, in fact, is what we will be doing, and that is defined as the combination of the generic failure frequency, the damage factor total, and the management system factor. So in the software, we will see how these parameters are defined, and most importantly, how do we get the values for the damage factor total. Depending on the thinning type, if it's local or general, the damage factor will be calculated using either of these two formulas. So you will see that the damage factor total based on the thinning type that you select will be either the maximum, the combination of all the damage factor families plus either the maximum between thinning and external, or the combination of the two with all the other families based on the type of thinning that we select. Okay, for the consequence of failure, we, as I mentioned before, we will calculate the flammable, toxic, non-flammable, non-toxic consequences depending on the fluid type. And we can either have a calculation based on area or financial. What is the difference? If we do a calculation based on consequence area, we will understand in meters squared what is the affected, let's say, area in case of failure. For the financial, we just give a different monetary values to understand what will be the financial impact within that area. So you can either measure the damage by an area of let's say the affected area defined by the consequence area, or you can define it by money, doing a financial consequence calculation. So first, you either way, you need to calculate the area that will be affected, understand what assets are around the affected area, and what will be the cost or the financial impact if all the assets in the surroundings of the affected area are damaged or are affected by the failure of a particular equipment. So for financial consequence, in addition to the calculation of the consequence area, we will need to give prices of, for example, we need to declare the number of people that normally work around the area. What would be the cost of repair, the duration of a repair, cost of a full replacement of the asset, all these different monetary information, and even the cost of stopping operations during the repair time. We have finally we reached to, let's say, the risk calculation that, as you know, it could be just the combination of a probability and a consequence. So it doesn't matter if it's a consequence area or a financial consequence. Both are consequences, and the probability is it's still the same. In the risk matrix, the vertical side represents the probability, and the horizontal side represents the consequence. Each component in an RBI analysis will have a position in the risk matrix. In other words, it will be a part of a risk ranking that indicates on which risk area it is going to be positioned. In terms of the process of the calculation of the inspection plan based on API 581, we aim to define when do we have to inspect, and what is the type of inspection, including the percentage of coverage that needs to be done based on the calculated effectiveness. So for this, the user needs to, or the RBI engineer needs to define something to begin with, that is the risk target. So we need to be clear on what is the risk that we will not like to exceed. And then what the software does is, starting from the present or the moment in which the RBI analysis is performed, the software will calculate how much time would it take to reach that risk target. So, but it is performing this calculation based on a plan date, which is a date in which we are assuming that we are doing our next shutdown, our next mandatory inspection, or just a reassessment of RBI. And it will give us a target date that is saying, okay, do you need to inspect before your plan date or after your plan date? So in the case that the RBI date, which is equivalent to the plan date, is later than the target date, then an immediate inspection is recommended. And then if the RBI date is earlier than the target date, the risk limit will not be reached, and therefore you will not need to perform, or it's not recommended to perform an inspection. These are the three cases declared on API 581. So it's the risk increase at the moment of the risk target. There is a indication that at the moment of the plan date, the risk is already exceeded. So you need to perform an inspection. If you perform a reassessment, this would be the impact of the RBI assessment, and you will see how to keep your asset under the risk target. These A, B, C, D levels here represent the effectiveness of inspection that you will perform. If you have to perform an inspection and you have a class A, it will substantially reduce the amount of risk compared to a B, C, or a D. But of course, these A, B, C, and D effectiveness inspections have different costs. have different requirements. So you need to assess which one is the most appropriate one to define. And this is the case 3, in which when we do the calculation, we realize that we never reach the risk target in a reasonable time. Normally, the software calculates up to 25 years. And if you don't reach your risk target up to 25 years, then no inspection will be recommended. Speaking of A, B, C, D, and E types of inspections, what we do is we either define at the end of the calculation a manual inspection plan or an automatic inspection plan. A manual inspection plan consists of all the damage mechanisms that are active. You will need to manually define what is the effectiveness of inspection that you would like to apply, and on which date. So you manually define that, and then the software can calculate if there is an impact in reduction of risk based on the manual dates and effectiveness of inspection that you have defined. If you perform the automatic inspection planning, the software will automatically recommend the inspection plan based on API 581. So it will target the worst possible damage mechanism that was detected, and it will suggest to you what is the lowest inspection effectiveness that you can apply in order to bring your target under the risk target at the plan date. So in API 581 there are different types of effectiveness. We have levels A, B, C, D, and hopefully we never get to use E, which is ineffective. But normally we consider A, B, C, and D. So A is highly effective, B is usually effective, C fairly effective, and D is poorly effective. So the impact is that the inspection method selected will identify the true damage, correctly identify the true damage state in nearly every case on 80 to 100 with an 80 to 100% of confidence. This is a highly effective inspection. And an example of what that could mean is for every particular damage mechanism, there will be a table that indicates, okay, for thinning, for example, the highly effective inspection requires that if you do an intrusive inspection, you need to make sure that if you want to comply with a highly effective inspection, you need to do 100% visual examination with removal of internal packaging and trays, and 100% follow-up at the locally thinned areas. And if you do a non-intrusive, you need to do 100% coverage of the CMLs using UT scanning or profile radiography. So for each damage mechanism at different levels of effectiveness, it will suggest you what type of inspection, what percentage of coverage you will need to perform. So in addition to this, we also give you the year of when this should be performed. That is the result of the inspection plan, and that's the calculation of RBI. We have the whole interface in order to proceed with this calculation. So basically, we have an interface for data entry, an interface for calculation, an interface for the visualization of the inspection plan. In Palladio, as we have seen, we can do many things in terms of managing the RBI results, including color coding our 3D model if we have one by risk, visualize the risk calculation for each asset through our Palladio tabs, and we can do more things like define the corrosion loops on PNIDs, visualize the inspection results, and consult the data that we will eventually need to be using in our RBI assessment directly from our IDMS interface. So we will see how to do all this by looking at the software next. So so far, after this introduction, any questions about the presentation?
I think we can move to the next section.
Okay. Okay, thank you. Okay, so for this part of the training, we will need to be using some of the things that we have already learned, like for example, creating the asset. So for the beginning of the RBI analysis, we need to make sure that our asset exists in our asset hierarchy. So just as a quick refresher, I'm going to, for example, here in my plant unit, remember, to create an equipment, we can right-click, go to New Sheet, define the name of the asset, and then please remember that it's important for the RBI purposes to go to Construction Data, RBI Components, and define the chambers. So the shell side and the tube side. Okay, that is the bare minimum we need to create our equipment. Remember that if you're gonna be loading more than one asset, the way to do it is through the items list. So at the moment, I only have one piping here. So I'm going to load a few more. Remember that in order to do this, we go to the item list. We look for our P unit, select the asset type, export the Excel file, and open it here in Excel in order to add the different line list. So to add the line list in the Excel, we can open the Excel file, add here on column C the different lines that I would like to consider, and extend the column A valori to match the number of lines that we have added. After that, I can save the file and upload it back in the system. So I go back to Palladio to upload my file by clicking on Import and selecting my Excel file, so that I have the complete line list. After this, I can just exit, and I can see that if I refresh my plant unit, I have my whole list of piping, the 3 equipment that I have, And maybe we can consider also a pressure safety valve where we can create a new sheet. And in the code, we just give it the name. So this is just a refresher on how to create the assets. Yeah, we can either do it manually by right-clicking the asset type and clicking on new sheet, or we can do it through the items list by uploading the Excel file. Now, these assets only exist in my asset list, but they are not yet part of my RBI project. How do I start an RBI project? Here in applications, oh, sorry, one more thing. If you have in equipment, you need to make sure that you declare the RBI parts or the chambers. In order to visualize, if you have already done that, you can click on display and then RBI. And now you will see the ones that have this declared. So I can immediately tell that E6985 doesn't have this. So I can go quickly to the data sheet, construction data, and define the missing chamber. So I can say on this one too. And oops, sorry. Okay, so now that I have this, I can start my RBI project. All my equipment have the respective chambers. I have a list of piping, and I have at least one safety device. How do I start an RBI project? Here on applications, we have a tool that is called RBI management. If I click on RBI management, I will be able to see this window here, this interface that is called the RBI Studio. The RBI Studio, if I click here on RBI Studio, there is an option that is called management. And in management is where we can create our new study. Before I go here, I would like to explain what can you see on this window. You have multiple buttons. One of them is the edit button. The other one is multi-select. So, but the first one that you need to start using is the study. So here on the study list, you have all the different RBI analyses that you have performed within your database. I'm gonna select an example. Here we have all the different results of an RBI analysis that we performed in 2018. So here you can select different studies and visualize all the data that was loaded for that particular study that you have selected. Notice that an RBI study can have more than one plant unit involved. Like for example, this one involves the alkylation plant unit and the gas dehydration plant unit. But here is just to select the study. We haven't covered how to create it yet. I'm just showing you that when you have a study, the data that you load for it is going to be visualized in this first, in this main screen. This main screen has different tabs in the bottom. It's like an Excel file. It's exactly the same setup as the Excel file. If your project has both methodologies active, qualitative and quantitative, you will have this here that belong to the qualitative assessment. So these two tabs are the information that you will need to insert to do a qualitative assessment based on API for the calculation of probability and consequence of failure. Qualitative, only these two. In terms of quantitative, the input of data is divided like this. We have basic data that are just parameters that are, for example, the equipment type, component type, geometry, installation date, the diameter, the volume, operating temperature, design temperature, all very basic data, pressure data, yield strength of the material, many basic information about the asset itself. And then we have tabs for every specific damage mechanism family that we will be evaluating. So we have one for thinning, we have for stress corrosion cracking, high temperature hydrogen attack, mechanical fatigue, external, brittle, lining, and then this data input will be at some point combined as a total damage factor together with the management system factor and the generic failure frequency to give us our probability of failure. So all this is just to visualize the database of what data we input for each one of these damage mechanisms. Then we have the consequence area, is the place where the data to calculate the consequence is in terms of area. And if we have financial, we will also have those values here. So as I mentioned before, for financial, we need to declare some monetary values in US dollars for, let's say, environmental cost, equipment cost, injury cost, population density, production cost, and many others. And also we have the inspection plan that will allow us to see, this is important on the Excel file, because in the Excel file you need to define if the inspection plan after massive data loading through an Excel file will be calculated automatically by the software or manually by accessing the calculator and doing it on your own. You define the dates and the inspection effectiveness for each applicable damage mechanism. Nothing to worry about this. This is just for you to understand that you can visualize your data input directly on this page, but this is not where the calculation happens, so don't worry about this too much. Now, notice that what we are looking at here is defined by the item type. So if you are doing an analysis for equipment, piping, and pressure safety valves, each one of those is going to have a different data sheet, a different input, and therefore we have different templates. So this one is for equipment, but we also have for piping, for example, and we also have for valves, yeah, and any other component or asset type that you see here. Now, this lining bolt is simply a button that is used to refresh the page and load data. In case that, let's say, you make a change and you don't see it immediately, you can refresh the page. And then here it will indicate you what is the plant unit in which the asset that you select is located. If you change, it will show here, but it's kind of repetitive. We can see it from the left side. This is more useful in the case of corrosion loops, for example, where it could be from more than one. Let's go about the buttons here for a minute. Edit is to be able to make any, let's say, selection on this table. Multi-select is to be able to select more than one row at a time. Normally, notice that each row doesn't really mean that it's one asset. For example, if you notice, the first 3 rows are the same equipment, but the RBI component is different. One is for the channel, one is for the shell, one is for the tube side. So each row is based on each RBI part. So you may assume that if I, for example, add all these 3 heat exchangers in an RBI analysis, it will result into 6 rows because each one of these has 2 chambers or RBI parts. The multi-select tool allows you to, by pressing the Control key and then click, select more than one row at a time to perform an operation or to assign a value, to do different things. This one is to be able to fix the column. So it will allow you to fix the equipment name and the component name, and then you can explore over the input data. And you can activate and deactivate that based on your preference. This one is the matrix visualization. So if I select an asset and I want to see the matrix only for this asset, I can click here and it will show me if I want to see the single matrix for the asset after the calculation is complete, or if I want to see the group matrix, which is the resultant distribution of the assets of the entire project in which this asset was part of. So we will see the distribution here. You can see that all these numbers on the risk areas, if we right click, we see to which asset, to which RBI component is laying on this particular risk area. Okay. This one is to be able to find the item. So if I am looking at an RBI analysis and I'm like, okay, I would like to see more information, or what information do I have in my IDMS about this? You just click on the asset and then find the item. And as you can see in the background, our window changed to find the item in the asset hierarchy. And then we have how it looks like. We have the PNID, where it is located, where in the PNID, and datasheet attachment, inspection history, and so on. So this is just to find an item that is part of an RBI project inside of our IDMS. If you would like to do a search of a particular item within a list of assets in an RBI project like this, you can use this and type here what you're looking for. Then you have the possibility of printing these results or basic data or any section of the tables by using the printer icon. This is also it will print the reports for any of the assets that you select. So we can print a PDF file or print a paper based on the RBI report. We will see that during the calculation. It is important that it is outside here because normally we print a report directly from the calculator for one asset. But if you want to print all the reports at the same time, then we can use the tool of edit and multi-select, select all the different assets for which I want to print the report, and then click print. So it will create one PDF file for each one of the assets with the inspection plan results. So yeah, then we have this icon is very important, is the one that allows you to export this to Excel so that you can do a fill up of some of the values that that you're gonna need in terms of basic data or data that is necessary for the calculation. You can fill this up through Excel. It's very useful because especially for repetitive parameters where let's say you have a list of lines and they are all of the same diameter, you can just copy paste the diameter value on the line list and populate this kind of data in a faster way than if you do a single asset analysis. We will look into it later in the assessment. And whenever you have this file ready, you can load it using the import external file icon that is right here. These next three buttons are very important because these are the calculators. So for any of these assets here, we can perform a qualitative calculation using this button, or a quantitative using consequence area, or quantitative using financial consequence. These are our calculators. You can filter any of the columns. So there are different filters, like if you don't want to see some of these values, you can hide them. Then you have, if you are looking at the results, for example, this is very useful because you can use this one, that is the matrix filter, to say, for example, show me only from this entire analysis, only the ones that the current risk is medium. So if you click OK, also you can further define filters saying, I wanted only the ones that the current risk is medium, future without inspection is high, and future with inspection is high, or any other filter. But if you can see that if you click OK, it only shows you the medium ones. You can deactivate the matrix filter and look at your data. These next two are also very important. They are the RBI scheduler and the inspection descriptions configuration. So the RBI scheduler, when we finish an RBI analysis, allows me to open another tab here that extracts key information to create a report in terms of the equipment, the component, the equipment type, component type, and so on. It extracts key information of the calculation, and it gives me a bit more simplified visualization of the risk matrix or the RBI date, what was the target date and the plan date, and what were the results in terms of the risk matrix at the plan date with no inspection versus with inspection. And here we have a very important part that is, for each one is the date or the year in which we are receiving a suggestion of inspection, and what is the required effectiveness of inspection. There is an important part that is this icon will allow you to understand if the result is telling you that you need to perform a highly effective inspection on a particular damage mechanism that is thinning. This table is describing for each damage mechanism what is the definition of highly effective, poorly effective, usually effective for all the damage mechanisms. So, for example, here we have a highly effective for thinning, and this is the recommendation based on API 581. So it gives you options if you're doing, if you define general thinning or local thinning, and if you're gonna perform an intrusive inspection or a non-intrusive inspection. We can automatically populate these nodes into this report. For that, we have a tool here that is called inspection nodes calculation. And what happens, as you can see, is that the software will populate based on the required effectiveness for the specific damage mechanism, the node that indicates what type of inspection you need to do based on the API recommendations. The other option that we saw here, besides the inspection nodes calculation, is to overwrite the RBI study inspection nodes. When we print a report, if we would like to force this node to go to that PDF report, we can overwrite here, and this will result in the update of the software, so that if I print the report for this asset, it it will include that inspection note. So these are the purpose of these icons right here. Then when we have activated the RBI scheduler, we can save it on Excel like this. And then we can also, if we have to customize some of the notes in the scheduler, we can import them from that same Excel file. Then we have these 4 icons here that are very important in the, let me go back to here. These are useful to define the session status. So basically, this one indicates that the study is open or is being is under completion. It's still not ready. It's under process. Then the next one is the tool to select that the study is ready to be verified. So whoever is doing the data loading, as soon as this is complete, they can set it as verified. Then his supervisor will revise or review this and then say, declare, okay, this is ready to be closed. And only the people that we defined in the RBI project setup can define that this analysis is fully closed and is ready to be transferred to the database of the IDMS. So this is the status of the session. These 3 icons here. Yes?
Mr. Alberto, if we haven't verified this RBI status, it will not connect to the IDMS, or still connected?
It will always be connected. It's just that the status is important in order to be able to define, for example, deadlines or program activities, or be able to also do a reassessment of this same equipment in the future. Because let's say if you are including this item in a project and you don't close it, when you want to use that same asset for another RBI analysis, it will tell you that it is still open in another RBI analysis and it won't let you further analyze. So that's the purpose of closing the study.
Okay.
We have 3 more icons here that are very similar to these 3. But the difference between these 3 and these 3 is that even though they are also for qualitative, quantitative based on area, and quantitative based on financial, these 3 are to do an automatic calculation after data loading through Excel. So this one is to calculate one by one. This one is to, if I massively populate the data through an Excel file, I can select them all and then run an automatic calculation for it to calculate the risk. And these are the 3 types of methodologies that we provide, which is the screening, or also known as the qualitative, and the quantitative based on performance area and financial consequence. I think we briefly talked about this before. That is the possibility of, whenever we are starting a project, to import some of the data that we have in our IDMS into the project right here. It will extract some of the fields. In fact, I will show you. If I click here, you can see that there is a new tab called the Import Datasheet. So it is showing me, out of all this equipment, look this, what data I can retrieve from my IDMS. So for example, I can find my installation date, the volume of the equipment, the temperature, the maximum temperature, the design temperature, the operating temperature, operating pressure, maximum pressure. All these fields here, they are assigned in the data sheet of the IDMS, and we can retrieve them. And if we authorize, this information that is imported can be used as part of the RBI analysis. So it's just an option, it's a tool that we have there. This last option is also important in the moment of doing a reassessment, because what we do is we have the possibility of, if you have done an assessment on a plant unit and then time has passed and it's time to do the reassessment, only a few of the parameters that change over time. The other things, such as let's say design parameters or stuff like that we have populated in the past, can be imported from our last study for the same project, and then we just change the ones that they are that change over time to do a new reassessment of risk. We will see how this works. In terms of, let's say, this section over here, let's say that you can visualize this based on consequence area or financial consequence, depending on what has been calculated on your project. And this is just a tool to, in case that this is useful, whenever you load data through Excel, you can click on select all. It will select all the rows, and then you can perform an automatic calculation. And the mass inventory, we will discuss at the end. Okay, this is the, let's say, every button here on this main screen. Now, for this to be populated the way it is, we need to start from creating a project from scratch, from zero. So again, just going back to how we get here, we go to applications, go to RBI management. We will see the window that we were discussing, but I am not interested in looking at my existing projects. I would like to create a new one. So for that, I'm going to go to RBI study, management, and it will bring me to this window. What do we do in this window? We need to define three main things. What are the assets that will be part of my project? What methodology I'm going to use? And which are the users that can close the study? So I think before we get into this, that is the process of the calculation. Okay, so before the break, we stopped in the section of we are about to create a new RBI analysis. So as you can see here on this window, on the left side, we have all the list in chronological order of the RBI analysis that have been performed in this license or in this site. How do we create a new RBI analysis? We can click on the new RBI study icon, and we will be able to define the date. So we can use today's date. That is the 22nd of April. And in the description, we can give the name of our RBI analysis. Okay, notice that when I create my analysis, it comes down to be the last one. In terms of dates, we can sort this to be sorted by, to have the latest one at the top or the bottom based on your preference. And then what we need to do is to indicate here three things. First is our item list. So before we declare our item list, we need to consider that here on the right side, where we can see the name of our analysis, the data, the date in which it was created, the release of RBI that has been used to perform this analysis. This is not based on the revision of API. This is based on the time we release let's say, any software update. So, for example, older assessments like this one. For example, this 2018 assessment was done with the release 3.1. I can, on older assessments, we can increase the number of the release to follow the most updated rules. But when we create a new study, like the one we created just now, it will always have the latest release only. So we can upgrade but not downgrade in terms of the methodology version that we are using. So don't worry, every time you create a new analysis, it will be under the latest version that we have. The status of the analysis is open. It doesn't have a close date. And now I'm using Mr. Andre user, so he will be defined as the manager of this RBI study. Now, we see that there are 3 tabs here. The first one is the item list. The item list indicates the total and the different numbers of asset types that we were going to be managing on this RBI study. So if I go to my plant unit, remember we had this 3 equipment, 13 lines, and 1 PSV. How do we add them to the RBI analysis? Well, if I click on Edit and allow item drag, so once again, that is Edit and then allow item drag, I will be able to, for example, grab one of the assets and drag it and drop it here on my assessment. So if I drag and drop this PSV, for example, you can see that PSV 001 has been transferred as part of my analysis. So you can drag and drop one by one this. Now let's say I have 1 equipment, 1 PSV, and in total 2 assets. Or not only dropping one by one, but you can, like for example, in the case of piping or any other asset type, you can drag and drop the entire folder. So basically, let's say if I want to add all these 13 lines as part of my study, instead of dragging line by line, I can drag the folder, and as you can see, all the lines are now included as part of my analysis. It is important to consider that for as long as this study is open, the assets that we include in this RBI analysis cannot be added on a new RBI project until this one is closed. And this is to avoid repetition of work in terms of performing an RBI analysis for any of the assets within the system. So now that we, on the first tab, we have defined the list of assets, we can proceed to the study configuration. In the study configuration, we have 2 main sections. We have the screening that refers to the possibility of selecting a qualitative assessment or a qualitative methodology. We can activate that or leave it as nothing if we are only performing a quantitative assessment. I'm going to activate it to show you how that works. And then we have the detailed analysis. That is basically the place where we will define our quantitative methodology rules. So we are saying that for the calculation of probability, we're going to be following the rules of API 581. We are going to define the matrix format type. So here is the place where we choose, if you remember from the presentation, if we are managing our result on a balanced or unbalanced matrix based on API 581. I'm going to select balance, for example. And then here we have the consequence factor. Is also following the rules of API 581. And my inspection plan is also following the rules of API 581. What is this table here under probability factor is the list of damage mechanism families that we can include as part of the analysis. And so we have the names of the damage mechanisms. We have a column indicating which of these names belong or are following the rules of API 581. They are marked here. If there is any one of these that is not following the rules of API 581, we have an indicator of whether or not it can be combined as part of the calculation based on the same API 581 structure and rules. And then here we have the checkboxes to be able to add any of these to our analysis. So, for example, if I want to select the damage mechanisms that are based on API 581, I can check the boxes next to them and add them for my analysis. You can see that there are other damage mechanisms in the list that they are not under API 581. For example, the high temperature hydrogen attack. This was like a shortcut that we defined for some of our clients that wanted to do a semi-quantitative assessment that was specifically declaring a susceptibility of high temperature hydrogen attack without having to go through the calculation that is regulated by API 581. But for this training and for this example, we are going to stick to API 581 and the different damage mechanisms that come with this standard. But the idea is to show you that in case that there is a damage mechanism in your facility that is outside of API 581, we can also include it as a development or customization service where we receive from our client the methodology and the rules for such damage mechanism, and we make it part of the algorithm so that you can use it within the Palladio platform. Okay, that's it. We have declared the item list, the study configuration. If we go to the last tab, which is the user configuration, here, normally attached to the license, there will be different users that are listed here and that you can declare as the verifier of the study. If you don't see anything on the list right now, it's because of the installation that I'm using. But normally it will be the list of the users of your team so that you can assign which one you would like to use. Now, after the item list, the study configuration, and the users have been defined, you need to press save and then click yes. And this will create our study. So now we can exit the RBI Studio to come back to our RBI management window. And on the Studio dropdown, we can select the one that we just created. Sorry, maybe forgot something. Sorry, I don't know what I missed. Okay, for my item list. The configuration. So now here on my studio list, I can find my study. Let's have a look at what happens when I select it. When I select it in the RBI management window, we can see that for every, let's say, RBI part or RBI component, like we define here on the hierarchy, so the shell side and the tube side of each one of the exchangers will have its own row or its own assessment. Yeah. So notice that even though we added 17 assets, I can only see a few here that are only the equipment. So if you want to change to see, for example, the lines, you will need to go here to line code to see the lines, or to valve to see the valve. Yeah? That is because the data input for these assets are different. The templates are different. Notice that because I'm going back to equipment, and because we activated the qualitative tool as well, I have these two sheets here that belong only to the qualitative screening assessment, and the rest are for the quantitative. Differently from the example that we did earlier, this is empty. So our result tab is empty. Our basic data tab is also empty. So here I can perform a check in terms of, okay, from any of these assets, do I have data that I can import from IDMS? Let's see. So if I import here, as you can see, for this exchanger 2693, I have a bunch of information already that I'm retrieving from IDMS. So all these values are retrieved from IDMS. Here, the software is just showing you what it was able to retrieve from IDMS. If you want to consider this data, you need to assign that data on the yellow side of the table. How do you do that? You can use the multi-select tool, select the assets that you want to transfer data, and when you go here, you can say transfer values. Then click yes, and the data has been transferred. So you see that the import data tab disappears, but the data that specifies what equipment type, the component type, and all this that we define on the data sheet of that equipment has been transferred into equipment 2693. Okay, so that means that we have a head start already in the data that we have to fill up, because some of it is already coming from the datasheet. Now, what happens with the ones that are blank? Let me show you how the assessment is done independently of how much data you have, or if you have nothing at all. First of all, two types of assessment. One is qualitative, the other one is quantitative. Let's have a look at the quantitative assessment. So let's say for exchanger 1013, I would like to perform, start with the RBI analysis with a quantitative methodology on the shell side. So let me select that row, and then I will select if I want to do quantitative of either financial or consequence area. I will start with consequence area. When I click there, it will open my Palladio RBI calculator. So how does that calculator look like? That calculator will have 3 main sections. The first section will define the general data in which we need to select the damage mechanisms that are applicable for the asset. Then we have a section for the calculation of probability of failure, followed by a section of the consequence of failure, and finally, a section to define the inspection plan. So these are the different sections that we will see when we open the calculator for RBI. Sorry. Yeah, so as I said before, general, probability of failure, consequence area, and finally, inspection plan. If we go to general, we can see that all the damage mechanism families that we selected in our study configuration are here with their respective subtypes. So in the general tab, if we know what damage mechanisms are applicable from the for the asset that we are analyzing, in this case, exchanger 1013, we will be able to select the applicable damage mechanisms on these checkboxes. If we don't know what to select, we can proceed directly to the calculation of the probability of failure. You will see that the benefit of knowing is that, of course, if you define what needs to be analyzed, then you avoid the questions of what doesn't need to be analyzed. But based on your response, the software can help you to understand which ones are the ones applicable and which questions are no longer applicable based on your answers. So for this example, I'm going to leave it blank and I'm going to show you what happens if you go directly to the probability of failure. So I'm going to switch to the probability of failure tab. And the window is divided into 2 main sections, the input and the output. In the input, we have a list of questions that are, every row is a question that we need to answer. And those questions have drop-downs with options that are declared by API 581. Some of them have this range icon that is for a calculation, or some of them don't have a drop-down, which means we need to insert a numerical input for which the units we can see on the right side. Now, notice that we didn't define any damage mechanism that was applicable for this asset. And therefore, there are 277 questions to be answered. Too many questions, but don't worry, because doing the analysis through this window, we have an assistant. What the assistant is going to do is going to tell you, out of those 277 questions, which one is the most important one that you need to solve first. So it knows the path of the algorithm and the calculation, so that based on the answer that you give, it will say, okay, you give me the most important answer now. Based on that answer, I can tell we don't need this and this and this and this question. So every time we're going to have less and less questions. And at the end, you're most likely going to have to solve, I don't know, 30, 40 questions to calculate the probability of failure instead of 277. So let's see how that works. Here is the input. We have the questions. Here on the left, we have the output, which is the probability of failure. So as you can see, we are doing a probability of failure based on API. We can expand our output to understand what are the components along the calculation. So in probability of failure, I can expand and I can say, okay, we have the main components like we saw in the presentation of the probability of failure, which are the total damage factor, the management system factor, and the generic failure frequency. So these are the main contributors of the probability of failure based on API 581. What we can do is also further expand, because even though these two are just, let's say, just the value, the total damage factor is a combination of all the findings of damage factors for each damage mechanism that is applicable. If we expand, we are able to see the different families: thinning, brittle fracture, external fatigue, external damage mechanism, high temperature hydrogen attack, stress corrosion cracking, mechanical fatigue, and so on. We can further expand thinning, for example, or further expand external to be able to see external chloride, SCC, many subtypes that are within the families. And the reason why we expand is because each one of them will have a damage factor if it's found present in the asset. We will see a bit, we'll understand this a bit better when we populate some data. So for now, what you need to do is to start answering some questions. So for that, we're gonna use our assistant. When I click go to the parameter here in my assistant, it will highlight in yellow the question that I have to answer first. And in this case is the type of material. And in this case, this question has a drop-down. So I have to select the from the drop-down, the material based on API 581 that represents the section of the asset that I am analyzing. So after my selection, you can see that the row of the question that I just answered turned green. It's no longer white, it's green. And it's green because it has an answer. If I continue clicking on the assistant will highlight in yellow the next question. So yellow is for the next question to be solved. Green is for the questions that already have an answer based on our answers also. And the white ones are the pending ones. If I select the equipment type, in this case heat exchanger, and I go to the next one, we select the shell site this time. And we can see that here in the warnings, I have some messages saying that some of the questions have been discarded because of my selection. So maybe because of the fact that I selected a shell site heat exchanger, there are questions that are no longer applicable. It is asking us if we have cladding. You can say no. And notice that if I say that I don't have cladding, then the questions of corrosion rate for cladding and the value of cladding corrosion, they are grayed out. And therefore, we haven't solved 30 questions, but it's already reduced to 245. So this is the way that the calculation continues. So you keep clicking, go to the parameter, and it will indicate to you what are the options. You select an answer and move to the next question. The interface for consequence area is the same. We have also a list of questions on the right. Not as many, as you can see, at least 14 only. And we are asked for different things that we can identify with the assistant, who is highlighting in yellow the appropriate field to be answered. once we select an answer, it will ask us for more information. And there are some parameters that are communicated between probability of failure and consequence area calculation. We can expand and we can see the different things that are being calculated as we answer these questions. Okay. Finally, whenever you complete all the parameters, you will have the possibility of declaring an inspection plan here in the tab, because as soon as you have a value for probability of failure and you have a value for consequence, then you have risk, and then you can define your inspection plan. So let me show you an example here. See. Okay. So for example, this one, if we enter the calculation, we can see that this one is already complete. I want to show you what happens when you fill up all the parameters. So when you fill up all the parameters, the damage mechanisms that were found as present will be check marked here on the general tab. It will be marked as present. So as you can see, in this case, we have a thinning and some form of stress corrosion cracking. Then if we go to the probability of, also it will show you the risk matrix on the, let's say the present calculated risk based on this assessment. We can visualize the risk matrix in two ways. We have the balanced risk matrix that we selected this format at the beginning of the project. And we can also visualize this as an ISO risk matrix. What this means is it will show you it's a different visualization of risk. The limits are here. We have the green line. So it goes in this is a more specific location of the point. If you notice on this general risk matrix is always in the middle. So independently of where within this area the point is, you will see it always in the middle. But in the ISO risk matrix, you have a better understanding of how close it is to changing area. Let's say in this case to go to 2 or to change to area C over here. And you can visualize your risk based on probability of failure, which includes the generic failure frequency and the management system factor, or purely on damage factor. So I recommend you stay with the probability and the consequence, but this is useful also in some cases. If we go to the probability of failure, you will notice that whenever all the questions are solved, you see they are all in green and gray. It means that everything that we need has been answered, and the progress bar is full, saying that we have defined 36 out of 36 parameters required, and our assistant is telling us that the parameter of probability of failure has been calculated, and we have a value of probability of failure. Now, if we go to the consequence area, same, it is showing us a full progress bar, 13 out of 13, and the parameter has been calculated. We have a value of consequence area. So as I was mentioning before, if we have a value of probability and a value of consequence, we can go to the inspection plan. How does that look like? The inspection plan will look like this. On this window, as soon as you get probability and consequence, you get a value for two things. The damage factor total, sorry, which I didn't show you. Here, if we expand, we can see the value of damage factor total. And if you further expand, you can understand which fields are in green, which means they are giving a contribution towards the value of damage factor. So the damage factor total. So for example, in this case, only thinning is giving a contribution. And let me see. Yeah, in this case, only thinning is giving a contribution or is defined as the dominant, and that's why it is the one used as the damage factor total. The other ones are declared as non-existent. So this is how, if, for example, if you want to see what data input was considered for the calculation of a particular damage factor, you can click on that row, and everything that is in green on the input side means that was part of the calculation of such damage factor. Okay. You can further expand and see what are the different values for the different parameters in the formulas for the calculation. But essentially, from your input, this is what you can review because all of this is calculated in the backend. So after having the probability of failure, the consequence area, we can go to the inspection plan. The inspection plan will define the damage factor total, and it will define the risk, that is probability of failure times consequence area. Great. This is at the date of RBI, which in this case was in 2018. But we have the two values, the two calculated values here. Now, in terms of the fields that are in green, those are normally. Yes.
Sorry, Mr. Abdul. The screen is still stuck in the probability of failure.
Oh, maybe let me try to stop sharing and reshare. Can you see it now?
Not yet.
Is anybody else experiencing the issue? Can you see my screen?
It seems that the others can see your screen, Mr. Abdul. I will try to relog into this meeting.
Okay. Would you like me to wait for you, or should I continue? Okay, he just left. Rejoin now.
Now it's already fixed.
Thank you. Yes, so basically, I was showing just now, I don't know at what point we had disconnected, but Here is the calculation of probability. You can expand to see the contribution of the different damage factors towards the calculation of damage factor total, and therefore the probability of failure. Here we have the calculation of consequence area. This one can also be expanded, and we can see the different generic failure frequencies that were considered, the different calculations for hole size, and many other parameters. This is a very complex calculation, the one for consequence area, and it has a lot of variables in the back, but if we keep expanding, we will be able to see everything that was considered based on our inputs. But the inputs are very, very few, only 13 inputs. When we move to the inspection plan, we will be able to see the date of the risk, the damage factor total, and the actual risk calculated in these three fields. Now we have the green fields, and the green fields are the places where the users have to define a damage factor target, a risk target, and a plan date. What does that mean? The first two are either on a representation of risk target or a representation of damage factor target. What is the limit of risk that I am not allowed to exceed? Yeah. How do we know about these numerical values? In API 581, if we go live somewhere around here. Yes. So if we look at the ranges of the risk matrix, remember we have the probability and we have the consequence. So the probability is defined with the numbers 1, 2, 3, 4, 5, and the consequence with letters A, B, C, D. This is what we have seen also here. So we have 1, 2, 3, 4, 5, A, B, C, D. What are the ranges or the limits of each one of these risk areas? That is defined here in the standard. So for the metric table, we can see that, for example, category 2 is a probability of failure value of this much, or a damage factor that is in between 1 and 10. Yeah. So you need to, for example, here a way to interpret the damage factor target, we have it set up on this example as 100. That means that we will be on saying that we cannot exceed category 3. Yeah, and which is this one right here. Then the risk allows you to see what is the value that you cannot exceed in terms of consequence as well. In terms of consequence, we have a range in meters squared of consequence area, and we can see in the values on meters squared that you cannot exceed. If you multiply the probability and the range that you will not like to exceed, that will give you an idea on how to define the risk target. The calculation will stop once either of these two are exceeded. So if you are approaching the damage factor target or the risk target, then the software will say, okay, here it's time to inspect, or this is the action you need to do. And the plan date is when were you expecting to do the reassessment, the shutdown, the the integrity activity that will cause to perform a new RBI analysis. So these three things defined by the RBI engineer. And then we look at the functionality target date. As you can see, we did this as this example on 2018. Yeah. But if we use the functionality target date, the software will start a calculation until both the risk targets are not reached. So we click OK, we start at 2018, and we realize that 1 year after, in 2019, we have reached our target. So what can we do now? We can ask for a suggestion of a new inspection date. And the software is telling me you need to inspect in 2019. So what we can see now is on this one, as the title says of the matrix, we have the actual RBI matrix. That means that this value of risk is positioned on area 3B. Yeah. On my plan date, I was assuming to do an inspection or a shutdown on 2023. But what the software is telling me is that if you don't perform any inspection until 2023, when was the plan date, your risk will actually be here. And that is exceeding both the damage factor target and the risk target. And that's why these values are in red. So what are my options now? I need to define either a manual inspection plan or an automatic inspection plan. Remember from the presentation, the automatic inspection plan will use the calculations from API 581 to give you what is the lowest level of effectiveness of inspection for the applicable damage mechanisms that will bring your asset under or as close as possible to the risk target. Yeah. And with the manual, you can define different dates and assign different effectiveness for the software to calculate where will the risk be if you perform such defined inspections. So let's have a look at the manual first. So the manual will open this window, and this window will allow you to insert a new inspection date. So for example, we are looking at this analysis where they are telling us to inspect in 2019. So let me look at that. So I'm gonna select the year, for example, 2020. I'm gonna do it on February, mid-February of 2019, and look at that only the thinning is active, the rest are not, and I define an effectiveness. I am not limited to one date. I can, for example, add a second inspection if I want to. I wanna also inspect do another inspection in 2019, maybe at the end of 2019. And I set up the effectiveness. Maybe I'm considering a highly effective and a usually effective. And when I'm done defining my dates and my effectiveness, I click input. And the software will show me, okay, if you perform those inspections that you define, your risk will be here. And your damage factor total and your risk value based on those inspections will be this much. If I undo this and I do the automatic, you see the suggestion of the automatic is that, first of all, we ended up in the same risk area. But how much inspections did it suggest? Only one highly effective. That means that without any knowledge, I decided to do a manual saying that I'm going to apply a highly effective inspection in 2019 and also a usually effective inspection at the end of 2019. In terms of risk reduction, this didn't have too much impact. In fact, the highly effective inspection was enough for my objective of bringing it under the risk target, and I didn't have to do my usually effective inspection. Only one was enough to be compliant with the purpose of this RBI assessment, that was make sure that the asset is under the risk target. So as you can see, what the software shows is the actual. So we have a value of risk of 0.026. If we don't perform the inspection, it goes up to 0.3. And if we perform the inspections that are suggested, we go to 0.03 in terms of risk. There is also a considerable reduction in the damage factor total. So it's good because both are under the limit. And we have a way to demonstrate this with the suggested inspections. Now, I can also visualize from here the risk matrix in an ISO risk matrix. Let's explain this a little bit. I'm going to... The ISO risk matrix will show whatever is below this line is green. Whatever is below this line is yellow. Whatever is in between yellow and red is orange. And whatever is above red is red, which follows this risk distribution. Now, the one thing that we can see here is a blue line. That is our risk target. That is based on what is the value that we give here. So this is how we can visualize the risk target that we define. Notice that in the actual risk assessment, our position of risk was on area 3B, but in this high location. If we didn't perform the inspections and we waited until 2023, that was the initial plan, look at the increase of risk is right above the target. It is above the target right here, and it will be already on area 4B. Now, if we perform the suggested inspections, notice that even though we end up also on area 3B, it's a bit lower than what it was in the actual assessment. So we are still reducing risk even though we are in the same area. You can also see that here in the ISO risk matrix. So that is the purpose of these two different visualizations. Now we have the three matrix considering the actual, future without inspection, and future with inspection. And then we can see what was the detail of the calculated suggested inspections by looking at here at the inspection plan detail. So we are requested to do a highly effective inspection. You see that there are some notes here, and if I open the notes, it is a text field so that I can indicate what is it that I would like to do about this requirement of highly effective inspection. Now, I can, as I showed you before, the RBI module has a table that has the recommended inspections and percentage of coverage based on the required effectiveness, so that they can be inserted automatically into our report. How do we do this? I am done with my assessment. I am going to save. Yeah. Very important. This is a bit confusing. Normally, in our calculator window, we have a few icons that we need to consider. This one is to create a new analysis. This one is to open a file, because these two is like the equivalent to save and save as. So we will create a file out of this RBI analysis so that you can send to someone that has Palladio and wants to see what you are doing. So for example, if you are doing an assessment and you run into an issue and you want to send the file to Bureau Veritas or to Antea for some questions, you can save it, save this analysis, and it will create an XML file that we can open directly through Palladio, and it will load to any asset all the data input that you have done on this particular RBI assessment. That's the purpose of these two buttons. And this one is the one that you need to use to save on your database. So please remember that the button that you will mostly be using is the save button with the green cylinder that represents saving on the database. Okay, here is where we save. Session has been saved on the database. Now, this one is to print an RBI analysis as a PDF. So if I'm done with my assessment, I can print a PDF with the results. Here we used to have an access to for some of our clients to the API manual, but since it's a paid document, I don't think this is accessible anymore. Here is to add a note on the general assessment. This one is to retrieve values of corrosion rate or inspection history, survey history, that could be useful for us, because during the quantitative assessment, there are questions of how many inspections have been performed for thickness, for example. So we can have direct access to the historian of coming from IDMS of the registered inspections. And this one allows me to see what are the records of calculation of corrosion rate and remaining life of the asset based on my inspection history. So these are like shortcuts to retrieve useful information during the RBI assessment from the IDMS. But what do we do when we are finished? Normally, we can print a report. So here I'm going to click on preview to show you how that looks. So what it will do is it will consider the, let's say, some of the essential data that we use for input and calculation, and it will also display the 3 RBI matrix based on the calculated risk. If we go to the second page, you will have 3 main fields to look after. The first one is the description. So in the description, you can have the introduction to your report. I will show you how to edit and add content to this report. In the inspection plan, you can have notes about the found inspection plans, and the inspection plan details. You can have the notes about the highly effective inspection. Sorry, about the required inspection effectiveness. Let me show you how to add that information to your report after you finish your calculation. So three main sections. The top section is the general information. The general information nodes are populated here. So we open a free text field and we can add any text. KPI. Save. And then we can, the note in the middle about the damage mechanisms can be added here. So and the details of the inspection effectiveness will be added on this note right here. This one, I recommend we use we fill it up in a different way. That is the population of the API nodes that I will show you shortly. So if we notice that if I save on the database and I print my report and I go to page 2, you can see that the content or the text that I added under the general note, it will be here. It will make a reference node number for the damage mechanism and add the node here. And now I will show you, you can do the same to add a note about the required effectiveness manually, or you can do it with the automatic note insertion from API. How to get the automatic note? I'm gonna exit the assessment. You will see that we have the results and everything here. So we need to activate the RBI scheduler. When I click on RBI scheduler, it will bring me to the RBI scheduler tab. And on E11, that is the shell site that we were looking at earlier, I'm going to ask the software to calculate the inspection notes. So you can see that here, now that we have a highly effective on 2019, it is also considering the notes from API. And then I can say, please overwrite these inspection notes on my report. So now, if I access again to print my report, the note from API will be included automatically in the PDF. So let's have a look. Wrong equipment. Okay. So let's have a look at the report. If I go here, I can go to print, preview, and now here is what we have. The same on the first page. Second page, we have the notes that we added manually, this one and this one, and the automatically generated note by API as part of the report. Now, let's say that, I mean, this is a straight out of the table. You still have the freedom to edit this. So if you exit before printing and you want to change a bit of that note, you can go to the inspection plan detail note field and modify this. For example, let's say your service company already defined that your case was general thinning, so you don't need the information of local thinning. You can delete that. You can also say, oh, by the way, this is going to happen during a shutdown, and we are doing intrusive inspection. So you also don't need the non-intrusive inspection information. You can delete that. And if you want to add additional notes, you have the whole text field to make the additional comments. Just make sure you save, and once you do so, the report, when you print it, will have that modification. Oh, I didn't save in the database first. Then we print. And as you can see, the report gets modified to reflect only the note that we have added. We have finished through the notes icons. So yeah, just as a reminder, the report has 3 nodes. General node is up here. Damage mechanism node is here. And inspection plan detail node is here. 3 fields, 1, 2, and 3. So this is, let's say, the procedure on the assessment and getting the report. So far, do you have any questions?
Mr. Alberto,
Yes.
for the matrix of the feature without planning inspection, when will it change? Is it when we recalculate or reassess the RPI analysis, or is it when the date is when it is due in the 2023? Will the matrix change by itself by the due date, or will it change when we reassess the RPI analysis?
Okay. No, the only way to change the actual RBI matrix is by performing a reassessment of RBI. It doesn't change automatically. So basically, the process is, as soon as you create an RBI project and perform a reassessment, you will have at the date of the reassessment what is known as the actual RBI matrix. This might change from the previous one, yes, but it is following the date in which you perform the assessment. Then at that same date is going to calculate for you what is going to happen at the planned date that you define on that reassessment. It's going to show you 2 scenarios, the future without inspection and the future with inspection defined on the planned date. If you perform the suggested inspections, this is how you will end up in terms of risk. If you don't, this is what is going to happen. So the matrix doesn't change automatically. It does calculate the future with and without inspection, but it's based on what information you provide during your reassessment.
For the plan date, is it adjusted by the software or is it by the engineer? For the set of the plan date.
For the what, sorry?
For the how we determine the plan date of the inspection in the software. Is it manually or is it by the software?
The plan date. No, this is defined by the user. It's defined by the RBI inspector.
So the target date, is it determined by the software?
Yes, that one is automatically calculated by the software.
Okay.
So the ones that the user needs to define is the risk target and the plan date. The target date is calculated by the software.
So basically, we have to assign the new inspection plan date after the target date, or is it before?
The thing is, you don't know your target date before defining the plan date. So basically, normally the plan date is something that is not very flexible because mostly is let's say the shutdown of the plant. It's not something that I
see, I see.
So if there is you say, okay, we're having a shutdown on this date, then that is when you are expecting to do inspection. That is when, if you do a time-based or condition-based inspection plan, you are assuming that you are doing an inspection on the plan date. But now you want to make sure that you are under the limit of risk to reach this date without any issues. But what the software calculates with the target date is like, okay, if your restriction is I cannot cross this risk target and I am planning to inspect on this year, can I do that or do I need to do it before? So in this example, for example, it was determined that the target date, which is when the software is suggesting to inspect, was before the plan date. So it means I cannot reach this date safely because I'm already surpassing my risk target before I reach 2023. Okay, so this plan date is normally defined before the target date, and there is sometimes happens that, for example, you perform the assessment on 2018, like in this case, you define that the date is on 2023, and the software starts calculating and it says, look, after 25 years, you're not gonna reach the target. So then you might reconsider and say, okay, I'm never reaching the risk is never crossing anytime. I'm not surpassing the risk target anytime soon, not even after my plan date. So you might reconsider inspecting this asset on this plan date because it might not even be necessary, speaking in terms of risk. But of course, for routine and by law, there are sometimes that it is mandatory. But risk is a driver that can justify the extension of the schedule in which an asset needs to be inspected by law, for example. So it's a good opportunity to understand if the tolerance of risk until the moment of my next shutdown allows me to postpone the inspection for this asset, or if I have to do it before, or if I can safely do it on the shutdown period.
So the result of this RBI analysis is not the interval of the inspection program, rather it's a date or a year where the inspection takes place. Is it correct?
Yeah, it will give you the year in which you need to execute the inspection to not cross the risk assessment, because it's normally not a defined frequency. It's based on risk, so we need to elaborate and see what is the driver to determine the date, and this is just only obtained by this assessment. It's not a defined frequency or interval, but it's a particular date based on the date of the assessment.
Okay. So after we do the inspection, should we always do reassessment after, I don't know, after turnaround program or after the inspection being done?
Yeah, I will like maybe the best team to answer this question is the members from Bureau Veritas. Rudy or Harry, do you have any comments? Hello, Rudy, Harry.
Hi, Arbito. Sorry. Can you repeat again what the question? Because
Yes.
in parallel, I try to.
No problem. Can you please repeat your question, Pak Dimas?
So after we perform the inspection based on the planned date or the target date stated in the RPI analysis, should we always reassess or recalculate this RPI analysis by making new RPI study?
Yeah, Pak Dimas, I try to answer that. If in term KPI team perform the inspection after any recommendation that you try to perform the inspection, so you need to update the inspection quantity or inspection value of the box dialog, previously in the how many inspection, and then what the effectiveness you put over there. Then you need to run again to know how many the risk level at the moment after you perform the inspection. Actually, like that, Pak. Is it?
Okay, that's clear.
Yeah. So yeah, based on our discussion during RBI training, so RBI data is life cycle data. So this is hopefully after any activity or anything updating data or any activity, it's supposed to be update on the data input in the Palladio. So after that, as soon as possible, you try to running again to calculate again the value of risk at the moment.
Okay.
Okay, thank you, Rudy. Yes, so I agree. I think anytime that there is some sort of addition into the inspection history, and you need to reconsider all these changes at the moment of performing an RBI assessment. Of course, there are the good thing about this quantitative RBI assessment is that even though it takes some time to populate this required information, because it's very specific information, most of it doesn't change over time, only a few parameters. So if you create a database like this and you have a software like this, you can always go back to your assessment, bring back this data, and replace only the parameters that change over time. For example, some of the things that you will need to reconsider is that, let's say, for the detected damage mechanisms, there are questions, as we can see here, about the number of highly effective inspections that have been performed during the in-service time. So, of course, if you perform, let's say you do your RBI analysis, they give you the recommendations, you follow those recommendations, and those recommendations were based on a highly effective requirement, then the number of highly effective inspections at the moment of reassessment would be 1 or 2, or however many inspections you perform after that effectiveness was suggested on your previous study. And this will drive down the value of risk for sure on your reassessment. In fact, we already know by how much. You can see it in the ISO risk. It's bringing it down, and it's going to be a considerable difference between not performing the inspection and performing the inspection. So the more information that we have, the less likely we are to fail. And this doesn't apply only for RBI, but for many other things. And it's important that if we check our asset consistently, then the probability of finding an unexpected failure or something that that caused an accident is less and less and less likely. So all this data helps updating the amount of times that the asset has been inspected will most likely reduce the probability of failure, and the evaluations or mitigations in terms of consequence can be reduced with mitigation activities, replacements of parts, changes in the process, changing the operating parameters. What else? Yeah, changing the fluid. If you add in the moment of the previous assessment and the future assessment, if you add, let's say, an enhancement of your detection systems or your isolation systems or your mitigation systems. So all these things contribute to be factors that will reduce your risk at the moment of the reassessment. So this is essentially what we do in this calculation model. Now, this is specifically for the quantitative assessment based on area. So from the session in the morning, we covered some of the basic methodology of the RBI. How is it managed in Palladio? And we reached to the point in which we achieved the result of a quantitative assessment using the calculator inside Palladio to visualize an actual risk result and successfully calculate the probability of failure and consequence area for an equipment. With this, we were able to generate the risk ranking of an asset, visualize what will be the future of this asset without planning inspection, and the future with the plan inspection. This is all based on the quantitative assessment. We also visualize how to check on the inspection report, how to edit the notes and add more content and customize the RBI report for printing or delivery of results. Okay, one more thing that I would like to show you regarding the quantitative is that all this process of calculating the probability of failure and consequence area that we saw earlier is referring only to this exchanger, E011. When we complete our analysis and we look into the results, we can see that particularly on this study, we have more than one equipment. And in fact, we have 40 equipment on this one. Let's see how many lines. 138 lines and a few valves, 2 valves. So in studies like this, if you would like to populate data in a faster way, the recommended way is through Excel. In an RBI analysis, we can select one asset and use the calculators here, or to ease the process of data loading, we can export an Excel file with this particular data. The Excel file will contain the different input that were created for the analysis itself. So you can, when we export the file, the software will ask you to save somewhere. I'm going to open it in Excel. And when I open it in Excel, what we can see is the following template. This is the template for data loading of the RBI analysis. So depending on what kind of assessment we are performing, we have different things to do. The result sheet is only for an output. So we don't have to populate anything in the result, since it will be automatically filled up after we perform our analysis. But notice that in the results sheet, you can export for on column I, you will be able to see the name of the asset. Column J represents the chamber or RBI part that you are analyzing, and we can see that in orange we can find the different populated data in the results field. So you will have the value and color of the matrix for the present risk, the actual value of risk, damage factor total, probability of failure, and consequence area. Also, you will see the future RBI date on the area consequence, which corresponds for us to the plan date. The plan date on the financial consequence. Also, the future risk without inspection, same categories for the without inspection section. And then the future risk with inspection, and have the same categories of value of risk, damage factor total, probability of failure, consequence area, and so on. Also, we have the corrosion rate values that were used for the calculation, and if there were any specifically like a specific theoretical corrosion rates that we used for the damage mechanisms, they will be displayed here. This is the results page, but the one that you need to populate really is mostly the basic data sheet. So the idea here is, again, the orange columns, the first orange columns from A to F, they are automatically populated by the software. Same goes for G, H, and I. So normally the name of the equipment and the chamber, also J then, and K. They are, all these first columns are populated by the software, because if you see, what it is indicating is that at a particular location in our database that is defined by the combination of these columns, plus at a position in a particular plant unit, sorry, a particular site name, we have this, the name of the site, the name of the plant unit, the name of the equipment, the name of the chamber of such equipment, and the asset type here. So all of this is automatically populated from the software, since we already defined in our RBI study which are the assets that are part of the analysis. Then what we will define are from column M forward. So if you want to make this part of an RBI analysis, yes. Then we go into if they belong to a particular corrosion loop or not. This is not mandatory. We can also say the calculation, the type of calculation for the quantitative matrix, if it's a damage factor total or probability factor. And the same for the financial. The equipment type, the component type, and the geometry type is usually defined inside the RBI analysis, or it can be imported from the datasheet. Please remember that there are some fields that can populate this data automatically coming from IDMS. Particularly, I will share this document that I'm about to show with you. You can use as a reference. Sorry, 1 second. Okay. But basically, yeah. So here I have a few screenshots of the places where in IDMS you need to set up things so that that information can be transferred to RBI if necessary. So let's review that for a minute. For example, we can see here on that in the data sheet of an equipment, the type is very important because the type is defining on the, let me show you on the software. On the software side, in the tables, when we go to item types and then equipment types, we have a table, and this table is having this field that is equipment type, and this field is the one that is connected to API 581. So any type of equipment that you define in Palladio, you can associate it with an equipment type of API 581 so that the software at the moment of import understands how to treat such equipment. So for example, in the case of the heat exchanger, if you create a new asset and call it, define the type as heat exchanger on the datasheet, it will automatically create these shell side and tube side chambers. Yeah. You can define other types, like for example, if you go to column and you can define what kind of equipment based on API 581 you will consider a column as. So it's not a compressor, it's not a heat exchanger, it's not a pump, it's not a tank. It could be named as a vessel. So here is where you will assign such things by pressing edit. And at the moment that you define this table, you can, in the datasheet of the equipment, you can define the type. So when I'm creating a new equipment and I'm calling it like this, and I define that the type is a heat exchanger, and I save. If you check on the newly creating equipment, If we go to the construction data and the RBI components, we are able to, at the moment of defining the chambers of this equipment, here on equipment type, it already understands it's a heat exchanger. Sorry, let me refresh. And so you can see that the shell size and tube side chambers are defined and the equipment type is already populated as a heat exchanger. This allows us to fill up the next information that is related to this particular shell side as component type. Component type in this case would be the shell, and the geometry type cylindrical. This component type could be the tube side, cylindrical as well. And so all this information will be populated in the RBI analysis. Same with the material. The material, please remember that it also comes from the setup that you have on the materials table. So in the base material, you need to make sure that whatever material you use to assign in the chamber has a definition associated to the representative material for RBI 581, for API 581. And that's defined on this category right here. Also, in this table, it's important to set up information such as the tensile strength and the yield strength for the particular material that you are using, because this is used in the calculation of probability of failure. If we have a look at the document, we will see that here is what I was explaining you on defining the equipment type. And here we have other fields that are important to know. The pressure, the temperature, and the volume in the process, in the operating data, sorry, in the design data category, can also be transferred. Maximum pressure, maximum temperature, maximum and volumes of the asset. We can also transfer in terms of the operating data, the maximum pressure, the maximum temperature, and the fluid. For the fluid, in the fluid table, we also need to focus on the RBI 581 representative fluid and indicate if there is any toxic element connected to it. After we populate in the RBI components datasheet all this information, this will allow us to save some time in the data loading, because this can be transferred directly from the IDMS into the calculation. Another fact that goes from the datasheet into the RBI is in the tab standards. If you indicate that there is a post-weld heat treatment, it will be here. So if you go to the column standards, here the post-weld heat treatment, yes or no, you can indicate this. This can also be transferred into the RBI analysis. And that's pretty much it. Together with information about the date of issuance. Let me go back up. Here it's let's say the commission date and the asset type, and those are the main things that you can transfer for the RBI analysis in a quantitative calculation. If we look back into our template, these 3 columns are things that we define in the chambers. The installation date is also in the datasheet. The RBI date is defined at the moment we create the project, and we can also define another RBI date at the moment of the calculation by either populating an index cell or through the questions in the RBI analysis. The diameter, the volume is also part of the datasheet, so it can be retrieved from it. All these parameters, design temperature, operating temperature, maximum temperature, and the values of minimum temperature, you can indicate if you want to calculate or make it an input. For the operating pressure, it's also a parameter that can be retrieved from the datasheet. The thickness and the minimum thickness, you have the possibility of calculate a theoretical one inside the RBI analysis. But if you have one based on your IDMS records, you can also bring that in. And same for the thickness reading value. So all this basic data, you can populate in Excel. And in terms of the other sheets, to understand what are the valid inputs on these columns, you need to focus on the description. So the dark orange part is just the name of the variable in the software. In the bottom, it has a description of what it means, and then an indication of if the value is numerical, if it's a text, if you need to choose from any fixed number of options, or in some cases, if you need to refer to the list sheet. So for example, there are parameters like this one, like material category, that says selected from the list sheet. What is the list sheet? The list sheet is this sheet right here. So in the list sheet, if I look for the parameter material category, I will see that my options for material category are right here on column S. And my input in my Excel file needs to be according to these 4 options if I am working with API 581, these 5 options, sorry. So when I'm filling up the Excel, I am restricted to input these values here for material category. This is when the indication is selected from the list sheet. You can see that some of the parameters follow this. Also, the representative fluid. If we don't want to browse through the list, we can import it from the IDMS if we set it up previously in the datasheet. Other cases, they give you the only 2 options that you can, is either gas or liquid. This one is for the storage state of the fluid. And then you continue filling up the data in the Excel file. The best is normally to do one analysis of one asset using the assistant, the one we learned about this morning. So accessing the RBI application and using the assistant so they can guide us on the process on what data to consider. And then once you have a result like this, you can see which of the fields are mandatory and you go through there. It might be that you have similar assets, so you can even copy the inputs and speed up the process of loading. Let's say for our training, we were looking into this one. This one I imported some of the data coming from the IDMS. that is coming mostly from the datasheet. So if we open one of these in the calculator, we can see that there are already questions that have been solved based on that imported data coming from the datasheet. I can show you that if we export a result for an RBI assessment with Excel, I will demonstrate how to upload. So for this particular one, we haven't defined the applicable damage mechanisms. I am going to assume that the only applicable damage mechanism for this one is thinning. So there is another thing. You see that it says please set. We need to remove this setting by selecting the damage mechanisms. Otherwise, they will be all considered. And only removing the check mark on the ones that we want to keep. So let's say, in this case, if I am saying only thinning is applicable, I can uncheck these damage mechanisms, leave only thinning on, and then uncheck the rest. These allow you to skip many of the questions after saving on the database, because you have told the system that you don't want to do a screening. You know that thinning is the only damage mechanism to consider. If we go to probability of failure, you can see that instead of 277, we have 160. And if we expand the probability of failure, we see that we have declared that these other damage mechanism families have been declared as non-existent. If I proceed to use the assistant for the calculation, I can quickly, I'm gonna fill up some of the data. Just to demonstrate to you how to export to Excel and fill the rest. Okay.
Sir, for the input value of the probability factor, can we import or copy from the previous study, or we must insert it again if we want to do reassessment?
For what value, sorry?
The input value for this PF, if we want to do reassessment, can we import the previous value in the previous study, or we must insert it again?
There is no need to insert it again. You can import from the previous study. So how to do that? Let me show you. In this, let me just populate this very quickly. Okay, so now I am finishing the screening. And some of these parameters have a range. This range allows you to either make an input using a value that you insert here, or you can calculate by answering some questions. So in this case, let me do an input. Okay. Sorry if it takes some time. Almost finished. I'm not paying close attention to the input. I just want to show you the process of data loading. So I'm just gonna get some values so that you can see what to expect in the moment of import at a blank Excel template. So okay. Okay. This is the section to insert the number of highly effective, usually effective, fairly effective, or poorly effective inspections that we have done in the past. This is the management system score. By the way, this management system score is retrieved from the management system factor calculation. So normally, what we provide to you is this is part of the API 581. What the RBI inspector needs to do is to consider the management system factor rules. Normally, an 80% is a decently managed plant as an average value in case that you don't have the full calculation, but you normally the management system factor is a calculation that happens with the evaluating different management practices in the site. So what does it consider really? It considers the different categories. Let me show you which ones that that describe that will calculate an overall value or a score that is by the discussion of with different departments in terms of that evaluates management practices, safety practices. Let me show you what we use to normally calculate that. So I'm going to send it here. Okay. Okay, is this file over here? So basically, this calculation is done normally by the RBI specialist. It considers, in order to calculate the management safety factor value, there is a combination of the evaluation of 13 parameters that include a scoring on leadership and administration, process safety information, process hazard analysis, management of change, operating procedures. So you can see that for these 13 categories, we have some questions to solve. Here you have the possible score and the actual score that you are giving to this practice after you have your interviews with all these different sections of the administration. So what we do is, after giving all these scores, it will get a total of points. Those total of points are transferred here, and we end up having a PS score or a management system factor value. So the total maximum points that you can get is 1,000. Then based on that, we get a score, a PS score or a management system factor that then will be used in this part of the assessment right here. So when we indicate the management system factor, we will have a value included for that in the calculation. For the generic failure frequency, we can is a table value that only changes, I believe, for tanks, for storage tanks. The rest is the same value based on the table of API. So it's a tabular composition. And let me get some calculation for the corrosion, for the consequence. And then we see how the import works. Okay. So after all that input, this is my calculation of risk. I can insert a risk target, a damage factor target, and a plan date. Calculate a target date. In this example, the software is already considering 25 years, and we never reached the risk target that I defined. So in this kind of situation, it is telling us that there are no inspections recommended before 2028. That is our plan date. And maybe in 2045, you have the possibility of doing an inspection. So the future without inspection looks the same, because the risk is not increasing substantially. So in this case, we don't have suggested inspection. Okay. So so we have a result on this particular analysis. What I'm gonna do now is, for this project, I am going to export an Excel file. So if I export an Excel file, I can name it whatever I want. I can save it here and open it in Excel so that we can fill it up. Notice that my Excel file that I just downloaded only has the list of equipment that I had on my PTKPI RBI training project. So it's the 3 heat exchangers that we have here, and their respective shell side and tube side on each one of them. So the idea now is, one of them we filled up in the assessment, in the calculator inside Palladio, and is the one on row 7. So you can see that all the required data is populated for that one. And some of that data is also available for row 8, because it was the one that we retrieved from the datasheet calculation. So for the other ones that we have 0 data, I'm just going to assume we are doing the same, just to show you how the import works. And I am just going to populate the rest of the data and perform a test of import, so that you can see how does it look like when we have a filled up study. It should end up having the same results as the one that we have performed before. So for this one, we can fill up the dates like this. And the same for the rest of the data. I am going to just show you, maybe not the entire workbook, because it's gonna take some time, but maybe let's focus on these first parameters to show you how the transfer works. If I fill this information in Excel, I will be able to upload it directly on my RBI. It's quite a lot of values. So what I'm gonna do is I'm gonna save this now. I'm gonna save it as just the file that I want to upload. And I'm just gonna go back to the server to show you. You can see all these fields were empty, but now that I have filled it up in my Excel, I can drag and drop my file here so that I can go to Excel and import the file that I just created. So here, it is telling us that if I use my Excel file, it's going to be overridden. So you will notice that this result that we have may be lost, but it's not a problem because all the data input is already in the Excel file. So if I click yes and select this file, I just press OK, and you can see that in the result window, the result that we had for this one before is gone, but that is not a problem because I can now understand that if I use the multi-select tool and select the assets that I want to calculate, I can do an automatic calculation based on the Excel input. And now the software is doing a calculation based on the input that we gave to it. It will tell us how many rows have been evaluated out of the 6 that we have here. So it takes some time in doing the evaluation, but it will indicate with a progress bar here in the bottom which ones are being analyzed. Right now it finished with the first one. Normally the one we should have selected only is probably 2693. That is the only one with full information. But after going through this process, you can let it calculate on its own, and after the data loading, after some time, you will get the results without having to enter to the calculator. So we'll just wait a minute for the calculation to be complete. So basically, after filling up the Excel, we load the file and do a multi-select, and then proceed to calculate automatically based on the Excel input. Not only on the basic data sheet, we need to define what to calculate. While it calculates, let me show you here. There are other things to consider. For example, in the area consequence, we have some input as well that is referring to the detection, isolation, and mitigation type of the systems that you have. Here is the description of how to understand if you have A, B, C, or D for each one of these categories. And the fields that say output means that you don't need to insert. These are calculated by the software. But the other ones you need to define in the Excel file. On the inspection plan, it is important to define if you want to create an automatic inspection plan or a manual inspection plan so that the software can do the calculation or leave the space for you to do it manually. So this is the idea. Here we can see that if we go back to the software, the calculation was executed and saved correctly. So now we can see that in the result, we have again our result of our shell exchanger, and that would be the way to do a calculation, an automatic calculation. If I was to, for example, use asset 2693 for a reassessment, I need to make sure that this project is closed and that this asset is closed before I can reuse it. So I need to go to the process of, let's say, saying that this is verified. It is closable, and it is closed. And now that my asset is closed, this result is final, and I can reuse the asset on another project. Now, on the same asset or in a new asset, you can perform also a qualitative calculation. What is the difference? Sorry, before I'm gonna recover this as open to show you that after we perform a consequence area calculation, we can go in further detail to do a financial. If I access the financial calculation for this same asset that I already performed an area calculation in quantitative, most of the data is already there. The other data that will be asked for is the cost of things. So as you can see, even the probability of failure is already calculated, and in the consequence is no longer consequence area, but financial consequence. And the questions that are pending to be solved are mostly about cost. So for example, determine a constant value of the process unit replacement cost. What is the value of the environmental cleanup cost? What is the cost per individual, the cost associated with serious injury or fatality of personnel? The material cost, all this, the population density in the area affected. What is the cost of loss of production due to downtime to repair the equipment? All this information will allow to transform your consequence area calculation into a financial consequence calculation. But as you can see, most of the information is already there. If you have this information, then you can express it also as a financial consequence risk calculation. Otherwise, you can remain on the area side of things. If you calculate a qualitative for this asset, then you can go here to calculate a qualitative RBI assessment. The qualitative RBI assessment, as you can see, is very simple. You don't need to define any damage mechanism. It is not meant to be done on a single asset. It's for a more general group of assets. And the idea is that you can expand the calculation to understand what are the drivers. So, for example, I can resize this a little bit so that we can see. So we have the condition factor, the damage factor, the inspection factor, the mechanical design factor, and the process factor. This is purely qualitative. So the condition factor has 3 questions. The damage factor has 15 questions. The inspection factor has another 15 questions. mechanical design factor has 2 questions, and the process factor has other 3 questions. The combination of these factors is going to give us a qualitative assessment. Why is it qualitative? Because it's purely based on experience. If you look at the questions, for example, the first question in yellow says, in a plant walkthrough, how would the plant housekeeping be judged, including painting and insulation maintenance programs? 1, significantly better than industry standard. 2, about industry standard. 3, significantly below standards. So you see, the way of grading things is not numerical as the quantitative. It's more qualitative, and it's more general because of that. So you just select every option, as you can see here, has a weighting. For example, the significantly better than industry standards is 0, about industry standard is 2, significantly below is 5. So you will select based on your experience, how can you grade this category. Then the quality of plant better than industry standard. Sorry, the quality of plant design and construction. You see, it's very generic. It's very hard to judge things at this level of detail, because when you are doing a reassessment, your view of the grading of this could be completely different than the previous inspector. So that's why the reassessment on a quantitative assessment is much more traceable and reliable. Nonetheless, it's important you see that you have also the possibility of doing this, because this kind of assessment is very fast. So if you are a knowledgeable person that has a good criteria on how to grade these categories, it could be useful for initial screening of the risk in your asset. So after you answer all these questions, what it's gonna tell you is you can visualize which categories are applicable and which ones can be discarded. Generally, in this kind of assessment, there are very few that can be discarded. Nonetheless, let's have a look. Yeah, we use all of them. And then, as you can see, each category of the probability, the condition, the damage, the inspection, the mechanical design, and the process factors have a grade. Yeah, the probability factor has also a general weighting, and then based on the range in the risk matrix based on API, we understand that the probability of failure is on level 5 for this one. Then the consequence factor, same thing. We go for the consequence by answering these questions. Sorry, I am just giving some random values to show you what is the end result of this. But the idea is that in the description field, you can see what you're asked for and what these gradings represent in the dropdowns. So you can give the correct weighting on this qualitative assessment. Okay, in this case, we didn't need more parameters. The assistant tells me that the parameter has been calculated. And so if I save, I can see in general that my result in the qualitative assessment is that this asset is on 5A. Yeah. So in the qualitative, the software stops here. There is no calculation of effectiveness. There is no indication of the type of inspection or the percentage of coverage. This could be only interpreted by the person who did the grading here, and based on that risk ranking, what will be the recommendations in order to mitigate the risk or create an inspection plan starting from a qualitative assessment. So this is a more generic evaluation of risk, but we can have both. And as you can see, if we exit this analysis, now on our exchanger 2693, we not only have results for a screening, that is the qualitative that we just did, but we also perform an analysis on a quantitative assessment that you will be able to visualize here. Sorry. It will be, let's find this in the IDMS and see what we can see about it. Okay. There is an area for this one. Let's see. Let me reaccess the software. Let me see if it refresh. Because what I'm expecting to see is how to visualize the two results. If you have a qualitative and a quantitative of the same asset, I want to show you what to do in that case. The consequence area is not being transferred. Because I have to close the study. The study. Okay. The result here that we had for I'm missing the risk value for the RBI date in the quantitative. So I'm just gonna check inside the calculator to follow with the result. Yeah, I believe that since I close this, I cannot reevaluate, but if I set as open again, yeah, I enter here. By the way, I'm gonna take this chance to explain you one more thing. When I open the calculation for this particular asset, and I change a parameter, like for example, I change the allowable stress to 50. I can see if there is any variation on risk because of the parameter that I changed. So, for example, if the management or if I change something like this to say that water is not present, you can see that there is a yellow indicator that is telling me that from 1.5 it goes to 0 if I make this change. And if I put it back, so it's in real time, you can see what is the impact of changing some of the parameters into the risk calculation, if any. So if I select yes here, I can also see the change in the parameter. I'm gonna save like this. It will change because in this case the risk will be 0. We have a consequence, but it's 0 here. I'm gonna recalculate this. Target date should still be over the 25 years. And the inspection date, I will add it after this. An automatic inspection plan. Be safe. I'm gonna exit this now. So this is what I wanted to show you. If we perform a qualitative assessment, we also perform a quantitative assessment. We can have both results for one asset. How does that look in the management of the data? If we exit and we visit our equipment, you can see that I will be able to find two different types of calculations. One of them is for screening or qualitative, that gives me a position of 5A, and the other one is on consequence. Both of the analyses were performed on the same date and under the same project. So what the software is going to show me is the highest risk based on whatever methodology I'm using, especially on the summary here. If you have more than one RBI project, it will list them all over here, and it will show you the change of risk over time. You can change between the screening result, consequence area, quantitative results, or the financial consequence. We were reported an issue of translation here that we are fixing. Just for your understanding, this the matrix type balanced and unbalanced is what we discussed in the presentation. Balanced would be this distribution of risk to visualize the result. Unbalanced would immediately change it and show it on this way. In the screening, we can do the same, balanced or unbalanced. For the screening, it seems like the only used matrix is the unbalanced, but for the quantitative, you can change between the two, depending on how you would like to represent your results. Okay, so from the RBI management tool, when we perform a study like this, we can do a reassessment also. So there are different ways to do a reassessment. You can either set up, or in fact, you need to set up a new project. You need to do it on a different date. That in this case, I will need to close any of these old projects to make it today, for example, and I can import the existing data from those to be able to change only the variables that change over time in the analysis. You just need to make sure that the project is closed and that I can import the data from the previous report. Let's have a look into how to do that. So, for example, let me try to do a reassessment with our own project. The status of this project is still as open. So, excuse me 1 second, please. So, since our status is still open, we can select to close the RBI study. So I'm gonna close it here. It is telling me that some of the sessions are still open if I wanna force close anyways. If I say no, I have the chance to have a look at my report here. I can see that all the session status is open. I can close it from here. So I can do a multi-select. And then edit to send it as closed. It has to go through all the stages. So go here. Then once again, select all, go here. Select all, go here. Now all the assets are closed. Once we close the study, we can, from the RBI Studio, we can close our analysis by clicking edit and then close study. And now the study has been closed. Notice that I can select this filter to show the closed studies. This one has been closed. We have the status as closed. So when the status is closed, we can do a reassessment on all these assets. So how can I do this? I can create a new analysis. I'm gonna call it, hopefully doing it on the same day the software allows it. Let's see. The description, I'm gonna call it PT KPI RBI Training 2. Okay, now I have an open project that is the reassessment of my previous one. I can just save this. Well, let's do the study configuration. Select the same damage mechanisms. And then activate the qualitative, save. And if I exit, I can look here under my studies on my new reassessment project. There are no assets, but what I can do is using the RBI management tool, I can use this option that is called import data from previous study. So in order to do this, I have to first declare which items need to undergo this process. So in management, I can see under my asset list that it is empty. So I need to make sure to add the same assets as the previous study. I'm gonna use the drag and drop option to put them back in the study. So it was the 4 exchangers, my 13 pipes, and the safety device over here. Okay, now I'm gonna save and exit. Now if I select this, I have an asset list that if I select all and I ask to import the data from the previous study, you can see that the data that we used for the previous analysis has all been imported. There is no calculation yet, but all the basic data that we previously defined in our previous analysis has been imported. So now you have the chance to say, okay, I can export this to Excel, fill up or replace the values that change over time, re-upload, and then automatic calculation. This is how you perform a reassessment. You can use the data from the previous time to be able to change only the parameters that change over time. The rest remain the same, so the data loading is much shorter at the reassessment period. In fact, for these two that we have already populated the data, we can perform an automatic calculation like this for area. So again, with the multi-select tool and the automatic calculation from any of these two categories, we can do a risk assessment calculation. And the software will provide the results for each one of these rows. So number 1 was executed. Now it goes for number 2. And as soon as it's complete, we will get a prompt saying that the calculation has been executed correctly. Like this. So if I refresh, we can see in our result area that the calculation here has been performed. This is the way to perform the reassessment. We can also, from here, when we have a high number of results, like for example in this assessment, where many of the assets already have an analysis performed, another useful thing is that if I use the multi-select tool and I select a few of the assets, I can print the reports as, let's say, PDFs or so I can have a look at the different reports as PDF files. The same that we can do if we do it directly for one asset inside the calculator and the printer. So we can save it as a PDF and then deliver or share. Now, from this printer right here. This printer is for only one report or one asset, and the one outside is for multiple reports at the same time. Let me show you what happens now that we are accumulating a few analyses into our training plant unit. So we can see that whenever we have an additional study, the first one was the first session, the first assessment, and then we did a quantitative one, well, it was a reassessment. So I can see the two analyses here and the position of the asset on each risk area. Only one was analyzed, so that's why it's visualized like that. But for example, in a plant unit that already has a bigger results, we will see it in this way. But in fact, I have exited the module for RBI, and I am back in Palladio IDMS. So as soon as we finish our RBI analysis, we can visualize the results of the entire plant unit that was undergoing the RBI project. So we will select the date of the study, and we will see the distribution of low, medium, medium high, and high risk of the assets within this pie chart. We will also be able to see the distribution of the assets in a future without inspection. So you can see here that part of the assets are going into high risk. You can see which assets by right-clicking on the matrix, and it will give you the names of the assets and also the possibility of finding them in the asset list, or the future with inspection. So look at how the pie chart changed from present, future without inspection, and future with inspection. Yeah. So this is a way to have a general view of the distribution of risk in the plant unit. If we enter the plant unit and we expand the asset list and we activate the RBI visualization mode, we can see an indicator next to the name of the asset that says this particular asset is under this color of risk, or this risk area that is assigned with this color that represents a level of risk, low, mean, medium, high, or high. Whenever we select one of the assets, we are able to see the single matrix for that asset. And if that asset has an analysis complete, here on in the indication side, we will be able to see the summary of the recommendations. So let me find a better example. Maybe here. Okay. This one. Okay, so as you can see, when we select one asset, it will tell us, okay, on the right side, it will tell us the results of the inspection plan. So It will tell us information about each damage mechanism that was detected. It will tell us the inspection details that are recommended, and this is in the RBI tab of the asset. So as you can see, in the IDMS, all the results of the analysis are automatically transferred at the end of the analysis, and you can visualize them on the RBI tab. So as an example, this particular asset, you can see the present risk calculated, future without inspection, and future with inspection. You can change between the ISO risk matrix and the risk matrix. You can see it in a balanced and an unbalanced matrix. And you can understand if you had a qualitative, you could see it here. On this one, there is only a quantitative analysis based on consequence area, and that's the result that we will see. In terms of here, we can see that we have detected sulfide stress corrosion, and then we have thinning, and we have hydrogen-induced cracking for this particular asset. It will tell you what was the value of the damage factor calculated for each one of these detected damage mechanisms. It will tell you the last time an inspection was executed for this type of damage mechanism, and what was the effectiveness of that inspection. So we have a total of 2 inspections, one executed in the past of high effectiveness category, and a future inspection in 1A. So also a highly effective category inspection to be scheduled. What are the inspection details? For thinning, these are the recommendations based on API 581. For this one, we have also the recommendations here. So we can directly understand what are the recommendations in terms of inspection for API 581 for a particular asset directly from the RBI tab. Furthermore, we can see that, let me go back to an example here. All these risk matrix at the plant unit level are connected with our asset hierarchy in our IDMS. This means that we can right-click and click on any of the assets here, and it will find it for us in our asset hierarchy, allowing us to visualize the 3D model, the position of the asset in the PNID if available, the data sheet, the attachments, the inspection history. And this is how all this data is being tied up, and these are the different ways of managing the data. If we go to a plant that, let me find a good example here. A plant that has a 3D model, and we can transfer to visualize the location. We can transfer the colors of the risk matrix into the 3D model to be able to understand the location of the assets that have highest risk. So by right-clicking on the plant unit, I can ask, sorry, by opening the plant unit and right-clicking on one of the asset types, I can visualize the risk matrix if available. Sorry, I think this one was done with a previous assessment style. Make a slight change here so that we can see this. Yeah. And what I can do is I can end up transferring the values of risk into my 3D model for color coding purposes. So with this example right here, I can load the 3D model. I can load my risk matrix. And I can visualize the distribution of risk in my plant unit. While this loads, I would like to also to let you know that every time that there is an RBI analysis, we will have the possibility of registering in chronological order the assessment on every plant unit or on every asset that the analysis has been involved. So we can quickly switch to understand what was the difference in risk between our previous assessment and the current assessment. So, sorry, this server is not meant to load this model, but let me force it a little bit so that we can see it. Let me show it to you here. Okay. Loading it on my second screen just to finalize the demonstration. Sorry, 1 second. Okay. So when we load the 3D model, for example, we have the possibility of visualizing first the RBI matrix. Here we have the distribution of the assets on the different risk areas. This one is specifically for equipment. How do I get this? I right-click on the asset type and then RBI data. It will show me a matrix on the distribution of the equipment that have been evaluated on the latest RBI analysis and how they were arranged in the risk matrix. I can use my color palette that we saw on the first day of training, not only to color code by fluid, by PNID, by inspection type, but also by RBI. So by RBI, I can transfer these colors here. And now you can see that I can directly visualize all the different positions of the assets within a 3D environment that are, in this case, in medium high risk, because we don't have a high risk asset at the moment. Now, if I would like to know where is a specific one, I can right click on the matrix, select a name of the ones that are here, and you can see that now it's boxed in red. I immediately know the location of the asset. I can see the single risk matrix, and I also found it here. So I can see on equipment, the isolated view, I can see its PNID. I can see its data sheet, the attachments, the inspection history. and all the different information that we have loaded for this asset. So this is a way to, let's say, close the loop of how the results are managed after the assessment is completed. The other thing is in the scheduler, we have the possibility. Yes. In the scheduler, we have the possibility of visualizing the RBI dates that were calculated. So, for example, for a list of assets in a particular plant unit, I can see the date in which the RBI assessment was calculated, what was the result of RBI, and based on this, I can also see, I can also load I can see the inspection plan here. If I double click here, I would immediately see the different activities that are being suggested for me on this particular equipment based on the RBI results. This gets into the scheduler, and so based on this information, I can compare, for example, with my time-based inspections that are in other columns, to decide when is that actually I need to define the final plan date or the moment of inspection. This final date is not an automatic assignment. It's something that we just provide this scheduler visualization so that you can compare in parallel the date suggested by the RBI next to the time-based inspection normally scheduled, and define a final plan date based on the results. So this is the let's say the order of ideas to achieve a correct management of the RBI results in Palladio. How does a PDF of the report looks like? That is another thing that, for example, in a plant unit, when you're looking at the RBI section and you have these results, this is not the only way to visualize results. If you go to item list, you get a very simplified way of the results. You have the item, the component, if any, and then the current risk matrix position and the calculated risk based on area or financial. In this case, it's area. Then future without inspection and future with inspection. Very simplified, very useful for reports. You can always export this as an Excel file, and then you are able to add more information or modify based on your requirements. You will be able to you will be able to see the different results of your report just like this. So you can add more information, extract data from this visualization. You can also use filters to filter this as any Excel document. So you can select to hide a few of them if you need to, or you can use the matrix filter column to say, okay, I am only interested to see in a future without inspection which ones are medium high and high risk, for example. So you will see that in a future without inspection, all these assets, sorry, with inspection, all these assets are still in medium and high risk. you can even go more specific on the filtering of the results by saying, I want to find an asset that the future without inspection is high and the future with inspection is medium high. And the software will find that scenario for you. So this is good because these are examples that justify the value of the risk assessment, showing, like, for example, if today you are in area 1E, if you don't perform inspections, you will be in 40. And if you perform the inspections, you will be in 2E. There is an increase on risk over time, which is normal, but at least you are staying in a medium high instead of a high risk level in 2 levels of probability. So it's a good progress in this kind of example. And also on this plant level, you can have the matrix, you can have the item list, and you can have attachments. So some of our clients, what they do is the PDF reports that they generate on their asset, they load them here just as attachments so that they have them for reference of the assets that have been analyzed on this particular plant unit. So this is, let's say, the most general way of describing the RBI tool. I would like to pause for a minute and ask you if you have any doubts, any questions.
Mr. Alberto, when we analyze, when we begin RBI analysis, usually we will determine the corrosion circuit or inventory group first. Where do those two things being used in the software?
Yes, that's a good question. So you can start also, you can do analysis on corrosion loops or different grouping of systems. I remember we kind of covered that during ITMS. Let me finish this one here. Just yeah. So remember that here on system, we have the possibility of creating corrosion loops and circuits. So in an RBI assessment example, sorry, on the demo plant, this functionality is not active, but I'm sure in your database it will be. I'm going to show you here. On the system section, you can create a corrosion loop of your different items. So I'm going to, sorry, let me create something quickly here for us. It's a demonstration. So maybe it is also a refresher. This one. Okay. Let's imagine we have these two assets. We have, well, a complete asset list. It's just to avoid creating these from scratch. And this is visualized through the plant unit section. If we go to systems, we have the possibility of bringing from this plant unit section groups of systems of different asset types and classify them as different kind of systems, like inventory mass or a corrosion loop or any other kind of grouping. So to create a new system, you right click on the plant and click on circuit management. Then here I can edit and click new. The ID will be populated automatically, but here I want to call this, for example, PT KPI corrosion loop. And then when I save, I can exit and access my corrosion loop. My corrosion loop will have a data sheet. And in that data sheet, I can edit and define the type for it to be defined as a corrosion loop. Then I can select the plant unit from which I will select the components of that corrosion loop. So in this case, ours is PTKPI. And I can start selecting an item type, like for example, equipment, and go to item selection. So the only equipment that we have in this unit is this one. When I click select, it becomes part of this corrosion loop. I can select a different asset type, like piping, item selection, select the line, click select. Now the line is part of the corrosion loop. This is how you define the corrosion loop in Palladio. Now, how do you use this in an RBI assessment? If you go to RBI management, in the same way that we bring an equipment as part of RBI analysis, we can bring a corrosion loop. So I'm going to use this analysis. Go to management, find my analysis. So this one. And I can use the allow item drag, edit, and then I can bring this PT KPI corrosion loop here. So notice that now it is part of the analysis, of the RBI analysis. If I save, I will have a sheet here for corrosion loops. Let me refresh. And on this one, notice that in corrosion loops, only the qualitative calculation can be performed, because quantitative is specific for each asset. Now, we already went through the different questions that are applicable on a qualitative assessment, but that is how we will start the calculation for a corrosion loop. So it will just give us a generic position of the risk area in the matrix for the corrosion loop that we have added and that we want to analyze. Actually, the one we added is this one here. So it's the same process. We just create the corrosion loop through the system field, and then drag it and drop it into an RBI analysis, perform a qualitative calculation. Please remember that the idea is that for assets for groups of assets, like a corrosion loop, for example, you perform qualitative assessment. The quantitative goes for the components of a group that need higher level of detail, and that's why you perform a quantitative assessment.
Okay. So if we want to get detailed analysis, we didn't need to use corrosion loop.
Yes.
Okay.
Another thing that could be useful is that if you decide to acquire a service of PNID loading, we can help you with this kind of scenario where sorry, let me find an example. I don't have an example, unfortunately. Maybe let me see in the server. But as shown in this image right here, something that we can also display in the software is if you have the PNID that you are using to mark the corrosion loops, we can do something like this where the routing of the different corrosion loops can be highlighted into the drawing that is loaded in Palladio. So if you decide at some point to upload the PNIDs, we can also mark for you the corrosion loops, so that you can visualize them through the system module.
Okay.
Okay. Okay. Any other questions?
For inventory mass, is it the same as corrosion loop, only qualitative RBI analysis? Or
Sorry, say that again.
for inventory mass or inventory group, is it the same as the corrosion loop? Can it get detailed RBI analysis or qualitative only?
For the inventory mass?
Yes.
No, for the inventory mass is not a group that you analyze with RBI, but it's actually a value that you need to consider in the RBI assessment. So when you define assets to be part of a group, you can calculate the inventory mass of that particular group. So,
okay.
So let's say here on the template, you will be able to define to which corrosion loop in column O, which corrosion loop does the asset belong to. And for the ones that have matching description, the system can calculate the inventory mass that is normally required in the analysis in some cases for the consequence area analysis. So that's how that comes into play. The value that is calculated for the inventory mass will be transferred here from the calculation if you do it through the software. If not, you can, if you are doing it elsewhere, you can transfer just the input. So it has these two ways. To calculate an inventory mass, you need to make sure that the asset has been defined as part of a corrosion loop, sorry. And what we'll do is when you select this particular file, there is a tab here for inventory mass. And if I select the inventory mass calculation here, I can click on the load data. And there will be a calculation of inventory mass for the particular asset, considering all the different assets that are connected to this particular equipment, based on the inventory group mass 1. Okay. In here, we can also recalculate that. And if we go to inventory mass, you can see these are the different inventory mass groups that these assets belong to. Those are defined into the systems as well. And here is the inventory mass calculation for every one of the assets. To stop this calculation, you need to uncheck this box, and then it will be just saved like that. To define an inventory mass, the same process that we did on the corrosion loop can be used. We can do it through systems by going to circuit management, defining an inventory mass. And then adding some assets, or we can do it directly through the Excel file. Actually, this one, as soon as you define that this is an inventory mass group and you save, notice how all the fields get locked. Everything gets locked. You can no longer change anything, because every component that comes into this inventory mass needs to be assigned through the RBI assessment. So it will be considering the groups that are defined in the Excel template in the inventory mass section. So we will populate here on column M the name of the inventory group. So you will consider this IMV mass, this same name, and that's how you will declare that these components belong to a particular inventory mass group. Okay. So this is the way that those groups get assigned and the calculation is performed. Independently if they are piping or equipment, is gonna be the same.
Okay. And also, Mr. Alberto, supposedly if we want to do RPI analysis on pipeline, and that pipeline is belong to the same corrosion loop as the another pipeline, can we use the same input data for that pipeline for the damage mechanism and another input?
Well, theoretically, yes. If it's part of the same corrosion loop, it means that it's exposed. The reason why it's part of the same corrosion loop is because they have common parameters, right? Like the material, the fluid that goes through it, and so most of the data you can reuse. But if there is any parameter that is changed, then you need to put it as another group. Also remember that in the analysis of corrosion loops, there is not really questions that are related to specific information on diameter or stuff like that. It's mostly questions that are in a very generic status, like, for example, are you analyzing a unit, a corrosion loop? How many equipments are you considering? What is do you know if these following damage mechanisms are present? So nothing very numerical about the properties of the components within the corrosion loop. So even if the values change a bit between the components, you are analyzing it as a group. So the questions are very general. You don't need to worry about the details of changes in parameters, but most likely those will be common in the group. So that's why you can define it as a corrosion loop. For the single analysis on a quantitative basis, you do need to pay attention that the parameters may change between an asset and another, even if they are in the same corrosion loop. Not the operating parameters, but maybe the design conditions. There might be a difference in diameters or even asset type. An equipment and a pipe could be part of the same corrosion loop, but they are completely different assets. So you will need different data. But on the qualitative level, it's fine.
Okay.
Okay. Anything else you would like to discuss?
Sir Alberto, I want to ask.
Yes.
Adel.
Sorry.
Sir Alberto.
Yes.
Could you hear me?
Yes, I can hear you a bit low in volume, but I can hear you.
Okay. I want to ask you, could we import 3D model from other resources?
Yes, we can. We do it as a service, but basically, if you have a external 3D model, we can convert and import into the platform. Normally, the model format that we will look for is to be able to take your model and extract it in a PCF format for piping. PCF is a format that is neutral, that is called piping component file, or IDF, that is temporary files that are created in the modeling process to create that are based from isometrics. That's for the piping, and for the equipment, we use RBM files with the attribute files to import the properties and the division in parts, so that it's not a unified model, but it actually has all the different components.
Okay, so we have to convert it first.
Well, I think we can consider as part of the service let's say you have a CAD Works or a AutoCAD or a Smart Plant 3D model. You can hand it over to us, and we will let you know what does it imply to do the full conversion and import into the platform.
Okay, I got it. Thank you, sir.
Okay. You're welcome. Any other question? Okay. Well, I would like to thank everyone for being part of this training. I know.
Sorry, Mr. Alberto. One
Yes.
last question. It's kind of out of topic on the RBI analysis.
No problem.
Is there some kind of documentation of the soft copy of the training module for this?
Yes, we do
session?
have some documents that I will share with you. like for example, the document that I was showing you earlier that
Yeah.
points the position of the
Yes,
of the data. So I will make a compressed folder with with all of the documents that I have that I consider could be helpful for you, and I will send it to you so that you can share with your team.
Okay, thank you, Mr. Alfredo.
You're welcome. Nonetheless, please remember that under your software license, the first year of service, you have let's say included hours of support. So I know that we discussed a lot of things in 2 days. It's gonna take a bit of time to practice and to actually go through the software. And for sure, I know you will have a few more questions. So feel free to contact us. We are here to support, and I hope this session was useful for you. That you learn how to navigate and use the main functionalities of the software. And we look forward to support you in this project. And so thank you for your time, and feel free to contact us for any future information.